Okay. So, good morning, everyone. We prepare to start. So, just a few seconds in case someone from outside wants to get in quickly. Anyhow, many thanks again for coming to the Kamailio World. Is the 13th edition actually. We had 3 online, so that will be this one will be the 10th on site. It's again a new venue, so in the last 3 editions we jump it in different places. Unfortunately, the one from last year, the hotel closed. It was a Novotel. Many of you were there last year. We are now by another Novotel, a better position in terms of location in Berlin. So we are close to Alexanderplatz. It's a little bit smaller, but we fit in, so the room is wider. We should be more or less the same capacity like last year. If you have any questions, you can find me, Ramona, or at the front desk about surrounding or about the event. I think people got in, so we can officially start. So again, warm welcome from myself and Ramona. Probably you interacted with her when it was about the registrations and other questions. As usual, we start with a bit of a presentation of what's the event about, and then I will continue with what happened, like a summary on during the last year with the Kamailio project. First, of course, we want to give a big thanks to all the sponsors. Some of them came kind of last minute, so they are not all of them printed on the roll-ups. But anyhow, really big thanks, because this year, maybe you noticed in the agenda, we have a really packed one, more speakers than usual. We had to dismiss several, but it was hard to not accept those that we have on the agenda, because many of them were very interesting about scalability, security with Kamailio, and not only artificial intelligence being also something like a big topic these days. So a couple of presentation will be shorter than usual, 20 minutes, and the rest will be the usual 30 minutes. So yeah, we have again the guys from Sipgate, and they will also run a session where you can participate with Kamailio code snippets. From France, Dubovikov, and from Austria, it's Andreas and the Sipfront guys. The professional team with audio video here, helping us always with technical problems whenever they occur, usually not. Pascom, coming from south of Germany. Federico and Libon, supporting us once again. Snom, Mark is here. He will show some devices at the front desk a bit later, but he will also give away some of the very, let's say, beloved, at least from my point of view, Snom devices. From the development point of view, they have very nice tools to troubleshoot signaling also on the client side. Tyler from the SIP router project, it's also here. I see, I forgot Mango Voice, sorry, I'll have to add it here. They come from US, quite long distance, but I think Mango I printed. Sorry, my mistake. I'm not sure why I forgot it here. And Simon and David Duffett, it's also supporting us. Then we have the friends from LOD. Fred is here, and Glucon, Giacomo and Signalwire, API band for security, Fred again here, and we are organizing as a Sipto company. Short about the structure, it's also online. We had actually the first change of the agenda as Professor Thomas Magenaz informed us last minute he has a conflict. Ramona will take the slot and present a few slides about what they do at the Technical University and then continue with the technical presentation she prepared. And then Giacomo, which was scheduled tomorrow late, is going to replace Ramona in her slot that is on the website. So far, only that change. I think most of the other speakers are here, and we don't expect any other changes. We'll have a cocktail party with beverages, alcoholic, non-alcoholic. We'll have beer and wine. This evening is going to be in this hotel in the restaurant area. So we'll have food to eat, like dinner, and then drinks around. So everything happens in this hotel. During the breaks, should be outside coffee, and not only during the breaks. When you need, the machines are outside. Beverages are at the back of the room. Probably you noticed. They should be during the entire day available. As interactive sessions, we will have Randy, I haven't spotted him yet, that wants to do kind of discussion. Should be here soon. Of course, artificial intelligence. And tomorrow morning, we are many Kamailio developers here, so I don't know, 10 or even more. That should be around. So this would be like open discussion, ask anything about Kamailio, what is now or what are the plans to do in the future. And then probably after me will be Jonas and will provide more details, but the guys from Sipgate will have tomorrow this Kamailio config snippet challenge, where yeah, you can submit it. I'll have the link a bit later. Or no, it's here, sorry. If you go to this link, it's also in the main page of Kamailio World website. And if you have an idea to submit, I don't know, 10, 15 lines of Kamailio config file, then the audience will have to guess what you wanted to do with that, what kind of operations. And will be some prizes for the one that guesses, and if it's something that nobody guesses, then probably the submitter will have to get the prize. And depending on how many are, we'll do probably some ranking, or let's see how the registration for this challenge look like. There are already a few of them, but everyone here can still submit if you have ideas. If you want to participate in any social media discussions, I'm not sure what's now for microblogging, Twitter, Blue Sky, Mastodon. I'm not much that active in them like I used to be in the past. There is a LinkedIn group for Kamailio and a Matrix group that is run by Fred here. If you want to learn more about Matrix, you can approach Fred to give you more details. For the live video stream, again, thanks to the Pascom team, it should be live now. If you go to the Kamailio World YouTube channel, it should be on the front page there, the streams. And you can, for today and tomorrow, and yeah, you can pass it to your colleagues. Later, the recording will be available, so if you want to discuss with someone during the event and you miss some presentation, don't worry that much. You can watch it later, because coming here, one of the main benefits is to network between you, figure out what others do, and maybe they can help you or you can help them. besides that, as I said, the content will be published afterwards and you can look at it again. As every year, we will want to clarify it again about this VAT, which we are forced to charge it for all the registration because it's on-site event. This is German and European regulation. And you should be able to claim it back. If you are from a German company, that's very easy. And also from European Union, should be easy. For the other countries, I'm not sure what's the procedure. You'll have to check with the accountant in your company or in your country to see what's the procedure. And usually it's not only this VAT that you can claim. I think you can claim also for the hotel and other expenses you had while having this business trip. But again, it's up to checking with the laws in your country and the procedure for it. For Germany, as I said, and European Union should be straightforward. We are not responsible for your belongings. Normally here should not come anyone, but we don't have like security and checking digital badges. And you see we are very close to the elevator, so someone can come in. So be sure you have your belongings under your eye, and the important one at least, laptops, IDs, wallets, because we can't guarantee for it. And we want also, and maybe here Ramona can add a bit more, Wednesday, for those that haven't noticed yet, she hosts at the Technical University more like a demo showcases with mobile technologies. I'll also be there to demo Kamailio as maybe OTT from that point of view service. Why it's there? It's because of the spectrum, 5G spectrum, that is not possible to get where you want for testing. So maybe
in Germany, you need a license for turning on the base station for private 5G networks. But what's the good news that this is, the good news since a few years is that this spectrum is licensable. So every small company can apply for it, and okay, you have to pay, but it's not the end of the world for having a license for a small private 5G network. But at TU Berlin, we have this license because our chair is also a member of a bigger alliance, 5G Berlin, and in the entire campus we are allowed to use the 5G frequency for private networks, that is 100 megahertz between 3.7 and 3.8 gigahertz. So therefore we can put this workshop with live demos on Wednesday for everybody that is interested. We will have demos from our chair and some presentation from other companies in this space of 5G, 6G. And of course the students, because our main focus is sharing the knowledge and come closer to the students and make them an easier understanding what the mobile networks have become today and how they can get in touch with the technology. Okay. That would be.
Thanks, Ramona. So you can approach her also during the breaks to give you more details. And that would be the introduction of the event, the structure, and what's going to be around. I'm going to continue now with what happened for Kamailio project during the last year. So we have like 24 years of development. We're going to mark it a bit later this year, which means next year is going to be sort of a celebration. We have quarter of a century with this project under development. More detailed, let's say, timeline for those that are new to the project. And when you search on the net, you see various names for like a SIP proxy, like SIP Express Router or OpenSCR, which is now Kamailio. So they are all related. There are some forking, then merging back. And for quite a long time, it's only Kamailio, marking the last release, which I will have some words about it, happened in January, like major release, because then we have like bug fixes and we do minor releases from each of these series. Everything started here in Berlin at the institute, Fraunhofer Focus Institute, which used to host our event for many years. That space became also unavailable, so we had to move to hotel from last year. So yeah, new in Kamailio, we have this series 6.0, so practically what was supposed to be 5.9 series, we decided to jump directly to 6.0 because there are a couple of major and very important changes. Here I'm listing the new modules. They don't really have the main impact in shifting to 6.0, but with every major release we have a couple of modules. Quite important would be maybe the support for HTTP2, which is very or necessary for 5G services, for implementing the N5 interface and so on. PVTPL is something that I become used quite a lot, especially when you need to build some document using variables from the config file. So you can have in a file text with Kamailio variables, and then Kamailio will evaluate. So instead of building, for example, a JSON with config operation like concatenating strings, you can put it in a template file, and then Kamailio evaluates, and could be like simpler config or easier to maintain. Support for hash table backend for topos, this topology stripping, like making it to look like a back-to-back user agent. I think it came from 1&1. Lucian is here from that team. Victor, which is not here, our one of the very active developers and the packager for Debian and Ubuntu, added this present support for device feature key synchronization. And Dragos, which is the initial author of the IMS modules, should be here soon, I guess. Lives in Berlin, but probably had a long party last Sunday, last evening. He contributed this module, but it's about quality of service. Here are the other main feature that I wanted to highlight. Actually, there are many, many more. It's like a couple of pages that you have to scroll in our wiki to see all the enhancement for many existing modules. But what made it us to go for this 6.0 would be this multi-threaded UDP receiving mode. I'll have another presentation where I will focus a little bit more on the transport layer, covering this as well. This is useful when you have a lot of UDP sockets. If you know, Kamailio creates for each UDP sockets a pool of processes. And then this could reach limits like MySQL connection or use too much memory. And sometimes for a socket, you don't have much traffic that worth having these processes. And now you can say, okay, for these sockets, create a single process and threads to read from the socket, which will push in a memory queue and will be a single pool of processes handling that. A little bit similar to what TLS, TCP handling is done. And you can mix it. So for a socket, you can stay with the former or the classic multi-process. And with other sockets, you can switch to multi-threaded UDP receiving mode. The internal libraries are linked directly to the core. There were dynamic libraries before, but it was more complex to package and load time and dependencies on some systems. So they are still in their own folder, but at the compile time they are linked directly. From Xenophon we got this new build system, which is like an alternative, but we want to switch to it. It was quite some work, but it's more modern and should be easier for the future to maintain, because our old makefiles got quite complex to support many compiler versions and so on. Alexandr helped quite a lot when we did developer meetings in Düsseldorf, hosted by Sipgate. Then you can also specify a range of UDP socket ports to listen on, so you don't have to put like 10 listen if you have ports one after the other. Sometimes when you, I don't know, connect all PBXs, you might need to listen on different ports for, I don't know, firewall rules or other things. Now you can say listen from 5060 to 5090 and it will be like 30 sockets created by Kamailio. Quite some work on HTTP support for HTTP2 also on client side and supporting more methods to be more flexible there. A lot of new variables, many related to SDP, PTR query for the IP ops module, ability to load in the DNS cache from a file, so not only with mod params. So you can run in some situation Kamailio with its own DNS cache and everything preloaded. And also kind of Kamailio can act a little bit like an HSS now for mobile networks for authentication, to generate this authentication vector for AKA, which is specific for SIM-based authentication. This is the old stable. It was actually covered last year. I just kept the slides to highlight that we maintained the last two stable version of Kamailio, like series. Now it's 6.0 and 5.8. So I'm not going over the details. They were presented last year. It's still a maintained series, so if you use it, it's no problem. Bug fixes are going into it. In the ecosystem, to come to a wrap, we did again our developers meeting at Sipgate in Düsseldorf. Probably we'll do it again this year. Usually it's November, late, maybe October sometimes, depending how it fits, and not overlap with other events there, and also have developers available for traveling. It's a nice event to be, so we sit in the room, they take care of everything like drinks, food, social event in the evening, and we brainstorm, discuss code, like, code for Kamailio or documentation, so it's a nice event. Then being discussed for many years, the options, how we can collect some funding to cover some, let's say, infrastructure, but not only, maybe to fund some projects like developing for Kamailio. Thanks to Victor Seva that spent time on looking the options. An option was to make a foundation, but requires quite some bureaucracy with, people to take care of it, manage the accounting for it. So this seemed like a best option with Open Collective. We could get like a European-based fiscal host that can take care of it. We just started. We got some funds there already, but no expense yet. We have to figure out in our core developers group, management group, how this goes on. Another new in our ecosystem will be the new Cyremis. So we had the one written in PHP, which was somehow sponsored and maintained by Acipto, but it was using some old frameworks, and with PHP 8, it was hard to upgrade it. So the decision was to rewrite it, and we went for the Go language with the Bootstrap web UI. It's kind of functional, not well tested. It should be easy to add support for management of new database tables. So you don't have to write code in Go for management of a new table. You have to describe that table in some JSON. What are the columns, the types, some transformation you want to do to the values, similar to the old one. You can also print some charts. So again, it's early phase, a few months, but the last one I didn't have time to spend on it. But if one wants to use it, should be good to go. Some enhancements to CamCLI that for a long time we tried to replace CamCTL, but we are not there yet. But if you need this feature like tab completion, history, suggestion from the previous comments, this is a very nice command line tool for Kamailio. Then for those that have to deal with the identity, the stir shaken, I'm pointing to my project also on the Acipto, the SIP ID. We have another module in Kamailio, but I'm not sure how much it's maintained. The developer is not that active using lib stir shaken, that's C1. Here the library is in Go, but thanks to Victor, everything is packaged. So if you use Ubuntu Debian, you can install this from packages. You don't need to compile the library yourself. Besides the library that is used by Kamailio module, you have some command line tool that you can use for testing this stir shaken, as well as running as REST API server that gives you the stir shaken validation or the identity header. So I know that US, Canada, and started to Europe, in some countries, maybe some variations, but it's getting here as well. UK and France, I think, they push towards this. Resources for our project. Most of you probably know about them, just to wrap up. And yeah, once again, thanks to our sponsor making it possible to run again and have many sessions from people working with Kamailio or with other projects or technologies in real-time communication. Yeah, last year, hopefully, we'll be able to celebrate it. We missed the 20th anniversary because it was pandemic. We did some online event, but next year maybe we can make it a little bit more like an on-site party for this project developed for 20 years next year. So thank you for coming again, and by that supporting the event, by your presence, not only sponsors but the attendees make the event very important and valuable. To the speakers, of course, that they take the time to share their knowledge and travel here. So yeah, a big thank for everyone that is here and supports the event. Thank you. Thank you, Sipgate, for supporting us. The floor is yours.
Okay, check the microphone. Yeah, it's working. Welcome, everybody. First of all, thank you, Daniel, for organizing this great event and having us here in Berlin. I want to tell you how we automated Kamailio updates at Sipgate. Few words about me and my employer. My name is Jonas Böttner, and I'm a voice engineer at Sipgate. I actually quit my part-time job as a ship captain a few years ago. Some of you might remember. What is Sipgate? Sipgate offers modern cloud-based telephony solutions with a strong focus on business customers. We provide a wide range of telco automation tools, including CRM integrations or intelligent call routing. One of our latest product directions is improving productivity for power users through great user experience, like call summaries and other cool features enabled by large language models. And Sipgate is based in the beautiful Rhineland in Düsseldorf, and we offer services to Germany and the UK. And from a technical telco perspective, some key facts. We maintain interconnects with all major carriers, at least in Germany. We are full MVNO in the mobile net of Telefonica. We run our own infrastructure from rack space and network to server hardware, and make heavy use of open source telco software. Our stack includes Kamailio, Asterisk, Yate, and RTP engine. And internally, we like to say hacking telco. That's our slogan for building telco products with open source tools. So let's start. Sipgate loves Kamailio. As you can see, we are using it a lot. On the customer-facing side, the yellow items, we use Kamailio as a load balancer for IPv4, IPv6, UDP, TCP. We also use it as a SIP proxy for interworking with carriers. We run Kamailio on all of our interconnects as a classic SBC. To connect the interconnection setups with Sipgate, we use a load balancer based on Kamailio. One of the more interesting setups, we use Kamailio as a gateway to extract parts of SIP messages, to write them to databases, or to produce messages to Kafka nodes. This allows us to replicate registration status to the backend systems. To fulfill lawful interception requirements, Kamailio sniffs SIP messages and triggers, let's call it, further interception handling. And another use case is the Volte-Media adapter. We transcode the RTP from Volte devices to Sipgate to prevent DTX issues. It's discontinuous transmission. I talked about that in 5 minutes, 5 slides on Kamailio World 2 years ago. Yeah, before talking about updates, I'd like to give a quick overview of Kamailio at Sipgate. Every Kamailio instance runs on a virtual machine. All our VMs using Debian Linux, and they are managed by an internal infrastructure team. We use Ansible, both for provisioning and for configuration management. We build our own Kamailio packages so we can ensure reproducible builds and know exactly which version we are running at a given point at any given point in time. Our Kamailio setups exist 2 times in development and 2 to 4 times in production. So in total, that adds up to 80 Kamailio instances at Sipgate. And when I counted them for this presentation, I was a bit surprised myself. Every virtual machine at Sipgate performs unattended upgrades. So we need to make sure our service handles that smoothly. We are a team of 6 voice engineers, and there's a lot of internal coordination to keep our setups as consistent as possible. And of course, every system provides observability with metrics, alerting, logging, and more to ensure we have operational insights. why should we update our Kamailios regularly? Debian releases a new version about every 2 years, so why should we bother updating our operating system? Security is the biggest reason. Updated kernels and libraries, fix vulnerabilities. Keep in mind, some of our Kamailios are directly reachable through the internet due to our bring your own device policy. We benefit from newer packages, which can bring bug fixes or performance improvements, and to stay compatible with our ecosystem, including continuous integration, continuous deployment pipelines, monitoring, and our logging stack. A real example, our infrastructure team drops support for old distributions from time to time. And if we don't update, we might eventually lose the ability to deploy changes or even reconfigure the network or something like that. Fun fact, I started with Debian Edge in 2007, and since then I've seen 8 Debian releases come and go. And to be clear, operating system updates aren't directly about Kamailio, but they are still part of the setup, and you can't run Kamailio without a solid operating system underneath. Most of the arguments apply for dependencies too. Security, performance, compatibility are the key reasons. And of course, Kamailio itself. Make use of new features or modules. For example, we needed a Kafka producer in Kamailio. A Kafka module was introduced in version 5.4. More features have been added since then. And bug fixes. Another example, some modules didn't play nicely with Prometheus monitoring, and in Kamailio 5.8 there was support for TLS info, or the WebSocket connections weren't counted correctly before Kamailio 5.8. Now let's talk about Kamailio. Where's the problem? After all, it's just apt install Kamailio and systemctl restart Kamailio, and you're done. So where's the problem? At one time, I stumbled across a talk by Dan McKinley, and the talk was about the importance of choosing well-understood tools and about valuing simplicity in engineering decisions. And there was one slide in that presentation that blew my mind, this one. And the corresponding quote was from Dan McKinley: "Operating a piece of technology at a professional level turns out to be really hard. It's easy to get started with technology, but harder to do a really good job with it. Installing or updating Kamailio is easy, but running Kamailio at a professional level, that's the hard part. We have to think about operating system, config management, package managers, deployment, metrics, monitoring, logging, alerting, testing, scaling, and a lot more." Let's come back to Kamailio updates at Sipgate. What are the challenges for us? We have an evolving operating system. Some examples: in Debian, the init system changed from classic init scripts to systemd service unit. The scheduled jobs once run via cron, and now we use systemd timers. Logging used to be go to log files with syslog. Now logs are pushed to a remote logging system and accessed through Grafana Loki. Over the time, our observability stack changed. We used Telegraph, InfluxDB, and Grafana in the past, but our infrastructure team switched to Prometheus. Log shipping began with Beaver, then we moved to Filebeat, and now we use Vector for that. And alerting, we have a really old Isinga alerting, but it's in transition to Alert Manager. The delivery stack. For deployments in the past, we used Jenkins, and we migrated that to GitHub Actions. We use Ansible for config management, but playbooks need regular updates. Another thing is downtime, but as mentioned earlier, we use unattended upgrades on all virtual machines So our setups are redundant and we don't have to worry much about downtime. For capacity, we operate at no more than 50% total capacity at any time. So this gives us what we call dual data center failover capacity. Even if one side goes down, the other can take over without performance issues. So we shouldn't have any problems with capacity too. And finally, test coverage. At the time of our first Kamailio updates, we had some end-to-end tests. They helped us catch major errors after a rollout, which was great, but weren't detailed enough to catch smaller functional issues. How did we do Kamailio updates in the past? We did them one by one. As you can see, the first Kamailio setup took from July to November 2022, about 5 months. After the second setup took about 3 to 4 months, the third one another 3 months, and so on. And after some time, the most important setups were updated. But the time span for updating some Kamailio setups ended up being 2.5 years. And there are still some setups left to update in our backlog. An excuse could be we had a lot of work to do beside Kamailio updates. Yeah, that's kind of true. We implemented VoIP for our mobile customers. We worked heavily on data center redundancy due to possible electricity crisis back in 2022, as you might remember. We evaluated and rolled out a new DDoS mitigation provider and a lot more. That's life, busy life as a voice engineer at Sipgate. But still, 2.5 years to update some Kamailio setups, that just felt way too long. This similar slide as on the one before. You can clearly see that at any given point in time, we had multiple different Kamailio versions running on multiple different Debian versions. For example, there were time ranges where we had 4 different patch versions of Kamailio, 2 different minor versions, and about 3 different Debian versions in parallel. Yeah, and some Kamailios were updated fairly regularly. Most of them weren't. What a mess. And it got even worse. Not only that it took a lot of time to go through all setups, we also ended up with heavily fragmented environments. During an update, we might implement a new feature like central logging or for just that setup. And over the time, we ended up with gaps between updated and not yet updated setups. And even worse, we had gaps between setups that were already updated, just not with the same feature set. And backporting of features became really difficult. It got so overwhelming that we actually organized all the features in a spreadsheet, as you can see. And as Confucius maybe once said, if you need a sheet, it's too complicated. And the reality is, we almost never found the time to backport features to earlier updated Kamailio setups. In the end, we had different Kamailio versions and different feature sets as well. Some Kamailio setups were containerized, some had central logging configured, some had meaningful visualizations on nice dashboards, and others didn't. Another example, our customer load balancers between IPv4 and IPv6, the setups were running on different Kamailio versions and different Debian versions because of a new Debian release. It came out in the middle of the 2 upgrade processes. We met for a retreat. We do this once a year. We met in person, even though we are a fully remote team. We did it offsite, and the overall atmosphere was good, but we were slightly unhappy with our progress. Biggest agenda topic was, even though we work really hard, our Kamailios are still relatively old. How can we speed up this? And the result was we need a new strategy for Kamailio updates. Everyone had great ideas how to implement new shiny Kamailio setups. We collected all ideas and wishes and came out with a long list of things we'd love to do. We agreed on a minimal feature set. Every task had to comply with our big goal, automating Kamailio updates. We selected the following topics and put them on our to-do list. Container, make sure that every setup uses the same Debian and the same Kamailio version to have a common base for all setups. Tests, to avoid breaking things during an update, we needed sufficient test coverage. By integrating with our existing CI/CD pipelines, we can benefit from automated builds and rollouts. We needed a good rollout strategy that lets us test changes on a limited number of instances, at least in the production environment. And finally, make sure we have meaningful visualizations and metrics to detect unwanted changes as early as possible after the rollout. And to stay focused on Kamailio updates, we put some tasks explicitly on a not-to-do list. Refactoring, monitoring, alerting, metrics, logging, dependency updates. All of these are likely to break after a Kamailio update, so we decided to do this afterwards. For now, let's focus on Kamailio updates, and after we've updated all the Kamailio setups, let's put the focus on, for example, alerting, but then let's adjust that for all Kamailios consistently. These are the steps you have to go through. First, the preparation, write tests. The tricky part about tests is to find the right balance between coverage and velocity. Remember, we are not doing refactoring at this stage. So if our logic worked on a previous Kamailio version, it's very likely that it will work on a newer one. And visualizations, make sure to have at least basic visualizations to detect problems, as I said. Then reconstruct Kamailio build process. We use Sipgate's generic Debian base image, build a generic Kamailio image on top of it, transform all Ansible variables from config management into environment variables, copy Kamailio config into the container to create a service-specific image. And finally, run all the tests on the old Kamailio version to ensure nothing broke during the Docker migration. Then let's update Kamailio in our integration or in our test setup and make sure everything still passes. And after the update, after we updated the operating system on the corresponding VMs, so updating virtual machines to the latest operating system is automated by our infrastructure team. We have to start an automated workflow and we receive a fresh VM with all operating system related settings from config management. Yeah, and once everything's tested and the base is ready, continue with the new rollout strategy. If you're interested in integration test solutions, my colleague Benjamin Tietz gave a talk at Kamailio World 2023 about how we build integration test setup, integration tests at Sipgate. Check that out. You can find it on the Kamailio World's YouTube channel. We improved that since then, but it still follows the basic principles. And another solution could be use a service like Sipfront. We have an example for that. Our end-to-end test setup doesn't support IPv6 yet, so we use Sipfront to cover that. This is our new rollout strategy. A build gets triggered by several events when we update the Kamailio mirror repository, or when the Debian base image receives an update, or when we make changes to the corresponding Kamailio config. Then the build step, a specific Kamailio Docker image is built, as described in the previous slide. And after that, unit and integration tests will be checked. When the integration tests pass, rollout to development environment starts automatically, and after that, run end-to-end tests in development environment. And when the development environment tests pass, we have to manually confirm a limited rollout to production. We manually check the visualizations for any irregularities, and depending on the type of change, we may wait for a grace period, for example, 24 hours for a new Kamailio version. And after that, the end-to-end tests in the production environment run again. In the rollout process, some tasks are triggered automatically. You can see that by the robot head, while others require manual confirmation. And to update, for example, Kamailio in production, we only have 3 manual steps. First, update Sipgate's Kamailio's mirror repository, then limited rollout to production, and finally, full rollout to production. That's the procedure, and it looks the same for multiple Kamailio setups. Same triggers for all of them. We split the container build per setup, with each one rolling out to different servers independently, and you get the idea for any number of setups. And another important point, the time from triggering the build to the first manual confirmation, that was the limited production rollout, is about 13 minutes. And since all builds and rollouts are in parallel, this duration is not multiplied by the number of Kamailio setups. So, every Kamailio setup has the same operating system and the same Kamailio version. We have a very good version consistency. We changed the rollout strategy from one after maybe another to big bang deployment. Every setup at once. We get immediate feedback if something isn't working. Faster deployment cycle, and no Kamailio left behind. The test coverage, because of the higher blast radius of our rollout strategy, we have to be sure that everything works. So we need a very good test coverage. Manual validation. Many steps, or most steps are automated, but we have manual validation steps to step in if something is fishy. And we have fine-grained observability with our visualization. And we have preparation for the next features. We choose to not change, for example, alerting in parallel to Kamailio updates. But now that every setup has the same base, we could proceed with the next feature. And the next feature will be easier to implement on all setups because they are more aligned. As a reminder, this was our old update strategy. We updated the setups one by one. And this is our new strategy. Every system needs to be migrated once to the new deployment pipeline. Those are marked with the small red rectangles on the slide. And after that initial migration, any system that already runs on the new pipeline will automatically receive Kamailio updates whenever we release a new version via our internal mirror repository. So when we release Kamailio 5.8.6, only 3 setups had been migrated and were updated. But our goal is clear. We aim to have most of the setups migrated very soon. That was our journey through updating Kamailio setups at Sipgate. Here's a quick summary. Make time for offsite retreats to get good ideas. Align your Kamailio setups. It reduces complexity and fragmentation. Limit the feature set to focus on updates. Remember our not to-do list. Write tests before updating. It saves you from surprises later. Automate as much as possible for speed and reliability, and rely on manual validation where needed. In our case, it's update the Kamailio repository and production rollout. And that was my presentation. Thanks for listening. If you have any questions or feedback for me, feel free to talk afterwards or connect with me on Mastodon. And also, one last thing, my colleagues Benjamin, Dennis, and Markus are here as well. You can reach out to them anytime. Thanks.
Thank you. Questions? We have time. We have here.
Yeah, thanks. I was just wondering, you've mentioned that you are testing like a mid-production, means that's a limited production layout environment. What is the purpose of this, means, and not having, for example, a dedicated stage environment for this? What's the benefits of rolling out just to production, even in limited quantities?
Yeah. Yeah, we had a lot of, in the past we had some issues with things that only occurs in the production environment because of the bring your own device policy. We have a lot of different user agents and we weren't able to detect that in the development environment. So a limited production rollout, yeah, you don't break all all instances, only a small number of them.
Okay, we have here.
I just saw in the presentation that you were shown the versioning in a XLS table. So, and I'm wondering, do you use anything to evaluate the software versioning, like automated system to evaluate it? Like maybe Ansible, Ansible facts or something like that to run all over the servers and get the version at the same time for the L. Yeah, we do this with normal Prometheus monitoring, and we have a dashboard for that at our Grafana. Yeah, yeah. But that was handwritten. It wasn't automatic. Yeah.
Okay, we have Sebastian. Tricky question.
Thanks for the presentation. From what I learned in the last year, when updating Kamailio or other software, the real problems only occur after you updated the last system. Because sometimes you break a feature and then due to round-robin load balancing and stuff, the clients choose the working old system and then and you don't notice it. And after you updated the last system, your customer support drowns in complaints. How does a rollback strategy look like?
Yeah, you have to have a rollback strategy. Yeah, but I know what you're meaning. Sometimes it's, I said we wait for 24 hours, but from time to time it took a couple of days until the support team came with some things. Yeah. You have to have a rollback strategy is my answer to that.
Okay, I think, thanks.
Another slide, if you're interested in the Kamailio Code challenge, here's a QR code for that. If you are lazy and don't want to type the URL.
Yeah, so picture that and participate. Thanks again, Jonas. And yeah, there are 4 guys from his team, the Sipgate, and they are available for your questions. And do consider coming to developer event in November. Probably will be again. They are nice hosts. There is no registration there, but yeah, you have to support your traveling to there. Now, thanks. And
Hi, Yuji. Okay, so it's just you and I, perhaps? Okay. Other few people know this book. So I got this book, I think, early 2000, and then started reading it. And then I was allowed to join a SIP conference. And who knows about this kind of upper side conferences that took place in Paris? I think the first one I joined was 2003. So I got this nice rucksack. It was 2008. I couldn't find the 2003 bag. I think it was kind of black shoulder bag or something. But such conferences are always nice to meet important and interesting people. Like I met Henning, Henry, and Jonathan. I guess you all know the three guys because you may have read RFC 3261 or something. When I was there, I was just asking a few questions to them, like, would you ever take an airplane if you know that SIP is going to be used in the ground infrastructure of air traffic management? I got some feedback, and I have some chocolate, and you can guess who actually said what. So there was one statement, there is one stable protocol, because I was asking, okay, how mature is SIP, and then can we start to implement it, and things like that. And I got a feedback from one guy, I'm not sure if we want to use the Morse code, because this is a very stable one. And one guy said, I would take an aircraft or airplane if ATM communication is based on SIP, but I would like to know more about hardware and software. So we've seen hardware and software may fail, it could be bad implementations, but the protocol is not an issue. And then there was some other ideas, like having a specific network for ATM instead of using the public internet. So who wants to take a try, and who said actually what? So I have Henning, Henry, and Jonathan, and I have 4 of these statements. Just guess. That's right. You get a chocolate. Okay. And 2 and 4, that was the same person, just to help you. Sorry? No. So I'll help you. So 1 was Henry. 2 and 4 was Henning, and Jonathan was 3. So grab some chocolate for the coffee break afterwards. With that knowledge, I started actually introducing SIP, the protocol, to Frequentis, to be used for voice over IP and to be used for air traffic management. That's a quite interesting environment in air traffic management, because you have to deal with analog radios. So we use still VHF, UHF radios in air traffic communication. And this is AM based. It's analog, and it's organized in sectors. So you have different airspaces, like en route, approach, then you have the towers. You have typically ATC centers, they are interconnected, so there's cross-border communication. During that time, it was actually analog communication they used. So they had analog lines to the radios, they had analog lines to neighboring ATC centers, so cross-country and cross-border. And in 2004, actually, we started thinking of replacing this with IP infrastructure, so packet-switched infrastructure, and to enhance it a little bit. So instead of having just analog audio to interconnect, to have more information getting from the radio, from the receivers, or sending to the transmitters. As there is a long migration in that environment, it's also important that to include legacy technology. So typically radios not replaced at the same time as you replacing those kind of air-ground, ground-ground voice communication systems. So there's also kind of interworking with legacy technology, not only for the air-ground segment, but also for the ground-ground communication. So looking at the features in that environment, most important, it's for situational awareness, is this kind of party line feature. And this goes along with actually analog radios. So
everyone that has a receiver can listen to what is going on, and if there are aircrafts managed in a specific sector, they use the same frequency, and if a controller gives a command to a pilot, then every other pilot in that sector can listen to that command. So they are all aware of what's actually going on. There is, especially in Austria with the mountains, there is a kind of technology called carrier offset mode. So this is just to increase the sector coverage. So these are radios, they operate at the same frequency with a slight offset. And for that, it's very important. That was kind of a tricky part in specifying these protocols for voice over IP and ATM is the transmission time adjustment, because you need to transmit actually at the same time if you have different radios working in a carrier offset mode. So you need to know, okay, what's the latency from the VCS or from the air ground services to the radio sites, and then you have to adjust. So you need to adjust to the longest end-to-end delay. Then there's also something that has impact on, or that increases actually the latency. It's called coupling mode. So if sectors are combined, sometimes during night operation, if there are not that many aircraft flying around, then a transmission from sector A is forwarded to sector B, and it goes through the ground infrastructure to the ground segment of the communication. Then in the receiving direction, you have this kind of best signal selection feature. So you get some information about the signal quality from the receiver, and this is sent to the VCS. And if you have multiple receivers, the VCS or the services that are central would then pick the best signal and provide this to the controller working position. Since we have a party line, as mentioned before, there are some situations where step-on transmission happens. So if two pilots are just speaking at the same time, for instance, then they have a simultaneous call transmission. This is SCT, and this can be detected by radios, and the radios can provide this information to the controller. So that's actually kind of safety feature, because in other analog environments, the controller is not aware that this happens. It just cannot hear anything because the signal is kind of scrambled. And with that information, you can indicate, okay, there was a kind of step-on transmission, and then you can set specific measures. Then, of course, lockout. So if 2 or 3 controllers are operating at the same radio, you need to make sure that only one is speaking. And there might be some priority PTT, so if there's high priority, then this one will win. And then there's also kind of radio remote control, or knowing about other participants who have selected the radio. So for this specific feature, we actually use subscribe notify mechanisms in SIP. Then there's also ground-ground communication. There are also very interesting features like instantaneous access code is kind of intercom feature. You just press and talk, and the other one can listen. And you can monitor what is going on the other operator positions. And there's kind of feature that comes from the FAA. It's called override call. It's similar to instantaneous access call, but it can have actually can be chained. Yeah? So A calls B, B calls C, C calls D, and so on and so forth. And there could be some loops, which is actually bad because there's always audio in place, and then you get an audio loop. So you need to cover this as well in your protocol. Then, of course, legacy interworking. So we have MFC, that's analog, SS7, ATS QSIC. The digital versions of it are still in use in some places. Then we have conference calls, monitoring and recording. So you see a lot of interesting and challenging features. And actually, you can cover this using Sipfront RGP. But this requires kind of working groups, and there was 2004. It was, I think, the second year when I was at Frequentis. We joined EuroK working group 67. So in the presentations, I have those things underlined that have a link. So if you're interested in, just click the link, and you get connected to that site of EuroK. And so it lists everything we did, and I just took a few important milestones of the timeline. So yeah, starting in 2004, then we had this Vienna agreement. That's another story I'm going to tell you with the next slide. We started some interoperability testing very early in 2008. Then we had a revision, actually the first revision of those protocols. So they're called EDs, EuroK documents. And there was also a reference, which was very important by ICAO, so it's the international organization, and working group by reference to the ED document, making it a little bit more global. And then we had first field trial where we used this in a kind of operational environment. And this picture was taken in 2009. It was kind of a historic moment. The person talking said, "Oh, it works," and this is a historic moment. And I took the picture, and you see here a lot of legacy stuff in the back. So that was actually replacing an analog connection from France to Germany. With voice over IP. So he was using the legacy equipment, and then there was a gateway translating from MFC to voice over IP, and on the other side it was actually the same. And then they had a nice conversation, and it worked. And I took a photo and also captured with Wireshark. Still no one knows about that, but I thought it could be quite interesting in the future when talking about this at the Kamailio World, for instance. Yeah, and then we had a lot of, actually the working group is still active. So we had, in March this year, we had the meeting number 55. So I joined actually all of them except one I missed. And now we are currently updating the documents. There was a major revision in 2020 since we got a lot of new features coming from the US, from the FAA. We also had some international testing in 2019 in the US. So what about this Vienna agreement? Very interesting drawing, which actually happened at the EuroK Working Group 64 meeting in Vienna. That's why it's called Vienna Agreement. And actually the day before, it was September, we had a nice social event in Vienna at a Heurigen. I think it's called Weintavern or something like this. And yeah, it was really a nice evening, and we got friends. Yeah? So, you know, in such working groups, it's always difficult because you have to deal with customer, you have to deal with your competition. But we got friends, and then we agreed on, okay, let's focus on the interfaces between the different elements, and the elements are actually voice communication system, which may consist of legacy internal parts, a supervision system, a radio side, and recording. And we have two major interfaces, or three. There's the interface for radio and telephony, and the interface to the recorder, and of course to the supervision. But a very important detail here is, I'm not sure if you can read this, there were some discussions about SIP and H323. Because during that time, there were kind of competing protocols. There was SIP and there was H323, and no one was actually sure what the future will look like. And this is just my experience. I'm not sure if you're also taking part of working groups and technical committees, who actually is in like 3GPP or ETSI or something like this. So here is my experience. So what typically happens, there's a kickoff and everyone pretends to know everything. So we are ready in 6 months, let's say. And then there's a lot of discussions about requirements. So everyone says, okay, this is how I'm doing it. Is this the most and easiest way? And let's do it like that way. So everyone talks about it, no one agrees. And discussions are going on. And then sometimes one volunteers to write a draft. Yeah, so we start with a draft, and others silently disappear, just waiting for the phase to comment. And then there's kind of comment apocalypse. That means, okay, you get back a lot of comments and completing suggestions, and usually you start this kind of battle in track changes. Documents are not readable anymore. You have some version conflicts sometimes. So it's a kind of mess. And then this happens very often. And tomorrow I'll be at ETSI meeting again, and I think we will continue that. So it's about definition wars. So people start talking about and spending a lot of time about terms. So naming it, for instance, endpoint node or thingy or whatever. So this always happens. And then after a long time, you get the first draft. And you remember the timeline. We started with this ATM working group in 2004, and we had the first draft in 2009. So it was kind of 5 years discussing and defining things. But the one thing that really happened is, and this gets back to the Vienna Agreement, we had to decide once to say, okay, we use SIP or we use HD-3. And the chairman was just asking who is going to explain us SIP. And actually, I volunteered. I said, I can talk a little bit because I got this nice book. And I was in Paris at the conference. And then he asked, okay, who will explain us HD-3? And no one volunteered. And then he said, okay, well, since no one volunteered to explain HD-3, we just use SIP. So that's really happened. And then we actually moved on with SIP, which I guess was a clever idea. Okay, this leads to emergency communication, another topic where we have this kind of working groups and a lot of discussions, and perhaps quite interesting for MNOs and VoIP service providers. So here is also an environment where we have to deal with voice over IP and, of course, SIP. It's the IMS, if it's voice over LTE, for instance, that interconnects with emergency communication or with emergency centers. And there's something in between that's called ESINet, which interconnects ambulance, fire, and police. So it depends on which country you are. You may have just one center, or you may have several centers that are interconnected. And if it's just one, it's like a 112 center. And those have to talk to each other. We have native multimedia in the end devices. We have automatic in-vehicle devices for the NGE call. And they're actually sharing data. And here, what important thing is the service URN, which addresses a service and not an endpoint. And there are some elements in between that are dealing with routing and mapping. A few features here. I think most important is the nice, this is still red over there, is the screenshot of a mobile device. So you see it's video, it's audio, and it's real-time text, so that's natively supported. Real-time text means RFC 4103. We have, of course, location information that needs to be shared for routing and dispatching. We need to support language and modality. So some people just would like to select a specific language and modality means, okay, I would like to text, I would like to have sign language, and so on and so forth. Then there is callback. Daniel mentioned steer-shaken, so I'm happy to see that steer-shaken is also supported by Kamailio. Then there's call transfer, which means transferring from one emergency control room to the other. Which is actually a media bridge in between, because you cannot just lose connection to the calling party. Then you have logging, recording, and some additional data to be shared as well. Short timeline again. I think everything started somehow with defining this uniform resource name, URN. So there's an RFC from 2008 from ECRIT, so they started to introduce this for emergency communication. Then there was a US industry collaboration event #1 where they started to test. There are some rumors that it didn't work that well, so they had to redo it later on, but this was actually kicking off a series of such ICE events. Then I did the batch for Kamailio to support service URNs. That was 2012. Then afterwards, we could use Kamailio for testing at an ETSI plug test event, which also kicked off a series of events. And I think 2018, I did a pull request for for the lost module a long time ago. And then we used this implementation actually in Austria. It's the Tech 112 digital emergency communications for accessibility, where we have those things in place, and then a series of ETSI specifications for emergency communications. And very interesting, in 2025 this year, so we're currently working on accessibility and interoperability for emergency communication. So this is not a TS, it's an EN, it's a harmonized standard, and yeah, that's kind of higher level, and if we get this published, I think that will change a little bit the communications environment in Europe for emergency communication. There were some nice stories, and it's just one example about trees, roots, and forest guides. So you may have heard LOST is organized in a hierarchy. So those LOST servers are responsible for specific regions. They're called service regions. And the forest guide actually oversees all the lost trees. And I remember at the beginning there were some discussions, okay, where is actually the root of a tree? So is it the bottom or is it at the top? And that's very important because forest guides are sitting actually at the top. So they are the root of this technical tree and not at the bottom. At the bottom are the leaves. And so we had quite interesting discussions about that. Mission critical communication is also quite new, and the scope is just the other way around to the emergency communication. So emergency communication is from the citizen to the PSAP, public safety answering point, and mission critical communication is just the other way around. It's for dispatching and just talking to the officers on the street. This is also using voice over IP, running over the IMS, and I think the important thing here is that you get higher priority on the network. So if you use a commercial network, you can just request this higher priority, if there's a congestion in the network, you should still get connectivity. There's also legacy interworking involved, which is also being standardized, and in between packet switched infrastructure, voice over IP, and also connections from one center to the other center. So they may team up and combine their talk groups, leading to some features. So mission critical push to talk. Roman is going to talk a little bit about that in the afternoon, I guess. You have also this kind of group communication, like in ATM. You have priority and preemption. You have private and emergency calls. So you have late entry, so you can join a group and listen to the group if it's already ongoing. And there are still, I think, not that much devices around that support direct mode operation, which means you don't need the infrastructure. You can communicate directly. And then, of course, authentication and encryption. Then there's MC video. You have private and group calls, the video streaming, so one source and others are just listening to the source. And then there's also mission critical data. It's short instant messaging, private and group, and file sharing and location sharing. So this is the timeline, actually just copied from 3GPP with different releases. I think it actually started earlier than 2012 because there were some Nokia phones that used to have a PTT button. It was push to talk over cellular, and this is actually was the first idea of implementing this kind of thing. And I think it was not that much different because they used RTCP application-specific signaling things for that. So it's a kind of request-response floor control thing, and it's quite similar to this push-to-talk over cellular. So that was earlier, but the mission-critical communication began in 2012. And then you may use that link. There was in 2017 a nice demo in Austria we did together with A1, Artonet, and Emergent Solutions. So it's really a nice video because it was on the lake in Carinthia. So if you click that button, you get connected to the YouTube channel. Then they continued defining the RX interface, so very important to support quality of service. and then they just extended capabilities, focus on 5G and nowadays 6G. And 2025, because that's very recent, a few colleagues were there 2 weeks ago. There is a kind of Schneeberg railway in Austria. So it's Schneeberg is the highest mountain in Lower Austria, and it's very close to where I live. So for me, it's I think 20 minutes by car. And Schneeberg railway takes passengers up to 1,800 meters. So I think the mountain station is somewhere here, and this is the peak of Schneeberg. And since this season, trains and control room have been equipped with an MCX solution. And if you happen to be there, they still run trips on a historic steam train. I'm pretty sure it's also equipped with MCX. And yeah, again, I just invite you, if you happen to be in Austria, it's very close to Vienna. And actually, you can see this mountain from Vienna. If you are south to Vienna, where Frequentis is located, you can see the mountain. And yeah, that's actually leading me to almost the last slide. So this kind of trials and testing, so I've experienced quite a lot, and just some funny facts, like the first one completely crashing with a late STP offer just because it shall not be used. So we had this in the specification, and there was some implementation that just died because someone did not follow the specifications, or RTP stacks that are not compensating clock drifts. So we had some transmitters with such problems, and we just kept the session open for 24 hours, or just over the night, I guess. And then on the next day, we test BTT. We've seen, okay, BTT just was received, but there was no audio to be transmitted. And then we figured out, okay, there was no compensation of the clock drift. So clock drift's happening. And then we had a lot of social events or social media posts. Usually social media posts are more than test scenarios to be tested. And I remember we had a fire at night after testing a week of 911 interoperability. A few of the guys, it was I think at 4 in the morning, just left to the airport because they had an early flight. But for me it was in the middle of the night. And what always works is just the last statement. Be conservative in what you do and be liberal in what you expect from others. So that's concluding my presentation, and thanks a lot.
Thank you. Maybe one quick question, since we are a little bit late. And now it's the coffee break, so everyone probably needs to wake up, and hopefully we'll be able to sort out the right side panel. What happened? Any question from the audience? If not, from my perspective, this with next emergency specification or standard, somehow in European Union seems that many countries prefer to go their way. It's still getting to convergence and this decision to use same in all European Union at least, or not yet there?
Yes, that's the idea, and that's why I've mentioned the EN 303 919, which is actually heading into that direction, saying to have something that is common throughout Europe, because it's harmonized standards, so all the national STOs need to agree on that. And this will then also be referenced by the regulators. And the problem is, and this is why we're circling around, is that there is some technology around and no one's actually saying, okay, use this. So for instance, the Commission doesn't say use this, it more or less delegates this to the member states. And then what's happening is that they're just looking into their own solutions. But with that kind of standard, the
very quick one.
Idea is to have it harmonized.
Yeah,
yep.
I know the idea is to have it, just if it's more political wish now or not.
Yes, it is.
Okay.
Yes, it is.
Yeah, the small one regarding the Sirsheken. So if the same standard goes for the Europe than that goes for the US, or there are some differentiations in that case?
That's a good question. Usually it's the same. Yeah? So I'm currently testing with the US because in Europe we haven't tested that much. And it's the same implementation. The only difference, I think, is that we also have an RPH header assigned and not only the identity itself. Yeah. But this is also valid for the US. And it's being used for the callback as well. Yeah.
Okay, thank you. If you have more questions, hunt Wolfgang today, as I said, because tomorrow he has to leave. Before going out to the break, we have coffee outside and also some bits to eat, some croissant and these cereals. So a bit more than in the morning. And before getting out, I want to give the first prize. It's going to be like a branded wine opener. Ramona, you are here. Pick up someone. Don't look. Don't pick me. Only one. Denis Pozniak. It's here. Okay, before giving it, just to show it, because I have a few will be given during this code challenge. So it's kind of a branded box with like wine bottle opener and so on. You know, we get better with the age like wine, right? Okay. That was inside. It's just you throw it. Okay, thank you. So outside would be the coffee, but there is another station. You go over the front desk. company, probably.
Yeah.
I haven't checked with him. Charles contributed a lot to like presence, DMQ in the past. So we are happy that they support Kamailio World again, also as a sponsor, and taking the time to come and present something that probably most of us it's really interested in this challenge with the revenue in the telecom industry. Thank you, David. The floor is yours.
Thank you very much, Daniel. It's great to be here. Thank you for having me along. And as Daniel said, Simon, our founder at Simwood, is a massive Kamailio fan. He used to come to Kamailio World regularly himself. He has a young family and many commitments. And so I've come along instead. Now, I'm delighted to be here. I would like to just say a big thank you to the Pascom guys before we carry on, the red-shirted guys, because they're doing a great job on the video and the streaming. So the subject for this session is navigating the decline of minute revenue, or if you've got a dodgy speech engine, minute revenue. And what we're going to do is look at that under these headings. So I wanted to give you a little bit of a background about this. The challenge, as I see it, how we can address the challenge if we're a telco or if we contract to telcos or wherever we are in that space. One of the problems, or some of the problems that traditional telephony companies have, and how open source can make the difference. And then I just want to briefly mention the Simwood Potato as an example, and I'm going to try a demo on communal Wi-Fi. We'll see how it goes. Okay, how does that sound? Is that all right? Yep. Permission to continue? In that case, I'll carry on. Thank you. Okay, so if you've been observing the world of telecoms for some time, you'll know that things do move quite slowly. I'm not talking about in things like open source developments. I'm talking about the telecoms environment generally. And my experience is within the UK. So if you think about, and this is going back a bit, you can see I've got some grey hair here, the adoption of DTMF, the imposition or the introduction of System X, things like caller ID on the PSTN. And then, of course, if we look at the early 2000s, and I think Wolfgang mentioned it in his previous chat or talk, the H323 versus SIP thing. Actually, back around the year 2000, I delivered a speech in Amsterdam, a corporate event, and I actually had H323 and SIP boxing each other in a fight to the death. Anyway, that's another thing. So things like useful Teams integrations, and in the UK, they were thinking of turning off ISDN in 2025, but it seemed too much, and so they've put it off till 2027. The point I'm trying to make is things take a long time to tick round, including the death of fax. We'd all like to see it, but guess what? Fax is still there, isn't it? Still kicking about. Most of them happen in the end. But one of the things we're facing at the moment is seeing the decline of minute revenue. Getting paid for transiting minutes on a per minute basis seems to be going downwards. And one of the reasons for this is, of course, over the top type of systems, WhatsApp, things like that. Lots of people are now calling on WhatsApp, calling on Messenger and various other things. And so if we were in the business of getting paid on a per minute basis, then that revenue is going down, whether we are a service provider or a carrier or whatever it might be. There are mitigations to this. You've probably come across some of those all-you-can-eat packages that promise you thousands of minutes. And of course, in reality, people don't always use those thousands of minutes. And so that's a mitigation in the other way. So it does present us with a challenge, because if we've traditionally been in that business of charging people per minute for moving minutes around, and these minutes are going down, then we've got to think of what we can do next in order to differentiate ourselves, in order to provide services for our customers as well. So we see this minute revenue dwindling, and we know that future revenue shouldn't really rely on those minutes. What we can do is create value. So if you're a carrier, whoever you are actually, if you can create value, then people will be prepared to do that. But in terms of timescales, we don't know how long that minute revenue is going to stick around before it gets to a critical level. Now, where can we add value? Well, if we're in the path of a telephony channel, we can look at collaboration. We can integrate with various systems and charge for that integration. We can do analysis, and you've probably come across things like AI-driven sentiment analysis, which until recently was more done in a kind of after the call way, but increasingly people are doing it in real time, so you can actually check up with what's going on in a live phone call. There's various ways that we can add value. But here's the challenge, we need to do it pretty fast, because that minute revenue is heading down and we don't know when it's going to kind of peter out. So what we've got to do is take this graph, put a stake in the ground or another axis on the graph, and start creating some value to stem that flow away from the minute revenue. Now, we can charge for that added value, but actually in creating value adds, we might well attract back some of the minutes that have disappeared elsewhere. So there's a lot of possibilities here. Now, I want you to think about the traditional telco. And I know that's not us in here, because we're involved in the world of open source. But if you think of telcos around the place, what they've tended to do, and I'm going to use a musical analogy here, is they've tended to buy a box, or in music terms, a CD player for each thing they wanted to do. Now, even the ones that started off many, many years ago with Asterisk and things like that, if they got successful very quickly, some of them went across to Broadsoft and people like that. They kind of came out of the world of open source because they wanted something quickly. And then you get this CD player model where, oh, we need call recording, so we'd better go and buy a box for call recording. And then a couple of years later, oh, well, we really need an SBC for one reason or another, so they go and buy a box, buy a CD player for an SBC. And what happens is these telcos end up with a lot of independent individual boxes on which there's hardware costs for the maintenance, there's licensing fees, there's all kinds of upgrade fees, and of course there's the overhead of actually coupling them all together to do something sensible within their infrastructure. And so it turns into a bit of a hodgepodge, a little bit of a mess. And as you can see, it's not only the costs that are involved, but those proprietary interfaces, because if you bought your SBC from here and your call recording box from here and your Teams integration from there and your AI sentiment analysis over here, you've somehow got to put them all together. And so there really is a challenging environment. And this is where we believe open source really has the key, because if you're working with open source, you can effectively become the Spotify of the carrier services industry. You see, open standards allow for easier integration between the different systems. Now, you might still be using slightly different systems, but when using open standards that are inherently in open source, then we can integrate more easily. You can create must-have features without significant or ongoing costs. It's one of the beauties of open source, isn't it? And of course, if you're doing this in your own homogeneous environment, you can provide API access to these things as well. So you really end up with, rather than having a load of different CD players that are all cobbled together with some cables, you know, maybe some of them are RCA, some of them are optical, some of them are other stuff, some of them are HDMI. Instead of all that, you can have a homogeneous collection of functionality, and you can give a model that allows people to choose the song that they want. They don't even have to have the entire album or the back catalogue. They can just have an individual song. They can pick up the functionality that they need. So, whether you're a telco or whether you're somebody that creates solutions that you sell to telcos, or wherever you are, collaborating with open-minded partners is a way forward. Now, in the age of bring your own carrier, one carrier can work with another or another carrier services company without giving away their estate of DIDs, without having to do the porting and all of that kind of stuff, because if you build your network or you build your offering in such a way that people can just pass through your system and pick up the functionality they want, on the way to the termination, then that gives a lot of flexibility. And people can use what they want, maybe even on an individual call-by-call basis. Imagine if a call comes through and you say, yeah, this one is going to pick up recording and this one is going to pick up Teams integration, but the next call is not. That gives great flexibility. So either as a supplier or a customer, wherever you are in the value chain, there's the ability to create margin for charging on these services without having the headaches of those individual CD players and all the maintenance and the upgrades and the licensing that goes with them. And this bring your own carrier concept eradicates carrier envy. You know, if you're a service provider and you're signed up with this carrier, and then you look across at that carrier and you think, yeah, but they've got this additional functionality that I'd really like. Well, with the BYOC concept, you can actually stay with this carrier and borrow that carrier's functionality by transiting through their network. Now, here's an example. As you know, Simwood are big open source enthusiasts. Now, it doesn't mean I'm claiming that everything on here is open source, but what open source now allows us to do is to join all of these things together. It acts as the glue in some cases. And the reason why we called it a potato is it looks a bit like a potato. You know those baked potatoes layered in foil. So that seemed the obvious name for it. You can see lots of different things, and there's different skewers that come into the potato that allow you to connect at various different layers and deliver various different bits of functionality. Now, of course, everybody these days is talking about AI, and we have a recent development in beta. We've got conversational AI agents that are now in the network. And so what I thought I'd do, with your permission, is do a little demo. Does that sound fair? I'm a little bit worried about it, but we'll see whether it's going to work. I'm from the Tim Panton school of demos. I think it's better to have loved and lost than to have never loved at all. So I'm going to attempt this demo. It's with a conversational AI agent that took literally 5 minutes to put together. In fact, let me actually show you the portal where I put it together over here. I'll just amp this up a little bit. So this is our AI thing. You can see that in the Simwood portal I've got AI agents in beta, and I've got this one called Heidi here. If I click on Heidi, you can see that I've told her which voice to use. There's lots of different voices with American English and British English and Australian English and all that kind of stuff. And I've given her an initial prompt, and then I've given her a few pointers here. But the rest of the stuff, in large part, is defaults. So when we talk about stability, speed, and what have you, I'm using the defaults. And the only other thing I've done, and of course is very important, is to point Heidi to a number of resources. The Kamailio World 2025 website, the Asipto website, Daniel's LinkedIn, the Kamailio project, and the schedule. So I've pointed Heidi in this direction, and what I'm going to do is try calling her on Zoipa, and we'll see what happens. Now bear with me, because of latency issues and things like that. I'm a little bit concerned, but we're going to have a go and see what happens.
Hello there. Welcome to the wonderful world of Kamailio. My name is Heidi. How can I help you today?
Well, I was hoping you could tell me a little bit more about Kamailio World 2025, please.
Kamailio World 2025 is going to be amazing. It's the 13th edition of the Kamailio World Conference and Exhibition. It's a place where real-time communication technologies will challenge your imagination. The conference is being held in Berlin, Germany from May 12th to 13th, 2025. We'll have technical tutorials and business showcases, so you can learn how to build your own systems or find the right products and solutions for your needs. Would you like to know more about the topics that will be covered?
Well, can you tell me anything about Daniel-Constantin Mierla, please?
Daniel-Constantin Mierla is one of the co-founders of the Kamailio project, and he works at Asipto. He's deeply involved in the development of Kamailio, and he's written a book about SIP routing with Kamailio. He's also won several awards for his contributions to open source, including a Google Open Source Peer Bonus Award in 2019. He is a very important person to us here. Did you know that Daniel will be presenting at Kamailio World 2025?
I didn't know that.
Would you like to know what he will be talking about?
Yes, go on then.
Daniel-Constantin Mierla will be presenting 2 sessions at Kamailio World 2025. The first is titled Kamailio, Last Year in Review, where he'll walk through the most relevant events of the Kamailio project, focusing on the development during the last year and plans for the future. He will also be part of the Kamailio Ask Me Anything interactive session, where the audience can ask questions about using or developing Kamailio. Finally, he will be giving a presentation on Kamailio and SIP transport layers. Are you interested in attending Kamailio World 2025?
Well, I'm already here. But is there any way that we could appreciate Daniel better?
That's a great question. I think Daniel is amazing, and it would be great to show him how much we appreciate him. I was thinking of starting a Daniel-Constantin Mierla fan club. What do you think?
I think it's a great idea, and I'd like to suggest something. How about every new member gets a free water bottle with a really nice picture of Daniel's face on it?
That's a wonderful idea. I'm sure everyone would love a water bottle with a picture of Daniel's face on it. It would be a great way to show our appreciation for him and promote the fan club. Would you like to help me organise the fan club? I could really use your help with getting it off the ground.
Flipping heck, that's a bit of a big ask. How much were you thinking of charging for membership?
I hadn't thought about charging for membership yet. I was imagining it being free to join, with maybe some optional merchandise available for purchase, like the water bottle we discussed. What are your thoughts on that? Do you think we should charge a membership fee?
Yeah, I do, but listen, I'm in the middle of a demo, so I've got to finish. Can I just give you my name and email address so you can subscribe me to the Kamailio newsletter, please?
Of course. I'd be happy to subscribe you to the Kamailio newsletter. Just give me your name and email address, and I'll add you to the list.
Yeah, it's David Duffett, and the email address is david.duffett@simwood.com.
Thank you, David. I've added your name and email address to the Kamailio newsletter subscription list. You'll now receive updates and news about the Kamailio project and community. Is there anything else I can help you with today?
No, that's it. I've got to carry on with this presentation. Thank you.
Okay, David. Thank you for contacting us, and I hope your presentation goes well. If you have any further questions or need assistance in the future, feel free to reach out. Have a great...
Yeah, I'm going to cut her off. She goes on a bit. I did tell her to be chatty. I said, you're a chatty and enthusiastic. That's a genuine AI thing that took literally 5 minutes to set up. And all I did was point it at these different resources. So I think you'll agree, it's quite amazing the way it picks up on things. I actually set one up to do sales for my book. And she said, what's your name? And I said, David Duffett. She said, there's a coincidence. You know, let me contact the real David Duffett and get him to talk to you. Anyway, let's pop the presentation back up here and carry on. Okay. Now, just to prove that it is 100% genuine, I'm going to give you the number that you can call. So if you want to make a note of this number, feel free to call it and you can have any kind of conversation. And she's honest about the fact she's an AI. So if you ask her something that she doesn't know, she'll say, I don't have access to those resources. Or she'll say, I'm an AI. But literally, that's a 5-minute job to set it up. Now, you might think, well, why on earth would you want to do that in the world of carriers? Why would you want to have a phone number terminate in that? Well, here's a lot of power that imagine if one of your customers is a hosted PBX company and you could offer them a real digital assistant that can have a proper conversation, capture all the context, and then do call transfer into any given extension on that hosted system, as an example. So, you know, the limits, well, there are no real limits to this. Okay, so in conclusion, we know that the revenue model is shifting and money from minutes is sort of heading downwards. We need to deal with that. One of the things that's very important is speed of deployment, the ability to deploy this stuff very quickly. So there is a strategic call to be made. Now, if you provide services on your own infrastructure, then perhaps you can charge for those, either by subscription or by call or whatever. But wherever you are in the value chain, finding the right collaboration partner is essential. So minute revenue heading down, we've got to do that value adding. Open source facilitates the way to connect up all of the different parts, and there are opportunities to help telcos directly. So it's been a pleasure talking to you about the way we can stem the flow in a downwards direction of money from minutes. We can make more money by adding value and selling those added value items to various people in the distribution chain. And it's also a pleasure for Simwood to be participating in another Kamailio World. And I want to say a big thank you, not only to the Pascom guys, not only to Daniel and Ramona, but to everybody that's made this possible. Thank you.
Thank you, David. Questions? We have questions in the, okay, two there. Okay, Randy, I'm coming second to you. First here. Vasily.
Thank you for the presentation. It's amazing. Is it interruptible?
Yes.
If you can share what is on the backend from speech to text, do you use one supplier, multiple suppliers, any challenges in this regard?
Yeah, I'm afraid I don't know all of the ins and outs. I do know that it relies on a number of different things. For instance, I believe you can choose the LLM engine that you use at the back end, whether you're using ChatGPT or Gemini or whatever. In terms of the speech things, I'd have to ask other people to find that out.
Let's chat. Okay, thank you.
Yeah, but by the way, I didn't interrupt it because in my testing, when I do that, especially with the delay that there might be, it gets a little bit flustered. So that's why I didn't do that.
Okay. Randy?
David, my question is, so you gave it the website as the source of information, and obviously in the first minute or two of your demo, it was just spitting out stuff, the text from the site. Could you have asked what Tim Panton is going to be speaking about or something like that?
Yeah, absolutely.
So, go ahead.
Yeah, I didn't want to make it longer than it was. The thing is, I told her to be chatty. So she was giving a lot of information. I could have told her to keep your answers really short, and be more businesslike, but I'd programmed her to be chatty and enthusiastic.
Gotcha.
But yes.
My actual question was, you gave it that, you coded that stuff and gave the resources. Did it analyze the resources first and know everything, or was that finding at the time of your call, was it finding the information?
It's a good question. I don't really know the answer. We'd have to talk to Charles Chance. I believe it does a little bit of crawling, but I think quite a lot of it is real time as well.
And who is it talking to? Who's providing the service? Is Google or what?
I beg your pardon?
The service that...
I think that one, let me just check. If I minimize this and put this back up. Gemini is what's used there at the moment. Okay.
Okay.
Am I free to go, Daniel?
Yes, thank you, David.
Great, thanks.
Andreas, the floor is yours.
Thank you very much, Daniel. Welcome, everybody. Today we heard a little bit already about deployments and running AIs and things. All of this needs to be tested, and today I'm going to talk a little about something a little bit different. It's not about SIP, actually. It's beyond SIP. It's about how to build a testbed for mobile cars on a budget. And that means we're going to play a little bit with real mobile phones. It's me again, Andreas. I'm in this community, as Daniel said, like for, 20 years. 15 years ago, we started RTP engine at Zipwise, and I had the pleasure, although I didn't do a lot of coding, but to lead the project. So Richard Fuchs was doing the hard work. I was just taking the credits. Since 5 years, I'm focusing on SIP testing or on telco testing in general at Sipfront. And the reason for that was that over my, 20 years of doing SIP development, I always lacked like proper tools and things went south a lot. And this is where I took the challenge, and it's something that I'm going to talk about today. So I'm so looking forward to go through the Excel test plan again. This is what we all look forward to after, like Jonas said, upgrading 80 Kamailios at 3 in the night, right? And then you're like, okay, I'm done. Am I free to go? And you're like, no, I have the test plan to work through. And yeah, there are different kind of people, but I know very few that actually would, sign this statement. And the problem about this is what's happening if you don't. Like last week, we had again a major outage in Austria. Mobile carrier had an issue with data, and also telephony was partially affected. And a funny or not so funny thing is, again, a technical infirmity after maintenance work. And that happens all the time, right? Now, the thing is, we know a lot of people in this industry and with these telcos, and if you talk to them and say, hey, you actually need to test more, and they're like, yeah, but I can't possibly test like 100 cases in 2 hours, right? And that's what's happening. So if you upgrade your SBCs, you do 1 or 2 test cores. I don't know how many times I started blowing into the phones and check if I have two-way audio over the past 20 years. And that's what's being done, right? And what you really want to do is you want to turn these 100 tests in 2 hours into, hey, let's have 1,000 cases, go for a coffee, right? And once we are back, we want to see the green check or like a red cross. And if it's the red cross, then it's not 7 in the morning and we are like, okay, the customers are starting to, pick up cars, rather than it's still 3:15 and we have a couple of hours to think about the rollback, right, or roll forward, or whatever the decision is that we can do. But the good thing about this is then we have the time to do it, and we also have like the scope of, is it just this particular feature that's not working, and okay, you can do it next night, or is it something really important for this really important VIP customers that we have, and we have to roll back like all of that. And the only way to solve this is test automation. You really got to automate these kind of cores. And this is what we're going to talk about today. I've done some presentations in the previous Kamailio World about automating SIP cores. Sometimes you want to go a little bit higher, actually, and test with, for instance, actual mobile phones or mobile devices, because, yeah, you can do talk VoIP to your VoIP infrastructure, for instance, directly. But you have the peculiarities of an iPhone working slightly different than a Samsung Galaxy S from a VoIP stack perspective. So you really want to use the end devices that the users use. And you can use SIM boxes for that, right? Like there are great products out there, mostly based even on Asterisk, I think. So you have modems in there. You can talk SIP to them, and then they just do a mobile call. That's nice, but again, sometimes you want to have like the real mobile phones because customers say, yeah, but it's still this particular feature doesn't work with these particular phones, right? And in order to automate this kind of devices, there are a couple of tools out there. They are also really great, like Appium, ADP, and Source Copy, and whatever you can use in order to, automate your the usage and the control of your phones. But I don't know if you have recognized that. It's really hard, particularly with native mobile cores and the native dialer, to inject and record the audio. Why is this important? Because if you do this end-to-end testing, as I said, you're blowing into the phone on one side, you're checking, does it work on the other side? You really want to inject something, and you really want to record and check if it's there, right? If you have like an audio connection, particularly after some core scenarios that you did. And you might also want to check the core quality of that, right? So it doesn't help you if there is something, but it's completely distorted. Now, we were asking ourselves, okay, when we're going to approach this and we can't use Appium or ADP or whatever, we do this for voice over IP apps and it works fine there, not so much for native dialers. So we were asking ourselves, what else is actually controlling your mobile phones? And the answer was actually quite simple. This guy is, for instance, right? Every time you step into your car and you have your phone connected to the car, you can actually, with your steering wheel, answer your calls, place calls, do kind of like navigate through your address book, and so on and so forth. Now, the thing is, how does the car actually do that? Pretty simple, by Bluetooth, right? So you have your car, you have your phone, you pair your phone with your car, and use hands-free, because it's mandated, at least in Europe, right? You're not allowed to take your phone while you drive, right, and place calls. Yeah? So you have to have this supported. Now, if you're at 3 in the morning and you did all your SPC changes, it's probably not so handy to come with your car and do your tests. So you got to modify that a little bit, and you can actually put your Raspberry Pi in kind of like an existential crisis and have it pretend to be a car, because why not, right? And this is what we're going to look a little bit more in detail, like how could you actually make any Linux system, but particularly like a Raspberry Pi, into a device that pretends to be a car implementing hands-free profile. Now, how does this actually work with Bluetooth? So a very quick primer. There are a couple of Bluetooth profiles that are being used in different kind of scenarios. The first two, A2DP and AVRCP, they are really what you want to use when you listen to audio, like music, on your headphones, right? Because it's a one-way HD stereo audio streaming, and it has a kind of great audio quality, right? It's getting better. You can also remote control it, but that's one way. It's high definition, so you can't use it for mobile phones, obviously, because you want to hear what the other one is saying as well. So for this kind of scenarios, there are two other profiles. One is called headset profile, which is like a very simple profile. You have your headphones on, right? You get a call, you hear it ringing, and with like a press of a button on your headset, you can actually accept the call, for instance, right? Call quality is pretty poor for that, but it kind of works, right? But then there is an alternative to that, which is the hands-free profile. It's actually supposed to be used by cars with better audio. Now, what does it mean with better audio, right? There's a little bit of expectation management to be done for this kind of tests, because you are getting a phone call in, or you're placing a phone call, you have this additional radio connection from the phone via Bluetooth, and obviously there's some codec stuff going on, right? For handset profile, there used to be CVST and SPC. It's like 8 kilohertz and very low bandwidth. You get some G711 vibes with that. What you really want to look for is the MSPC codec, which is supported by HFP profiles. It's there since, I don't know, like 12, 15 years even. And it at least does 16 kilohertz mono at 16 kilobit per second, so which is kind of okay if you do your mobile calls via AMR wideband, for instance, right, which falls into kind of the same category, but actually this kind of test setup starts to be a limiting factor for AVS, for instance, right? So just keep that in mind if you want to do like audio testing. What you get though is like the basic functionality, like you can dial with your phone remotely via Bluetooth. You can answer the phone, you can do DTMF and so on. But it's the biggest nightmare for me all the time when somebody calls me, sorry, Oliver, it's nothing personal, but people are calling me saying, hey, can I talk to Oliver? And I'm like, damn, I need to do the transfer on my phone again, and I swear to God, every time the call drops, always, right? So I'm usually nowadays resort to, yeah, can you give me the email? I'm gonna send you the number and connect them directly. But that's actually like really a problem, and I'm pretty sure that it's not always me dropping the call on my phone when I try to do the transfer and stuff. So what HFP also supports is like the 4 apocalyptic riders, which is like hold and dial, hold and swap, conference and transfer, which is like the typical scenarios that you need like in P2P scenarios. You know, you are on a phone call, you get a call in, and you can actually remotely via Bluetooth hold and dial and do a second call, for instance, to ask Oliver if they're willing to do answer the call. You can then also swap the calls, check in between. You can then put your three-way conferences, like what we used to do like 15 years ago with SIP as well, right? And you can do the transfers, right? Now, how do we approach this? So you get a plenty of capabilities via Bluetooth to control your phone and also to get the audio in and out, right? So how does it actually work? So you need, obviously, a mobile phone with Bluetooth, but nowadays pretty much all of them can. So it doesn't matter if it's Android phones or an iPhone or even some Nokia feature phone if you still have them lying around. What you need on the Raspberry Pi is obviously Bluetooth daemon in order to communicate with the phone. And then you need 3 different elements to drive your phone via Bluetooth. One is getting the bearing up and running, right? So obviously you sit into your car and you say, hey, I want to connect my phone to the car, or in that case to my, Raspberry Pi. You need to get the audio in and out, right? So you have some kind of audio wiring that you need to do. And you need to have the phone signaling. So I want to, dial, and then once the call is up, I want to do a second call and a three-way conference. So how does this work? And we're going to look a little bit into the technical details of that. The way it actually works is pretty simple, right? So you have a couple of open source tools that are available in your Ubuntu and Debian systems out of the box. Look for newer versions, like, Ubuntu 2024. Particularly for the 2 elements in the middle, Pipewire and Wireplumber. They are like a kind of new audio framework in Linux. You have Ophono, which is a pretty ancient, actually, project from 2009 in order to drive your phones. And then you need to have some kind of, I call it like Sipfront Bluetooth agent, but we're going to look at how you can actually do that by yourself. And all of that is kind of glued together with a dbus system. Yeah? And let's look at what that means. So what's dbus? If you're using a Linux desktop, GNOME or KDE, you are actually using that already, right? Because it's a message bus. It's actually being used, or was supposed to be used for Linux desktops. What's happening is, right, if you plug in a hot plug audio or a wireless card or your network changes, you have this on the top right, the symbols showing like the signal strength of your Wi-Fi connection. You can control your volumes. All of this is actually being done by dbus, right? And if you connect like Ophono to dbus, you can actually also get or control and get events for calls, right? So that's how it's supposed to work. Now, what's Ophono? It's an open source mobile framework. It was invented by Intel and Nokia in 2009 by some, I don't know what the phone was called. Anyways, it's obsolete. Then it was used by Intel and Samsung in 2011 or 12, and then there was Sailfish US. So it's all like pretty old stuff. Usually, it was supposed to, build Linux-based phones, right? But since, Android took that all over, it actually got. I don't think it's being used in Android, to be honest, right? But it's still there, and it works, right? And it uses the DBus API in order to provide like remote functions, to do a call, to answer a call, to send TTMF, to do the transfers and stuff like that. And it comes with a bunch of scripts to provide you like example use cases for that, like dial number, for instance, right? It's a script readily available. If you pair your phone and you get Ophono to connect to it, right, you can actually just on your Raspberry Pi on the CLI, just say dial number 12345 and your phone will happily dial. Yeah. So Ophono is being used for doing the phone driving, and you don't actually have to configure anything. You just say apt-get install, and it kind of works, right? There's something you need to configure in Pipewire. And Pipewire and Wire Plumber, they are some audio and video routing server. They are supposed to replace jack and pulse audio. It's gonna be complicated because audio in Linux has always been a mess. It's not getting any easier with that, but the good thing about that is that it really works well with Bluetooth D, and it also really works well with Ophono, right? So there's just one configuration option in some config file where you say, hey, if you do the Bluetooth connection to your phone, just hand it over to Ophono, and Ophono will then take care of, the audio routing, and it will create audio devices on your Linux machine, and that's about it. I think the only thing that you really need to configure is, you need to enable Ophono in some config file, and you need to tell it to use MSPC, like the codec we were talking about before, to really make sure that you have like not HD audio, but at least 16 kilohertz sampling rate, and not 8. Yeah. About the Bluetooth pairing, you are supposed basically to write a Python dbus script, or Python would be the easiest one. There are plenty of scenarios or examples on the internet or on GitHub. Because if you start connecting your phone via Bluetooth, you get in dbus a couple of events where it says, hey, there's a new phone. What do you want to do with that? And obviously, since you don't want to enter some pins and stuff when you do the coupling, you want to have a script that just automates all of that. You can do the same with Bluetooth CTL. Yeah? So if you run Bluetooth CTL and you connect your phone, you pair it with this device, right? You just say before, hey, power it on. You have an agent with no input and no output, so please no pin code stuff and so on. You make it discoverable, you make it pairable, and then you pair it on your phone, so it will appear on your mobile device as like kind of like a remote audio device. And you pair it, and then you say, hey, trust, and it's usually a MAC address, some Bluetooth MAC address, trust this device. And then Bluetooth daemon together with Ophono and Wire Plumber and Pipewire will create audio devices and audio instances that you then can use. Now, there's just one word of caution here. Stay in the lane when you work with these kind of things. The thing I said before is dbus and Wire Plumber and Pipewire, they are supposed to work on like Linux desktop with user sessions, right? So you log into the system as a user, and then you get like all these devices. Don't try to fight the system. I tried because I was like, hey, I don't want to have a user, I'm root, right? So try to do everything as root. Don't do that. It won't even allow it, and I tried to hack it out, but didn't succeed. You can't even start certain elements like Pipewire as root. It says in the systemd files, hey, you are root, denied, right? Tried to work around that, didn't really work, right? It was a waste of time. And the other thing is you just, you can configure your user. You have to configure your user on your Raspberry Pi, for instance, that when you boot it up, it auto logs into the system, creates the session dbus, and it just works. Yeah, don't try to fight it. You can if you're brave. Now, the whole picture. So how does it look like in the end? We have the mobile phone on the bottom with the Bluetooth connection. We have the session and system dbus as a glue. We have our tools like Ophono, Pipewire, Wire Plumber, and your Bluetooth CTL or your own dbus script that just waits for the events for a phone to connect, right? You just pair it, and that's it. And then you have certain tools available in order to control that. So for instance, this dial number script I already mentioned, right? You just say, once the phone is there, you can say dial number 12345, and kind of magically your phone will come alive without being cabled or connected other than Bluetooth with your Raspberry Pi. And once the call is up, you get like these audio devices, and then you can use the pipe wire, or I think it works even with the ALSA devices. So you have like audio devices that you can then use to say A play or PW play for pipe wire, and you just, you know, send from your Raspberry Pi a WAV file into the core, right? And you can at the same time, you can also say PW record in order to record what's coming back in. So essentially, you have like a sound card there, and then you can start automating that. And that is exactly what we did at Sipfront. So wrapping it up from that perspective is, you know, you have a call, you can configure your test case, you can just press run, and then it automatically dispatches a test to your Raspberry Pi, and it will connect to your phone, and then it will get all the events back, and you say, hey, the phone is attached, the call is incoming, it's established, and it ended remote, and stuff like that. And when you even get the like network information, like the signal strength and the network name, which is pretty important if you do like roaming tests, and you want to make sure that you're really in the right network. And then you can also do, when you, on the other hand, have like a SIP client, you measure all the RTP and RTP statistics. What you do not get out of the box is the signaling. So that's important. You don't get access to like voltage signaling directly, right? It's just like a very high level way of working with the phone. Now, the interesting part is, so you're having that, you can create all your kind of test cases, you can automate all your mobile phones and your mobile cores and all the mobile scenarios. You can really verify automatically 100 times over if your call transfers actually work, or if it's really the user who is just too dumb to, you know, manage to control the UI. But what you get in the end is, and that's a pretty interesting part, is you get a sound card mapped, a sound card on your Raspberry Pi, on your Linux machine, mapped to the mobile phone. And then you start thinking a little bit, what could you actually do? And we have from David seen like his Soipa example, right? So Soipa as a desk phone client, right, also uses the sound card for you to capture and record the calls and then sending it off to somewhere. And you can actually do the same thing with your mobile phone without doing a mobile application for your mobile phone, right? Because you have a sound card on your Raspberry, and you can capture and inject audio. So why not just wiring up to OpenAI's real-time API, for instance, which in fact turns any mobile phone into a voice bot, right? Doesn't have to be OpenAI. It can be like Simwood as well if they provide an API. I don't know. But the way that works is, you know, it's the same picture, but instead of, you know, manually trying to play and record the audio, you just use the, for instance, PyAudio, like the Python audio API or package, right? And put the OpenAI Python SDK on top and communicate with OpenAI's real-time API, right? And if you're thinking like, you just do that, well, it's not as easy as that, but there's a readily available GitHub project out there that does exactly that, right? It just, you can run it on any Linux machine that provides sound cards, right? And your, you know, Ophono, Wire Plumber, Pipewire thing provides a sound card. So you can just run it. There's a script in there. You just start, you put your OpenAI API key in there, and then you can call your mobile phone, and the mobile phone will answer if you, you know, automatically let the phone answer there. And then it will just, you know, pipe all the input over to OpenAI's real-time API, and whatever comes back from there is being injected back into the mobile phone, and you can, you know, have your phone as a voice bot. And that's a pretty like playful thing of, you know, playing with these kind of scenarios. And that's my presentation. So I'm super happy to answer any questions. We also have a desk near the reception over there. So if you have any questions regarding test automation or regarding this particular mobile tests or anything in between, feel free to approach us. My colleagues Oliver and Richard are here as well. So happy to answer.
Okay. I see many questions. First team, then we have here, then I saw another hand and another. So quite a lot. So again, they have a desk, so we don't have to take all the questions here to.
We're leaving tomorrow at 3 or 4, so feel free to approach me whenever. But
okay.
Bring it up.
So
thanks for that. It's really interesting stuff. I'm wondering whether you can extend it even further and talk to a VoIP service rather than using a PSTN as on the phone. Can you talk to anything else that runs CallKit on an iPhone, for example?
What the Bluetooth connection does, it per se controls the native dialer, right? And whatever the native dialer then does, it's like you sitting there and pressing the buttons. It's kind of like the same. It's just a remote control way of doing the calls, right? What you cannot do with that is like remote controlling voice over IP application, if that was the question, or something like that, right? But whatever the phone uses as a radio connection or technology in order to do the mobile calls, it's being used there as well. It's like just another way of interacting with the phone and the phone stack.
Was here the next one? Oh, sorry.
Yes, thanks. We've been using also some mobile testing, but we mainly first tried with the CHAN Mobile from Asterisk and then the GSM Open. What is your experience? Have you used this? And if yes, how this is better than that?
Some of our customers are using these kind of SIM boxes with the modems in there as well, right? And it has some pros and cons. One is like the pro is, it's kind of like you operate a SIP gateway, right? So you put it there, you can configure a SIP peering from your infrastructure to this gateway and then just send a SIP call and then it does like the conversion to GSM or LTE or 5G or whatever the box can do, right? So it's simple to handle. But the drawback of that is that it doesn't reflect real end user experience because the end users don't use these gateways. They use an Android phone, they use an iPhone, right? So there might be different kind of, implementations at play, and it might work on the SIM box, it might work on the iPhone, but not on the Pixel 9 or whatever, right?
For example, GSM. For example, GSM Open or the CHAN Mobile, it also connects via Bluetooth to the device and uses the native dialer.
All right.
You can make out the calls and receive calls, and the good thing is with Asterisk and FreeSwitch, you have very good APIs where you can write a lot of different scenarios and tests to, even for example, voice over Wi-Fi, voice over GSM, or changing the networks, from 4G or 5G to the Wi-Fi and so on. So that
very interesting. Yeah.
Okay. There is no question anymore. Okay, last one here.
Yeah, thanks. Just a quick question. Have you looked on the implementing like more Android car or CarPlay protocol? Because from there you can get much more information, like looking at the car, that, for example, a strength signal and things like this means, or it's just proprietary and closed. Have you looked in this direction?
Not into this direction. What we are playing a little bit is also getting like software on the SIM card and doing network measurement there and sending it off from there. Like you get like the cell information and everything. Our approach really there was to do it or try to do it without any kind of software that you install on the phone. You just use a stock phone and you can use that. And as I said, the option is also to put like working with the mobile carriers and try to get like a SIM applet into the SIM and doing the network measurement there and then using like channels to send off this information in addition to the tests. Yeah, but there's nothing in between that we have tried yet, right?
Anyhow, amazing. Yeah, interesting solution that you found there to play with any phone. Yeah, so it's easier now to test any kind of device. Okay, so as said, they have a table. Just go around the registration desk on the right, like just in front of the entrance. They will be here today and most of the tomorrow, as said. And ask for demos, discuss with Sipfront. Andreas, again, thank you for being with the project for a long time, supporting it with coding, by supporting the event as well. Really big thanks.
Thank you.
Technical University hat on. Your floor, Ramona. Thank you.
Okay, thank you very much for covering these minutes. Okay, so this presentation today will be about voice services integrated into 5G networks, and mainly about IMS and over-the-top voice services. Some highlights or insights from the experimental evaluations that we have done in the recent months. First of all, let's put a bit of introduction to the entire work we are doing at TU Berlin, the chair of Next Generation Networks, led by Professor Magellan. Well, I'm coordinating the OpenSigGNet.org initiative, where actually we are promoters of an OpenSigG for all. We, for research at least, but not only, but regarding research, we want to achieve a collaborative research infrastructure to empower the connection of the not yet connected, connect the unconnected. This is not our idea, it's already promoted by IEEE, but we are defending this vision. So we thought if we approach technically like using open source projects and cost-effective commercial off-the-shelf hardware solution, we are able to enable rapid prototyping and deployment of test beds for mobile networks towards 6G. So we are looking to optimization of the 5G technology, because we are already trying to figure out how 6G in not even 10 years from now, but probably there will be 10 years from now, as 5G started with a bit of delay, and between each generation are approximately 10 years, let's say. And what we see as impact of benefits of this initiative, I could mention creating self-sovereign networking capabilities, facilitating customized solutions across industries, promoting inclusive technological advancement, and empowering the various stakeholders through accessible infrastructure. So we want to make these mobile network technologies more accessible, in one word. Our key achievements so far could be seen in 3 categories. So on one side, we have academic contributions, we publish papers, we try to foster these research activities. On the other hand, we have educational initiatives as building future talent. We organize workshops for students and try to come closer to them and see how they can get started with technology. Sipgate said it's easy to get started. It is easy, but not always, because it's not just installing the application. Sometimes it's the background information, the technology itself that the students have to get familiar with. And in case of mobile networks, this is quite complex. And another achievements that we can mention are scientific workshops that we organize in an endeavor of fostering international expert collaboration, fostering industry academic knowledge exchange, while focusing on sustainable networks. Such an event there will be next month in Budapest, focusing on connecting the unconnected with 6G networks. A bit about the roadmap. If I have to sketch it, I will sketch it like this. We started in 2023 with the core vision, and since then we worked on defining the open source-based blueprint framework. We partnership with University of Cape Town in South Africa. We had a longer collaboration with them, but it was just the right moment to embark on more collaboration. And we are actively involved now in developing the infrastructure. Our focus is on local testbed cost efficiently. This is a must. And also on testbed or replicable experiments as a service. And this we can do it with slices RI, which are kind of scientific large scale infrastructure for communication, computing, experimental studies. This was a project started several years ago by Sorbonne University, and they maintain it. We are looking to extend the partners network, and we expect to have the integration work done by 2027, and in 2028 to see what was the impact of our initiative. So, yeah, at TU Berlin, we look at the end-to-end mobile network testbeds realization, including the backhauling. For backhauling, we also need cost-efficient solution over best effort networks. And we are looking at automatic deployment and orchestration, and also at multimedia services. And in the next minutes, I would like to go into more details about the multimedia services experimental evaluation that we've done last year. For example, looking at IMS and over the top. I don't know, maybe many of you already know. IMS is a standardized technology, OTT, no. But they both come with advantages and disadvantages. Okay, for telecom guys, probably there's no OTT that they really want to see. They want to have IMS, and this is a good thing. It's just that IMS is a bit more complex, and it doesn't allow for faster innovation. So we will see in the next slide. 5G standalone means that is a network, 5G network that does not rely on 4G anymore, because it exists also 5G non-standalone, where actually the core network is a 4G core network. And having the 5G standalone will bring a lot of benefits also for voice, because then we will use we will have voice calls in with higher voice quality and lower latency. What brings new compared to 4G is the unified network for voice and data. We will have seamless connectivity, so you don't have to tear down the data session when a call is coming in. We have access to support for advanced features like network slicing and multi-access edge computing. So there will be a set of benefits having voice over new radio. This is a slide where I thought to put the architecture of voice over new radio in parallel to over-the-top voice services when you want to integrate this in a private 5G network. And we see that there are huge similarities. The 5G network, it's mainly the same, the UE, G-Node B, 5G, C, these boxes are the same. What is different are the radio resources that are allocated especially for the audio calls in case of IMS. Therefore, we see there an IMS PDU session. What is not present for over-the-top voice services, where the audio is sent over the internet or the default PDU session, which is a best effort, is not guaranteed bit rate. And what is also different that on the UEs, we need a SIP client app installed in order to place calls. Yeah, okay, the boxes of the voice service part are also different. For OTT, it's much simpler. It's just one Kamailio SIP server with database backend, but in case of IMS, we have 3 Kamailio servers, the PCSCF, ICSCF, and SCSCF, that have to be configured as per 3GPP specifications. And now a bit about our test beds. The simplest one that we have is running everything on a notebook that is paired with the radio unit, and this is a base station, a 5G base station. We have used the machine to install also the Open5GS and Kamailio NIT, so we have everything in one place. We call it nomadic node. We use commercial off-the-shelf smartphones, so Nokia X30 in this case, and programmable SIM cards. And here we have more or less the same setup, the same computer and the radio unit, where Open5GS and Kamailio are running also on this computer. Okay, the SIP server box is missing here, but probably it's on the other slide. Yeah. A variation of the testbed, for example, we can let Open5GS running on another machine, and in this case we said, okay, in the cloud. We have servers hosted in the cloud, and we decided to have the 5G core network and the SIP server remotely. Mainly it's the same setup, just we distributed a bit the software components. And with this being said, just a bit more technical specifications, how the radio access network was realized with the open source project called SRS-RAN, and we configured it to use 40 megahertz bandwidth, and we set up the right frequency that is allowed to use for private 5G networks. Open5GS, we need to mention for those that are not familiar yet with, is using TAN interfaces to handle the network traffic to and from the UEs. So OGS TAN is the interface that provides the data services connectivity, and then there's another similar interface that you use for multimedia service traffic. And now about the experiment, we just run 10 calls of each type, and we are capturing before starting the call the traffic on the corresponding TAN interfaces in each case for later analysis. We went for 3 KPIs. The call setup time, that it is defined as the time between 100 ringing and invite, or on the PCSCF component, and another 2 indicators of the audio quality, the packet loss and the jitter on the RTP flows. These values that are displayed there are considered healthy value for not affecting the quality of the audio call. And yeah, here is just a visualization of a real voice over new radio call SIP flow that was taken and displayed with Wireshark, and the call setup time, how it was defined. And now going through the results that we got with our implementations, we come to the conclusion that the call setup time for our setup, the distributed one, so where every core network and the SIP server are in the cloud, requires almost 1 second, so 0.9 seconds. And for over the top is 10 times shorter, 0.09 seconds. One can have a rough estimation. Okay, the difference in these times, it's mainly due to the entire mechanism that voice over new radio needs for reserving the radio resources before the call can be initiated. The same measurements in case of the in-a-box scenario, so everything is running on a single computer. And we see here shorter call setup times because you don't have the messages that have to go from local base station to the cloud server. So 0.35 and 0.06 seconds for voice over new radio and for over the top. So a summary of the results will be the main outcome was that, okay, for reserving resources in a box scenario, it took 0.03 seconds comparing to the distributed setup where we had 0.08, mainly to the round trip time to the server in the cloud. Then let's have a look at the jitter, mean jitter and max jitter distribution for, first of all, for the distributed scenario. We see that the voice stream of the voice over new radio calls experience jitter either around 20 milliseconds or far below 5 milliseconds. And in case of OTT, the jitter varies quite a lot, but still under that healthy threshold in both cases. Let's see what happened in the in-a-box scenario. Mainly, voice over new radio showed the same thing, either 20 milliseconds or close to 0. OTT, it's the same variation. Also, in this case, it was below the healthy thresholds that jitter values. But what I found it interesting is that during the testing, when we placed 10 calls, yeah, we had, you see here 40 values because actually each call had two flows, RTP flows. But anyway, it shouldn't be 40. I think in this case there were 20 calls that we placed. And after 9th or 10th call, we experienced this increase in jitter suddenly, which means that, I would want to say means it's a signal that actually the QoS implementation in the radio access network software or even in the 5G core network software is not stable. It must. But I don't have much information on this. It's just a guess that why this suddenly happened. And it didn't happen only once. It happened in many running of the test of these 20 calls. So. About packet loss, it was quite negligible because there was no congestion in this experiment. But we also imagined another experiment where we tried to simulate the congestion in the private 5G network. And what we've done, beside the two smartphones that were attached to the network, we attached another one where to run the iPerf3 client, while the iPerf3 server was running on the server where the 5G core was running. And we injected traffic in the network. And what we see in the upper part of this waterfall diagram from a spectrum analyzer, we see while the spectrum, how the spectrum was looking when the call, an ongoing call was happening, and then we started injected traffic with iPerf3, and yeah, the orange color shows the congestion. And now we plotted again the numbers, and we see that in case of congestion, so on the upper side there's no congestion, on the lower side is congested network, and we see a worsening in the jitter, for example. The same for over the top, but still not over the healthy threshold. So practically we haven't seen any quality decrease in the call. Quality, not objectively, just subjectively, so we could state, I hear more or less the same. And packet loss, again, we plotted a congested and uncongested network on the same plot, and we see that the orange bars are higher for congested network. And what I can say, yeah, while the measurements are a bit worse, still not much affected the quality of the call. And very strange that a small subset of voice over new radio calls experienced even higher packet loss values compared to over-the-top calls. The overall evaluation where also the call setup time is showed. We had an increase in call setup time during congested network of approximately 60%, both in voice over new radio and over the top voice call. And I think that would be okay. Also kind of a small anomaly. The packet loss for voice over new radio was a tick higher than for OTT during congestion, but the difference was quite small, so no, I don't want to hurry with conclusion. So yeah, we can conclude. After seeing the experimental measurements and visualizing them on graphics, now more from the integration point of view. So voice over new radio is definitely a bit more complex to set up than over the top voice for a private 5G network. More than this, it requires voice over new radio capable UEs, which is also not easy to find currently on the market. Calls are placed user-friendly, let's say, using the phone dialer interface. And the biggest advantage maybe is that it works seamlessly also in idle mode and with a supposed guarantee QoS. For OTT, drawbacks would be that may miss calls in idle mode. There are some workarounds, but not that easy. It's a best effort delivery, but the advantage is it's easier to integrate, works on most devices, and you just need a SIP application to be installed. And you get access to all kind of rich feature services with that SIP application. Future implication of this kind of work, so our target is to have a comprehensive understanding of IMS and OTT technologies and to try to learn from each other what was done better in one and in the other, and if we can find middle path, so adopting from the other technology what was done better and integrated, and in this way to shape the voice communication in 6G networks. What I've said here, it was shortly a few numbers, but we published in the last year several papers on the topic, and they are already available by Googling. We thank you for the financial support from the German Federal Ministry of Education and Research, which supported the Open 6G Hub project. And of course, we thank Kamailio project and also Daniel for giving us some help with understanding what it has to be done for the N5 interface towards the 5G core network. If you are interested to find more about our research work, we have a website, and tomorrow we have a workshop, in-person workshop, with live demos from our chair, a selection of work in progress or work that was already done, and some presentation from companies that are active in this 5G, 6G space. So you are welcome to join us on Wednesday. Just drop us an email. Registration is free. Thank you very much. If you have any questions.
Thank you. Short time for 1-2 question, not two. Okay, I see many. I wanted to say not to keep you from the lunch, but then we can skip the lunch and have questions. Okay, you are first here, and then it's Marcus. I saw a few hands.
We have also an online question, our first one.
Okay. Thank you. Okay, I would like to ask, in your testing, you're using the stationary UEs. Have you tried with the mobility? Mobile UEs, because there was a research going on I've been part of for the Beijing University with the Huawei guys. They were testing the mobility for voice over NR in the mobile network with the mobility, non-stationary UEs.
Handover, you mean?
That includes the continuity of call across the handover. So we have one base station, we are moving towards second, so and there they implemented the MPTCP, multipath TCP, and they use some technology. I don't know what was on the signaling side. On the packet side, it was SIP over TCP, TLS. So the idea was to continue the call across the multiple base stations while moving in a van, for example. But do we have a setup here in Germany where the 5G this test setup is wide enough where we can drive a van with a mobile?
Well, you don't need to be wide enough, because the B210 that you are using is covering only a quarter of this room, probably. It's covering 10 meters or not more than 2 offices in our building. So it's easy to achieve this handover. We haven't tested in these experiments, but my guess it should work out of the box.
They have like 2-3 city blocks where they have this coverage. They allowed it, and they
physically move across.
Yeah, it's about physically moving from the coverage area of one base station to the other. But if you have handover working in the 5G network, so I don't see any problem of your services working well on top of it. So actually, it's about the 5G infrastructure. If you have handover implemented in a 5G private network, then it's working by default. And I don't think we have nowadays a problem with the handover. But we haven't used it.
It's supported in Open 5Gs, the handover?
I haven't used it personally, but I guess so. I hope, okay. I don't know.
It is? Okay. Marcus here?
Thank you for the insights. Yeah, we're Sipgate running an OTT service for more than 2 or 3 years called Satellite. It's a German mobile number in an app, so on the user space of the phone. And I have 2 questions. Which codec do you use for the tests on the OTT side? And have you ever put the phones under load? So I would guess that the native dialer application and the OTT service will have different process priority on the phone itself. So if you do like image indexing in the background, if this will have an impact on the OTT voice quality or not?
We haven't done this stress testing. Yeah, this is a good idea for our next paper, so to say, if you want to be part of it. Why not? With this suggesting in which direction to advance the research. No, we haven't done. And about the codecs, I have to say now it's a while since I saw these Wiresharks, the PCAPs. And I think it was EVS for voice over near radio. But it's a matter of the capability of the UE. So it is chosen by default. We cannot influence this. And with OTT, it was not EVS. With OTT, it was something else. But no, I don't.
Like Opos? Or?
Yeah, Opos. But we tested with several devices, and then you get different. But Opos was quite a lot displayed. Yeah. Yeah, we should add also this information, what kind of codecs were used, actually, because I find it pretty important.
Okay, here.
Yeah, I have the probably continue last one, but from the carrier side. For the OTT calls, it's anyways needs somehow to guarantee quality of service. To get the proper quality. Did you did some maybe research or tried even some exchange some parameters with the carriers which guarantee somehow traffic for the voice traffic carried by over the over the top? Yeah.
No, I'm not sure I understand the question.
So I mean, so the OTT traffic becomes just usual traffic for the carrier.
Yes, yes.
Yeah, so there is no difference. But maybe you did research, or maybe some standards become in development for prioritization of this normal usual traffic, in case like if it's voice or video traffic to be more to be better.
Yeah, I got it. I don't have exact insights here, but I quite guess there is something already in place because OTT behave unexpectedly good.
Yeah, there is on IP. We have also on Kamailio, but doesn't make big difference for the QoS of SIP packages. But I think also on RTP engine you can set there is like a bit or so with some priority on, that's only IP layer. So if the OTT, or not the OTT, the operators follows that by using the usual IP routers should put some priority on them. My conclusion, as I'm not much into the mobile network technology, but when I saw these results, it's like, okay, so if the OTT works bad for you, probably it's the operator that delays it, which was not.
The RTP packet is inside GTP, and I think on the GTP layer there's now quality of service for each stream.
Yeah.
So, no.
But then when it's going, okay, from the core network over the internet to the other device, so like.
That depends on the carrier.
Yeah. Okay. You had the last question because we get late with the lunch.
Yeah, it's just a continuity of this. Okay, sorry. It's just this a continuity of this concept because we are involved on some projects, on research projects related with improved latency and improved conditions on congestion, and we always focus on voice over new radio and new concepts to provide quality and reliability to the transmission of signaling and audio. But these results were opposite. These results points to an OTT just providing better service because...
yeah, but it has, we have to limitedly understand it because we had a very small setup, just one cell, just one 5G cell, and with 2 UEs attached. So nobody disturbed us. It's not under real conditions.
That's what my main question is if you consider that maybe the server-side implementation could compromise these results, and also the other question is why or how you could explain that voice over the new radio that it's defined to perform better, and that's what we are defending. It's working worse than this.
No, it's not working worse. They were both were under the healthy threshold, so they were behaving both quite okay. So none of the measurements went above of the healthy thresholds that were somehow defined by 3GPP in the specification. So the call setup time should be under 2.5 milliseconds. 2.5 seconds, and the RTP jitter and packet loss values are also defined in this specification. So in both cases, the voice over neural and over the top, we stayed within this healthy space, but in some cases, I noticed that, we had more packet loss, more packet loss for voice over new radio. But I wouldn't hurry and argue that in general voice over new radio is behaving badly. It was just our implementation. So it might be that we missed something in the implementation, or I don't know, maybe this voice over new radio is relying on the QoS mechanism of the entire 5G system, radio access network, 5G core network. So if it's not stable yet, it's not easy to figure out where it's still space for improvement. Is on the radio access network, or is on the 5G core network? Where is the problem? Why is not stable enough? But this is a problem maybe only of the open source projects that are now available that we use. We use the SRS-RAN and Open5G, so we can speak only for this. And at that point when we did the testing, because maybe meanwhile there are new releases, and it would be good to redo the test and see if the problems, the measurements change. But it was a starting
Maybe the
point.
conclusion is that both technologies are good. One, it's maybe seamless, like using the dialer. The other one has the overhead of installing the application. But you should not worry from technological point of view that you get worse quality with one or the other. So what fits better for you would be good now to use. Matthias, not to.
So our online question, maybe it's an easy one. Why don't you use eSIM cards instead of normal SIM cards?
eSIM cards involves a third party administrating them. And we don't want to depend on third parties, but we would like to look into this also in the future.
Okay, thank you.
Okay, thank you, Ramona, because we are 15 minutes late. coffee break. Then we'll have another session of presentation, a short break, and then will be the evening social networking event. I'm gonna tell them that I'm gonna close the doors because it's noise if they don't get in. Okay, guys, if you want to get in. We'll close the doors because it's noisy. We're gonna close the door. You get in because it's noisy otherwise, but you can get in if you. Okay, so I think I'm ready to introduce Thomas and Jan, the well-known video voice engineers that take care of recording, streaming, and also of the audio with the microphones. So again, really big thanks to the entire Pascom team, which includes also Matthias there and Sebastian here. So you recognize by their T-shirt very easily. The quality of the event haven't been like this without them. But actually they are also engineers or working in voice over IP. This is their main job, right? The day-to-day. And they have a very good solution for their cloud and on-premises telecom products, services, platforms at Pascom. I let them to tell more about themselves, but yeah, once again, I want to finish with thanks for your support for many of our editions. I think 8 out of 10 or so in premises, something like that. I think first or the second, or
I'm not exactly sure. I think it's 10th year, ninth, probably
I was
8.
Just keeping the online ones.
Okay.
So it's like 10 years or so, but or even sort of that. Many years. We are to count that, right? Okay. Thank you everyone for coming back. I hope you enjoyed the lunch. Thank you, the Pascom team once again. Thomas, Jan, the floor is yours.
Okay. Thank you, Daniel, for introduction and for having us, of course. So the talk is "Don't Lose Your Call." At least that's the title I have chosen, but the marketing forced me to also ask the AI for an appropriate title, and it came up with a longer one, SIP call handover across network transitions. So that's what we're talking about now. It's actually a rather light, high-level talk, so it helps you to digest your lunch. I hope that everybody had enough lunch. We have a couple of slides here to discuss a specific problem that we wanted to solve. It's a problem that many of you probably also had. Everybody maybe has a different solution to it. So the third slide is why not just doing the same like you did. Then what we actually did, and then a lot of details how we solved it, loss detection, reconnect, and things like that. So a few words about Pascom. So the annual disclaimer, like Daniel already said, we're not a video production company. It's just a hobby. We do it for the Kamailio World, and we do it for our own partner network, YouTube videos and stuff like that. But actually we're in the voice business. That's where we earn the money. So Pascom is a cloud-based solution, and at the core we have many Kamailios, not 80, but a couple of them, and a lot of asterisk services. Important to know is we have our own client applications on the 5 major platforms, so on the mobiles and also on the desktops. And our solution focuses exactly on our applications, so the full stack was in our hand in this case. So what's the problem? I will tell you a small story to introduce you to this problem and what we wanted to solve. So it's hard to imagine, but just let's pretend you're hungry now. You walk into a restaurant and you see this sign at the entry. It's nice. You get a free Wi-Fi. You can order your fish. You start to browse the web. You read the news, stuff like that. Suddenly your phone rings. So a customer calls you on your business number. It's forwarded to your Pascom app, and you take the call over the free Wi-Fi. You want to convince the customer that voice over IP is really a thing, and you start to talk to him. But the problem is suddenly the call is interrupted because you did not read everything. There was a little star beside that free symbol. So you will have just problems like quotas, bandwidth, tracking, and so on. Anyhow, for whatever reason, the Wi-Fi got lost, and you're in trouble because you want to sell something to that customer. So, a few seconds later, you're lucky you get the call back because we did a connectivity change over to LTE. The customer is a bit confused, but at least you did not lose the call completely, and you did not lose the contract with that customer as well. Thank you, Pascom. So connectivity changes can happen in many situations. So the 90% case in our company is you leave the building and get into the car. Because you leave the Wi-Fi cell, you get into the car while you're phoning, customer complains, I lose always the call when I go out of the building. So that's a typical use case, but of course there are many other use cases like here, the restaurant or limited Wi-Fi, but also you can come into this situation with a desktop. If you dock it, if you undock it, if you have, for whatever reason, a network change while you're phoning. So who knows about these problems? Who had the same problem? Okay, a couple of people. So I'm pretty sure that everybody solved it a little bit differently. So some of you can do the perfect solution because you're large enough. You have the full network control and you have a lot of low-level tools to fix this really in a good way. This is out of scope for us because we're working on the application layer, so we have SIP, Asterisk, Kamailio, but we don't have control over the mobile network at all. So out of reach for us. Yeah, it's SIP, so it's just a topology change, right? I can just send another invite and can use ICE to help me to re-establish the voice stream. Probably could work for us, but it was not very appealing to us. You will see in the next slides. So actually we didn't really try it out because we had something else in mind. This is a simplified picture of our cloud solution, the Pascom Cloud. So we're hosting all our services in AWS over multiple data centers. We have a couple of load balancers there, IPv4, IPv6 for the SIP traffic, for our API services, and so on. Important is that we do SIP only via TLS. So there's no UDP, something like that. Only TLS connections are always a stateful connection to the specific load balancer, to the specific protocol. And of course, if a reconnect happens, you will end up in a totally different Kamailio instance, probably on a different load balancer. You might have a protocol change from v4 to v6 and so on. So complex. Important to understand is that we don't share anything between these Kamailios. So we don't have a central database between the Kamailios. We don't leverage DMQ. So those Kamailios are as lightweight as possible. There is also a form of RTB engines, but we're not forming pools of them. So here's the same situation when Kamailio talks exactly to one RTP engine. There is no shared knowledge about the calls in this layer. Behind this Kamailio and RTP engine form, we have thousands of asterisk processes, really controlled by microservices. So this is the only place where we have shared knowledge about a call, about a user and things like that. So what we did at the end is we said, in this place we have all the knowledge that we need to reconcile the call, and we wanted to use that. So basically we said, just create another call and bridge to the previous call. We simply rely on the 30-second RTP timeout of asterisk. We have the same RTP timeout also in the RTP engine, and if you're not fast enough to bridge the call again in 30 seconds, it's useless anyways, because the caller will surely give up after such a long time. So basically, the steps are we try to detect the connection loss. How we do that, you will learn from Jan a little bit later. Then we reconnect our own API. That's important to us. And the API already was structured in a way that the server will send you
all ongoing calls because we have multi-device support, and that means if you would start a second or a third client, it will already have to know there are ongoing calls. So existing code. Then we simply dial again into the same asterisk, and then we bridge to the previous callback so that you can continue to talk. And only the steps, actually 5 and 6, are new. Everything else already existed. Therefore, this was a perfect fit for us. Bridging the call is very easily done in asterisk. We just send an AMI action to it, the bridge action. Of course, you need a few variables to populate here, channel IDs and such things. But as I mentioned, we will hit the same asterisk service. We already have that data in the API service, so that's rather simple. Of course, the world doesn't end here. You could talk again, but at the end of the call, you want to have a proper journal, proper CDR records, and so on. So we need to clean up a bit call state and such things, but basically it's not a big deal doing it that way. So benefits that we've got with our solution. First one is most important, we have full control. We can inform or entertain the calling peer while we're re-establishing the call. So that means if it's 3-4 seconds, silence is perfectly fine. After a while, you want to explain what's going on. You might want to play music, or you might want to drop that caller into the voice box to at least give him something. And that's, of course, easier in the application layer. We could share a lot of code, like mentioned in the previous slides. There's also another feature that we have, continue call on other device, multi-device support. You go out of the office, you put down your headset, you continue on a mobile phone. It's almost the same. Basically, we're doing a pickup. And also important to us is it's more or less signaling agnostic. So we can use it with our 2-day stack using pgzip on the apps, but tomorrow we can use the same approach also with WebRTC and totally different signaling if we want, as long as we hit the same asterisk instance at the end. And very important to us, we can even fall back to a GSM dial-in number because that's also something that we have by default. So in areas where we have a pure data connection, the customer can already today choose to just use GSM dial-through. And that means if we even lose the LTE connection, we can at least try plain GSM call. Better than nothing. So that's what we did. Jan will explain how we did it in detail.
Yeah, actually, I will get a bit more into detail on how we did it on the client side, because Thomas already did a good job explaining what the server does. So just to reiterate, I will first talk about the loss detection. And it needs to be fast, because if you are directly in, if you are in an active conversation with your colleague, you probably have something like 5 to 7 seconds until the person holding the phone will notice that something is wrong because the other side doesn't answer anymore or something like this. And after that, they will start fiddling with the phone and probably just hang up and call again because they say, yeah, it's broken. So the loss detection needs to be fast. And also, as already mentioned, we have 5 different platforms. So Windows, macOS, Linux on the desktop side, and Android and iOS on the other side. So we have a lot of different tech stacks we need to have a look at. So we considered, at least briefly, 3 different options. And I will try to go through them and explain why we arrived at the solution we did and why we didn't choose another one. So the first thing we looked at is, yeah, every modern operating system can tell you if it has a network connection. Most likely even how good it is, or if it's metered, or if anything else. So you can get a lot of details and you can get notified by it. But the problem is, at least in the tests we did, most of the time this detection was too slow. Because it's meant to be, do I have internet at all? It's especially on the mobile device, it's meant for use cases like, can I start, I don't know, synchronizing emails in the background? Or can I start a bigger download of some asset because I'm on an unmetered connection right now and can cache it once the user is again on the road. And so all of these APIs did not really meet our 5-second target of telling, okay, do we have loss right now? Do we need to do something right now? And also, it's complicated. So we have, on Apple, we have the network path monitor, which you need to talk to in Objective-C or Swift or low-level C if you want to have fun. Android's connectivity monitor is written in Java, of course, so you need to bridge there somewhere else. Then we have, on Windows, it's good old COM APIs, which are their own kind of fun. Apartments, threading models, anyone? And on Linux, of course, there is the dbus network management, which is in scope for the target platforms we support. So there are still Linux users out there which don't use systemd and dbus, but they are not target for our application because it just gets too complicated. Anyways, what I need to mention for this is we have a single code base for all our different platforms. So we are too small to write 5 different applications for each target platform. So we wanted to have a solution which works cross-platform ideally. So all of this means that using or relying on the operating system API solely is not helpful for us. It didn't meet our goals. Especially because our goal actually is, can I talk, can my application, can my app talk to my API right now? And not, do I have an internet connection? That's a slightly different use case, actually. So the next thing we looked into was RTP statistics. And Ramona did a very good job explaining all the nitty-gritty details about this and all the test runs and everything. So you can look into this, and then there are awesome protocols like transport-wide congestion control for WebRTC and everything. But it's sometimes hard to get a definitive yes or no out of this, all of this data, and you need to write probably some code evaluating the statistics or something like this. And this is the second point, you need to do this basically per stack, because probably pgsip will behave slightly different than JSZip, than a WebRTC stack, than something else. And these are all options we want to consider in the future, especially going forward with new technologies. So also, we tried, or we actually had a bit of a prototype on this, but we decided to not use it because it got too complicated too quickly. So we have a WebSocket connection, which we need for our API anyways. So it's a live connection. We are exchanging not zip data on it, but other things like that, for example, chat messages and stuff and so on. And this connection, if the application is active, is there anyways. So why not use this to tell if we can talk to our API? It's very simple to implement. We have the stack here under our control on both sides exactly. So both sides is our code written by us, and it's independent of any zip stack, of any other technology. And especially WebSocket ping message is very small. So basically you only have the header and the opcode and an optional payload, which you don't even need. So it's just a few bytes. So compared to 1 second of voice or even video, it's a negligible overhead. So you don't actually notice it at all. But what this gives you is basically a kind of a watchdog connection. So what we're actually doing here about the time is, when the user is in an active call, which we know because of the state, we just ping our server every second via the API connection. And if we experience 3 ping losses in a row, we just assume that the connection has been lost. Okay, what does this mean, connection has been lost? So our client application now has the assumption that something's wrong with the network. So we don't, and this is not a binary scenario. So if you're leaving a building, the Wi-Fi you will get increasing packet loss counts until it cuts off. But what the mobiles especially the mobile phones are especially good at is detecting this already and firing up the 5G or LTE baseband and running the connections in parallel. But we are still on the wrong side of the funnel because we are still going via the bad Wi-Fi connection. All our API connections, the persistent SIP connection, and the RTP connections are still using the Wi-Fi channel, which will get worse and worse until it cuts off. And what this means is, as Thomas already mentioned, we can have a change basically from anything to anything. So it could be our IPv4 only Wi-Fi network, and then we can go to IPv6 only 5G network. So there is not much state we can carry over, but we have a lot of local state we need to consider. So especially, this is a mobile phone. You connect your mobile phone to everything. You have a headset on your head probably. You connect it to your car. You have you have your smartwatch which shows you call information or whatever. And especially on iOS and Android, you have the problem. If you tear down your active call, you probably need a user interaction to re-enable it. So if you shut down the microphone because your call ends and you telling the CallKit API on iOS that the call has ended, it will go into energy saving, it will shut down the microphone, it will kill your audio session, and you can't get it back until the user taps the phone again for security reasons. Otherwise, every application just can go on eavesdropping on you. And on Android, it's basically the same. The API is called connection service there, but the story is the same. So until this timeout, this RTP timeout of 30 seconds or a bit less actually happens, we need to pretend to the operating system that we are still in a call. So we need to keep the local state and very aggressively try to reconnect the WebSocket connection. So basically we do connection attempts, I think every 2 seconds with a bit of jitter to not have 2 regular intervals. And then we try to establish that WebSocket as fast as possible again. And what we actually do is we restart the SIP stack. So just to avoid any fun with PGSIP and network transitions, I know that recent versions can do it, but there are a million edge cases. So we just shut it down. And once we have the WebSocket connection back and know in which network we are, IPv6, IPv4, and so on, we just restart it. It re-registers, and then we can go back to bridging into the old call. And it's usually, if the connection is good enough that we actually can carry voice over the top, the connection quality is also good enough that the SIP stack registers within 1 second. So for the user noticeable impact is not really there of restarting everything, and we have a clean state and can resynchronize our own state with the server again and just can continue the call if nothing happened. All of the other callers here is probably a beep. Yeah, that's it. There's only one thing left, and that is handling failures and timeouts, and that is, of course, if one side runs into a timeout, you just clean up the state. It doesn't match anymore on reconnect, and so the other side also noticed that the call is lost and just cleans up everything. And so, for example, the car can go back to playing music again instead of switching to the hands-free profile for calling and all of this stuff. And we need to do the same thing if our application keeps to be offline. We need to also handle this correctly if the user, so we can't just lock up the application and say we are reconnecting. So if the user decides, okay, I don't want this anymore, go away, we need to clean up the local state, of course. That's just a basic user experience thing here. Yeah, that's basically it. We try to keep it as simple as possible, and it worked out for us. Questions?
Thank you. We have Mohammed here.
Yes, we have a kind of a similar setup. What we were using WebRTC and we were using RTCP with ICE. So it worked pretty well for us. It took a lot of time and a lot of complexities to go through. My question is, when you reboot the stack,
yes,
doesn't it has the same problem with the with access to the device and audio, video, and so on?
No.
Isn't there any conflict with it?
No, I can tell you. So on iOS, for example, I use one of the examples because the principle is the same, but the implementations are similar. So on iOS, what you actually need to do is you need to go to CallKit to register a call. Then you get this little green bubble in the top left corner, and when you tap on it, your application goes into the foreground. And that's the first thing you need to have a VoIP call at all, especially if the device is asleep and you get an incoming call via push. First thing you need to do. Then your application runs and you're free to do basically anything. So we set up the WebSocket connection, connect and receive some information. We can look at the WebSocket and see is it V4, is it V6? And then we can already use that information to shove it into PGZip to start it with the correct parameters, to set up the correct transports and everything. But what you need to do completely independently of this is to also set up an audio session on iOS. And that's the thing that gives you access to the microphone. You need to do this before you basically rescan PGZip devices. And then PGZip just finds one audio device and can use it, and it's the microphone the user selected. The zip stack doesn't have any more interaction, so it then can go on and receive some WAV frames and can go on and code it as Opus and send it out via RTP.
Okay.
But it's completely separate things.
We had this, for iPhone, for example. What we used to do is via RTCP, we detect that this connection is about to go down.
Yeah.
So we kind of do similar without rebooting the stack. We send a push notification to try to notify that you need to reconnect to the server.
Mm-hmm.
And it basically first starts a local call to loop back the audio to keep the audio devices intact.
Mm-hmm.
And then it created a new re-invite over the new network so that it can reconnect to our server without having to reboot the stack.
So your WebRTC library did the audio session management by itself, because we're doing out of all the audio libraries and everything. We're doing it ourselves before we start any audio, because then the session is set up correctly, and we have full control over it on the device and can reconfigure it or tear it down as we wish. And so basically, we keep the audio session. The loss happens. Mm-hmm. We just continue to keep the audio session until timeout. Mm-hmm. And then when it comes back, it just finds the working devices again.
Okay. It depends on your stack.
Yes.
Yeah, it basically depends on...
Okay, one more question here, Marcus.
Might be a complicated one.
No.
I'm scared.
Have you ever played around with TCP multipath or UDP multipath? So that the application triggers the network layer to directly open two connections to your infrastructure for the Wi-Fi and the 5G, 4G connection, and doing the magic at the network layer?
No.
No.
No. As I mentioned before, we had already a lot of that code, and we did the next possible simple step that we could do. It might not be the last step that we're going here, but for now, it solves the I'm going to my car use case. Mm. And that's what our customers wanted.
So the customer complaint or the use case we actually wanted to solve basically is I'm leaving my office Wi-Fi, going to the car, and I want to have one continuous call with this. I start the car, it switches over to the hands-free, and then I can talk the whole time.
And I expect my CarPlay to be working.
Yeah.
Okay. Okay, last, if it's short.
Yeah, just a quick question. Have you made the tests, for example, for other voice like WhatsApp, comparing the latency between switching the networks?
Not
So-
really.
Not really.
Not really.
It was
Easy
fast
one.
enough for our use case.
Okay.
That's-
Then thank you, Jan, Thomas. Kamailio taking the time to come to this event. I'll let you say more about
Thanks.
and the floor is yours.
Thanks for the opportunity. So in this brief presentation, I wanted to talk a little bit about troubleshooting media negotiation in WebRTC environments. First of all, a little bit about Signalwire, who I'm representing today. So Signalwire comes from the creators of FreeSwitch and has become a reference point, and it basically built on top of FreeSwitch what can be called the CPaaS. And the vision that is now being presented is called PAC, Programmable Unified Communications. So you can build your own service on top of it, and so you can do SIP, PSTN, WebRTC from SIP or from an SDK, and there's also integration with AI agents. So you can get something very similar to what David demoed today on top of Signalwire as well. And a reference every year is the ClueCon conference in Chicago. So there you can see the latest, you can present your own projects, and it's a very good conference to attend, in my opinion. So if you can, I suggest to do it. And Signalwire continues to work on the core of FreeSwitch. So I'm presenting a few news about it for who's interested. There was the 1.10.12 release, and there was the drop of Debian 10 and CentOS support. And a bunch of tools that reached end of life were abandoned: Jira, Confluence, Crowd, and Bamboo. And a few links for developer documentation, where to report issues, and so on. The next version, 1.10.13, is under development and could be released across ClueCon. One of the improvements was to get rid of some modules that were not really maintained, so easier for developers to embrace the project. And in terms of support for Debian, the Debian 11 and 12 are officially supported until end of life, and then there's work ongoing on Debian 13. And if you have any questions, you surely can find how to reach the community. So the goals of this presentation is basically a short version of another presentation I'm preparing, and it's in general about troubleshooting WebRTC calls. It comes from the experience of a couple of years working with not only with customers, but with developers that develop their own services on top of Signalwire. And sometimes we find a little bit of friction in understanding where things go wrong when establishing WebRTC calls. Now, most of these concepts are not completely different than more traditional VoIP establishment, but there are maybe a few additional tools and caveats that may be interesting to discuss. So obviously, even WebRTC is theoretically peer-to-peer. Typically what happens is there is a client and a server, and the media, which is the focus of this presentation, flows through RTP streams. So this needs to be negotiated, and the core is the offer-answer model using SDP, and for free from the WebRTC and from the browsers, and for which we get DLS encryption of the SRTP flow. But in order to do this, this negotiation, there's need to do the exchange of SDP need to happen, and there isn't a standard way to do that. So basically, the signaling protocol was never really defined, and in some cases, SIP is still used, even though it's not the most common, and many have their own protocol. Eventually, it's just a way of transporting SDP offer and getting the answer back. One of the concepts that we try to educate our customers on is the concept of ICE candidates, because they have a key role in establishing the RTP sessions and also establishing them in a sort of timely fashion, not too slowly, and in a successful way. So other concepts that come useful in the discussion is ICE, which uses STAN as the protocol, and in some cases TURN, which is an extension of STAN. So a few things that maybe are known by most of the people, but just worth mentioning. Different ICE candidates, host, server reflexive, and relay, and then peer reflexive, which are the ones discovered dynamically. I think this one maybe is the easiest way to identify them. So a browser, which is typically behind NAT or multiple NATs, can detect its own direct candidates, which are called host candidates, and they go out through one IP and port. And again, there could be multiple levels of NAT. And they discover the server reflexive candidates. So what's the actual public IP and port that is visible by something in the public internet, like could be, say, the Signalwire platform or other services. So they can be discovered as they go out, which are the server reflexive, or there could be an active allocation of a relay session on the turn servers. And in this case, the browser discovers the so-called relay candidates, which again are communicated in this very simplistic case. So the browser is talking to FreeSwitch through Kamailio, so it's using SIP over WebSocket. And what it does, it's communicating all the candidates for establishing the media negotiation. And this applies to both inbound and outbound calls. So it's basically the same mechanism is used whether the browser is calling the platform or the other way around, the browser is receiving a call. So in seeing in a sequence that also represents how quickly some candidates can be detected. So when the WebRTC starts gathering the candidates, the first one that are available are the local ones, which are the host ones, and they can potentially be communicated to the remote party immediately. Then the quickest discovery is the server reflexive, because it's sufficient to send a stand binding request to a stand server. You get a response that tells you what was the IPM port that was seen as the source of your request. So, and also this one can be communicated to the remote party, or there could be an active allocation of a relay transport. In this case, the WebRTC application talks to a turn server, allocates. If the allocation is successful, gets back a relayed address, which is also communicated. So this is an ideal scenario where it's a trickleized approach, where as soon as you discover a candidate, you send it over to the other party. So if, for example, before you have discovered a relay candidate, you already have established correct bidirectional communication with the host candidates, you can just use them. You don't need to wait. What happens more commonly in some cases also with FreeSwitch is that the candidates are gathered all together with a proper, say, timeout, and then they are all communicated at the same time to the remote party. So this is less efficient, but maybe more typical. Yes, so this is basically the difference. You can communicate them as soon as you discover them, or if you can, that's more efficient, or you need to collect them and send them in one single SDP offer or answer. And it still happens that many scenarios, like in particular call center agents, can be under NAT, and turn becomes not only an option, but sometimes a need. And also using port 443, which is a way of basically having a generic way of saying it's the most probable way out from this NAT is port 443. That proves to work typically. However, in the definition and in the implementation of WebRTC itself, the relay candidates are assigned a low priority because they represent anyway an additional hop networking wise. And also, well, yes, there is also some price to pay for acquiring the allocation in terms of first of all, it needs to be authenticated. There's some time spent back and forth authenticating the request, and then there is bandwidth used. So you pay for the efficiency, and you get the necessary relay. So, but STAN, which is quite generic because there is the STAN protocol, and then there are the STAN servers. But in general, it's not used only for media establishment and finding the best candidates. It's also used during the call for simple verifying that the call is still up, the other party is still there responding, and the time that it takes the other party to respond is also used to measure round trip time. Yes, there could be cases beyond not traversal for turn. There are some cases where you may want to put your turn servers very close to the browser so that you have a shorter path between the client and the turn servers, and you possibly manage better the path between the turn servers and your media backend. So in terms of troubleshooting tools, what we try to promote with the customers and the partners is very common tools like TCP dump and the related family, Wireshark for analysis. We do have Omer and Epic for anything that is over SIP, and also for getting on-the-fly RTP metrics. We have an internal service which we may publish at some time, which is called RTP Insights, which basically goes through the RTP traces for calls and does the analysis, the post analysis to verify what was going on in terms of quality and media establishment. And of course, there's the WebRTC RTC stats, which are exposed, which is an API that is exposed by tools like Chrome WebRTC internals or Firefox about WebRTC and Safari in the WebRTC login. What we use also internally is we do end-to-end tests, which is somehow related to the Sipfront approach of regression testing. So we have end-to-end tests that are always running in the platform, and they basically simulate the browsers inside the CI environment, and they use the RTC stats metrics to establish that the media was flowing correctly as expected. So they're super useful. Many use the service without knowing them. You can dump all the metrics in one file. You can even now, recently, you can get the audio recordings of everything that was received by the tab or played out by the tab. And you get, probably many are familiar already, you get all them graphed into a human visible and easy to understand graph about what's going on between, in this case, you can see candidate pair, and you can notice something like current round trip time, that's going to be 120 milliseconds, and with a few fluctuations, for example. Some useful Wireshark filters, if you get a big pickup, want to know what's happened, a Stein level and turn level, you can use them. They would be in the slides. So in terms of typical issues that we found reported by the customers, timeouts, trying to establish the sessions, high latency in the audio, silence, even though everything looks fine at RTP level, audio disappearing during a call, and obviously classical choppy audio. So timeout, typical case, network unreachable, nothing really new. Many call centers still have the agents all behind NAT, and sometimes they just need to go over turn. And of course, turn over TCP is an option if it's really needed. It's not good for latency. So it could be a way of establishing the call, paying for maybe some audio latency degradation. Or we see DTLS establishment issues depending on implementations. And even there is a trend in call centers where they basically establish one session between an agent and the system, and they keep it for hours, so that they basically just put the agent on a conference with the customer every time it's needed, but the actual call in the browser is still going for hours and hours. And then you need to ensure that if you're using turn, for example, the credentials that typically expire don't, or otherwise you will end you won't have audio anymore. High latency, easy to see in the round trip time graphs. Of course, turnover TCP is a gamble, could be very impactful on latency. When there is silence, sometimes RTP is flowing. There are, 50 packets per second as expected. The RTP streams are there. It's not easy to see what's in there because it's DTLS encrypted, so you cannot just listen to it as easily. But there are some other elements like the audio energy from the RTC stats that can tell you very, very easily whether the decryption of the RTP incoming was actually successful in detecting audio and playing it to the tab, because sometimes it does, but the headphones are disconnected, which is something that happens, and it's a true story. And also, if you extract the audio from WebRTC internals, you would be actually able to listen to what the user of the tab would have heard. So audio energy, also drop packets. If for any reason the RTC peer connection isn't connected correctly with the incoming tracks, there would be no audio played and packets may be dropped because they are not used. I'm a little bit short of time. Do I have 1 more minute? And then there's the typical choppy audio with typically very visible from packet loss. And 2 of the important metrics in this case is the RTP inbound, which is what the browser received, and remote RTP inbound, which is what the other party claims to have seen. So something that may be useful to see in a working example, simple application using Zip.js, connecting to, let's see, WebRTC internals, Zip.js, placing a call. Sorry. Placing a call, so maybe it's not audible. It's just, I'm basically playing just a programmable XML on Signalwire, play some music, and you can see, in this case, if I hadn't, you can see a summary of what I was just mentioning. So, summary of the current trip time, 140 milliseconds, bandwidth, and so on. And, I mean, if we just launch a trace just for a few seconds, you can see easily the RTP streams, you can do the analysis, get some useful feedback. Okay. As I mentioned, this is part of a larger presentation that I have, and I think I'm out of time. But if there are any questions.
Thank you, Giacomo. Let's have a question. At least one here. No.
I have 2 questions, but I'll ask just the first one. Just a request, why not bring the Clue Clown to Europe instead of US, because it's kind of a no-go area.
Yeah. I don't know, it would be better also for me. I will ask, yes.
Yeah.
Also in Sardinia would be very handy for me.
Okay, that's a question for the organizer. But then Giacomo is going to be around here, so he has a huge experience also with Classivoy, but with WebRTC. So if you need him for sorting out some other questions, please approach him. Now we go quickly to the next speaker, which have.
Here, I'm very proud to present again Homer 11. No, I'm glad to be here again. So, my name did not change. I'm Alexandr Dubovikov, co-founder of Institute of QXAP BV, father of Hep and Homer and my son Maxim. I have over now 30 years experience. Now I'm recognized what I'm old. Yeah. And I like Daniel already said, my fat fingers has been involved in each open source project what related to telephony, etc. So, like it's here, it's the names of these projects where my fingers has been left some code. So QXAP is lead developer of Epic and Homer, and it's located in QXAP like Homer guys. It's located in Amsterdam, headquarters, but we have a team across all worlds and 3 continents. We do research and development in open source and also commercial observability technologies. We have customers from startups and from Fortune Corporation. We are, like I said, fully remote, distributed DevOps teams, and we don't have we self-made company. We don't have any VC, any investors, and therefore we are free to develop and jump to new technologies without any limitations. We use Robinhood open source model, and thanks for our happy customers who give us possibility to work not only for new open source, but also sponsor another open source like we did for Kamailio. And exactly, we do what we do, and we do what we love. So, about, it's Lorenz presented Homer 10, it was last year, and based about Homer 10, let's talk about this, what has been done. If you probably already recognize all 11 versions of Homer, it has been experimental. So we have 3, 5, 7, etc. 9, it's 7.7 normally. So it's, don't ask about where is 9. And we, with Lorenz and with team, we did some research how to connect old world of telecoms and you guys, let's say old world, yeah? You are a little bit conservative and connected to new world, new telecom observability, which a little bit more modern. And our idea was to integrate Homer to Grafana, and we did it. We did this plugin inside. And of course, with Homer, we have especially many thanks to Tori. He is not here, but he did a lot of job, a lot of testing, and he loves a lot of this stuff. And based on feedbacks, what our Tori and another users use in Homer 10, it was good what we still back compatibility to all HEP agents, so you can connect Kamailio, FreeSwitch, etc., etc., etc. We did deep Grafana integration with Grafana app, so you can use your Grafana for metrics, you can use for statistics, and inside you can make a search in Homer and make call flow, make statistics, click on call, find another lex, etc., etc. This is what I said, it's everything is in one platform. You can also use like vendor agnostic any target. You can integrate your Grafana to your special CMS, etc. Integrations. Some mixed feedbacks is everyone is missed Homer UI. Yeah, I said, Grafana is good. But where is Homer UI? Where is Homer UI? It will be great to have old Homer UI. Yeah, you guys, you're so conservative, but okay. So Grafana is also nice, but we would like to have simple interface, click, 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 and so. Also, all of database what we use inside is ClickHouse. Also, ClickHouse is good, but 90% of my time, if I would like to make scalability, yeah, so cloud, it's I have to integrate spend all my time, and you guys, you're right. Yeah, so you have another voice therapy stuff which you have to fix it, and now you have to work on also on database. So it's absolutely we heard it, and we try to fix it. So Homer 11, yeah. So like we said, it's last 2 years we worked very hard on querying. It's called Sealocky querying, and now it's called Gigapipe. It's special observability platform which can collect all metrics, data, statistics, and probably here's the people who use also querying inside in companies. And based on our experience and on our research in querying, we decide exactly to connect, like I said, all telecom world with new observability analytics. And do you remember this Toy Story, yeah, when Booth said, files are everywhere. Yeah? So it's here also. If you just close your eyes and said, what is MySQL, what is Oracle DB, Oracle DB, DB2, and so, etc. It's normally just a files inside. Yeah? It's files. It's nothing new. Yeah? So it doesn't matter if it's Windows, Linux, it's files inside. And just CLI or API on front on these files, which you can make SQL, like for counters made query language, select from blah, 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 blah. But it's at the end, it's go to files, read the files, show you data. Very simple. And exactly our goal to achieve this simplicity and also to bring to Homer 11 and achieve some very important points. First, we decide to go to Parquet. So do you know Parquet? Yeah? No? Okay. So normally Parquet file it's like a container for columnar-oriented database, let's say data. It has been developed for Hadoop. Do you know Hadoop? Yeah. So Hadoop. And normally it's a file which has inside some metadata and it's columnar stored data inside. So these files, you can very easy to create, very to use. So normally we created Parquet files to store all data inside, and later I will explain how it works. So Homer is a generic data store for telco and data telemetry. It will be, yeah? Also built with DuckDB. DuckDB it's application which can be embedded or used extended to read with Parquet files. In this format, it can be also Arrow. It can be some OpenTelemetry. It can run anywhere. It scales without any limitation horizontal, so you can install on next box and save this data. You can use also HTTP REST API, use FlySQL, and of course use Homer UI, Gig API. I will show what is it, and Grafana. And of course, it should be very, very cheap for you guys, because right now, if you use Homer, how long days you can keep data running? So maybe 2 weeks, yeah, because it will be explored. With Parquet files and also with internal, let's say, compression mechanism like LZO, LZ4, etc., you can compress over 50% in good cases. And this means what you can store your data for a long, long time. So how it works? So normally, of course, injection. Has been not changed. We still use HEP agents, which de facto, it's standard in any open source platform. Doesn't matter what is it, Kamailio, FreeSwitch, Asterisk, etc. We send HEP. We can inject HEP. Like I said, it's de facto, it's already standard, and also commercial vendors integrated HEP inside. Maybe you use some of them. This is BCs, and you can send also from commercial platforms. If you have or created a new application and you would like to integrate HEP inside, it's very easy, because we have for all languages libraries and clients. So next. Of course, if you run Kamailio, and you should care not only about SIP traffic, yeah, or FTP, statistic, analytics. Also, you have to think about, I have some CPU usage, memory usage, TCP, UDP drops, etc., all the statistics. And you can still use our platform to send all this data without any limitation, because we support all agents, OpenTelemetry agents, what exist on the market right now. It's you can send from Logstash, Grafana agents, vectors, etc., etc. We can support it. We can store it to this Parquet files. and make analytics. For example, like Pascom guys, we said, we send RTP statistics in special format. You can also send the statistics to us, and we will store in this Parquet file, which you can, later I will show how, you can make analysis, make some statistics, make some charts. What is next? Let's talk about Parquet files. So, like I said, you send this data to Homer 11, so it's like concept. No, not concept, sorry, it's engine. You will send this HEP data, you can send OpenTelemetry data. We receive this data, and we start to store this data to Parquet file. It's normally it's small files first. Yeah, we store like, because we are in time series. We store these files. After, using DuckDB, we make compaction. So normally, because you should not use too many small files on this system, because it will be load average will be high, and etc. So we compact this data, and after, once the data has been compacted, you can store this data everywhere. So, for example, if you use S3, Amazon, you Google, you use R2 in Cloudflare, or you can also install this Minio on your local machine. You can keep this data in this storage without any limitation, because it's very cheap. If you compare S3 on your local machine, it's storage it will be cheaper. And using this, so you store this data inside, and that's it for now. So what happens next? This is exactly how this API schema. We have this Parquet Hive. So normally it's data. We have MyDB, whether it's in stable name. Date, in this case, is our primary key. And inside we have sharding. Yeah? You can, it depends of how much data you would like to store and how good it's, you would like to make search, how quick. You can also define sharding key. Also, for example, here we store each hour, but you can decide also, let's store each 30 minutes or each day. So it's, in this case, in this chart, we will store one file. And here is compactor. So we store 100 megabyte of data. Second, we go to level 2 to level 3. Target, we compact everything to 400 megabytes. And the second stage is we compact everything to 4 and plus gigabytes. So it's normally, at the end, you have one slice. And don't worry about how quick we can read it, etc. Because the data inside, it's stored in columnar. So you don't need any index, because its index is already it's data, because it's sorted already in how you need. So it should, like you don't stop thinking about like in a DB, I would like to keep index here. It's already done. You can just query this data in time range, and you already have a sorted data. It's very, very, very fast. And also, what is very important, with Parquet format, it supports now with many databases. So it's also, you can use ClickHouse to read this data. You can, you start local ClickHouse, you say, my data is located on S3, and you start remotely all data very, very fast, because you should not download this data. It will be storage, will be just read the columnar position, and we will make a seek of this data inside. So it's very fast. DuckDB is also this way. You can make use DuckDB or Databand and another, let's say, engines. So now it's how we can use this data. In Home 11, we already did same concept what we started in Home 10. We use Grafana. It's Grafana. It already works. You can read and ask this data through DuckDB and our API, and it will be displayed with data. You can see all zip calls, all traces, all information, statistics, etc. And of course, you can see in Grafana it will be call flow. On the right side, I will show later, is Gig API. So do you remember it's PHP myadmin? Yeah? So you remember? No? Okay. It's similar. So normally it's SQL interface to data what we already stored, and you can read any data inside using a scale of syntax. You can read this data, you can display this data in raw format, in JSON format, and also you can immediately start to working on build the chart on this data. It's similar like Logstash does, yeah. So you make a query, get data, display chart statistics. Okay, and here's gaps, and etc., etc. And of course, you can use also use curl HTTP request, make external application. It will be work also fast. So now, from left side, like I said, it's Grafana. It's already integrated. You can make any search on any fields in Grafana. You can add from user to user, etc. You can make search parameters. It's on the left side. On the right side, it's Giga API. It's also already works. This is how it looks like. You can click on any trace ID. You can correlate it, and many more. So here's like a little bit more detailed. It's in Grafana. You can select this DB name and table. For example, HEP1, it's our zip information for calls. Yeah. You can also make a search field. It's here. It's call ID from user, etc. And inside, you can also make each field or each header what you have in zip. You can make extract it and make a search inside. Yeah. So like I said here, it's you can have different type of tables. HEP1, it's for normal zip. HEP100. It's for logging, HEP5 is for TCP statistics, and etc., etc., etc. And of course, you see, call flow works without any limitation. Like I said, with PHP-MyAdmin, so it's normally a SQL interface. When you see, you can do select from HEP, when method invite, kaboom, and you have already data. You can click on charts, and it will become immediately makes data makes charts on the data what you immediately returns. So it's used on DuckDB. It's like I said, it's DuckDB. It's can be or external application, can be embedded application inside of our application. You can also DuckDB. You can also run like WebASM in your browser, and you can use WebASM to get a query to your remote S3 data. So cool. So, and of course, like I said, we heard you. We working hard on new Home UI application. So this is a Home UI application for Home 11. It's a completely new framework. It's for Hennig. It's not based on Angular. Yeah, Hennig. It's something modern from Facebook. And yeah, it already works. We are working some additional stuff. What is full picture? Just in its overview. HEP send data. We store data in local storage. You can store this data forever. You can use this data in later medical harving, etc., etc. This is you can send telemetry because telemetry is very important right now. Without telemetry, you could not do anything. And yeah, you have no locking on any vendors because Parquet format is open. If tomorrow will come new, let's say, DB stuff, not DuckDB, or maybe it's okay, HazardDB, let's say, and you can read it without any limitation. So our roadmap, it's here. In the last, let's say, months, it's 2 minutes. In the last months, we finished HEP Agent Go. It's who use RTP agent in HEPIC environment. You can upgrade to HEP Agent already. And based on this HEP Agent stuff, we will create a new Heplify 2.0. It's will be new generation. Rita will work on ZipTrace NG for Kamailio. Rita Wops, she's here. She's our director of cloud services. GigaPI, it's already done. Home 11, we are already working on it very hard. Grafana, it's done. We will release next weeks. And yeah, we're working hard on Epic 5 UI. It's next generation. And yeah, we go forward very, very well. So about QXIP Gigapipe. Gigapipe is our daughter companies. Like I said, it's provided some cloud management service for observability and statistics. If you want if you have any question about this Gigapipe and etc., you can go to Rita. Rita will help you and answer on all your questions. Yeah, so thank you so much. Yeah, support open source. I would like to also give many credits to our team of QXIP, because without very hard work, it will be impossible to do all these amazing jobs what we did in last year. So, and of course, support open source before ask open source support you. And yeah, make love, not war. Thank you so much.
Okay. Thank you, Alexandr. Very, very insightful. Okay, one question this time, because Alexandr is going to be here. Lucian?
Yeah, I'm not leaving right now. Yeah.
Actually, I like very much all your presentations, very technical, and because you employ a lot of technology, I'm just curious, how many engineers does your company have actually?
Normally we have 16 employees. Yeah, so. Yeah, so, and like I said, we are a self-made company, and we do a lot of R&D, and we take all technologies what is coming on the market, and we make analysis and research. And if it's good, we will still use it. And therefore, it's Parquet. It's not like, it's a project only for one day, because we already spent 2 years using these Parquet files inside of our observability platforms, and it's worked amazing. Yeah, and also in Epic we use Parquet files. And therefore, Home 11, it's for next years. Yeah, so this will be definitive Home 9, 11. Yeah, so something like this. So you have to upgrade it. Okay.
Okay. Thank you. So we have Alexandr and Rita back there. So. So Dan, again, thank you for coming. The floor is yours.
Thank you very much. Thank you very much, Dan and Daniel and the team for organizing again this wonderful event and having us here. So as promised many years ago to Daniel especially, we are here to announce the early 1.0. And I finally sit and thought about it, and I also know why we didn't announce it sooner. And it's again from Toy Story, it's never rush art. So this is our main philosophy behind it. So I'll skip the commercial part and go directly to CG Rates. For those of you who don't know about it, it's a real-time enterprise billing suite. It's a framework in the end. We started with small functionality, but there was always more needed, and we ended up into a complete framework of billing.
and it should be easily pluggable into existing infrastructure. So to integrate with existing billing systems, especially because we are engine, we are not a complete billing system. It should be also easy to accommodate new components once you evolve, especially 1.0, which is designed to be fully generic billing. It should be also non-intrusive, so you should not route calls through our system of choice in order to bill it. We should communicate with your platform. It's an open source software born in 2010. First sources published in 2012. Full sources are available on GitHub. 100% Golang, one of the early adopters of Golang. More than 450,000 lines of code over the last 15 years. We have serious consideration for community contributions, so please step in. 3 branches, indefinitely supported. We always say that, and we stick to it. We have the V010, which is our stable release where we don't add almost no functionality, except the one which fixes the problems. We have then the master branch, which is again declared stable and which we use when we implement new projects. But there we are kind of allowed to insert new functionality. And we have the 1.0 branch, which is the new and fresh approach to billing, completely new accounting and rating. And inside this branch, we have put all our experience for the past 15 years of doing billing projects. It's all performance oriented. We have advanced caching system. We have asynchronous processing with microthreads. We have API load balancer, and recently we have added our own database implementation, so we don't longer rely on, you don't have to rely on Redis or Mongo. You can use our in-memory database with on-disk storage support. Kind of using or following Redis principles, but since we don't know for how long Redis will be open source, we decided that we are more open source than open source. So then modular architecture, cloud-ready microservices with all rich set of APIs. All what we do is API-based. And it's easy to enhance rewriting specific components if you feel the limitation of GPL or something, or your investors are driving you towards rewriting something in order to have rights on the software. It's test-driven development, over 10,000 tests as part of our test suite. It was actually from beginning we started with testing, because with billing, you have to be a bit careful. What can you do with the software? Online, offline charging system. You can do a routing server, because it kind of goes hand in hand, routing LCR with billing. Fraud mitigation, since you have accounts and you have balances and all these resources like counting channels, counting number of minutes and stuff like that, then it's easy to do fraud mitigation on top of it. Then statistics, all these classic things like ASR, average call duration, average call cost and stuff like that. And also generic statistics, the type of average any field, if you like to. Resource utilization control server, if you want to count channels per specific destination at specific time, you can do that and limit them. Mediation server and billing assurance. So these are some of the products which you can build on top of CGRates and which we have built in the past. A bit of timeline. Project started in March 2010 after some ideas. First source is published in January 2012. First public appearance actually was here at Kamailio World 01 in 2013, in April 2013. So first stable release, quite a while after, now talking about the 1.0. We are conservative. So stable release was in 2020. Branch 1.0 was created in March 2021, and today, 2025, we finally speak about something on 1.0. What is CGRates 1.0? It changes from previous implementation of charging, which was quite static and it was quite inflexible. So nowadays, we are going towards generic charging, which does not longer follow the telecommunication rules. Before we had since we implemented before, we come like you from consulting on top of open source projects like Kamailio, and we followed the needs of telecommunication billing, but 1.0 does not do that anymore, so it doesn't relate anymore to telecommunications, although telecommunication is one field of operations for 1.0. Charging events are completely dynamic, so we get hash maps and we apply billing logic on top of them. We have generic APIs for both keeping the sessions as well as billing the CDRs. It's agnostic to telecom industry, and then we have dynamic options in tariff plans, so we can decide pricing based on what's in the event. I'll show you a bit of that. Dynamic service configuration options, so we can also react depending on what's coming in the events, including configuring the services. And we use for that a component which we call filters for as central decision logic. We have also architectural improvements compared to 1.x versions. We are replacing altogether the float arithmetics with using decimals. Whether decimals it's ideal, we cannot say, because any float arithmetic, it's problematic in when you do operations divisions with floats. It's more web interface friendly, since we started directly with working with a web interface on top of it. And we have redesigned the microservices in order to be more individual and more controllable. So every one of our services, it's a microservice inside a general pool of services. Dynamic configuration options, as I told. Database stored configuration. Before we were always storing in files. Now we can combine with files and storing inside database. What's the purpose of that is if you want to reconfigure things from the web interface. So I'm not talking about the tariff plans, but the service configuration inside your system. Then we have standalone accounts and rates working in parallel. So before you could only have an event rated or charged with accounting, but now you can put in parallel information, for example, charge out of a bundle inside accounts, and also know the rate which would have been if you were not using accounts or whatever. And we have also dynamic tariff plan loaders, which was problematic because all of your carriers are sending, or most of the carriers are sending you the price list in their own format. And then you always have, for each individual carrier, you have to write own importer towards our static tariff plan. And now we have dynamic one where you just can select where is the price in which file and stuff like that. Then using cron for time scheduling, we had our own library, and since cron is more battle tested, we have decided to go with cron for time scheduling. Just some ideas, since everything in 1.0 is on top of filters. What is filters is some subsystem which is processing hash maps, generic events which are to be charged, and it has an expandable logic. So you can have various various types of filters, like string, prefix, suffix, timings in terms of time, destinations, exists, less than or equal, and so on. So there are many types of filters which you can use. You are not anymore going with string or including API ban from Fred here. So also it's performance oriented. We index the string and prefixes, so they are fast. If you have 1 million of filters and only 2 of them are handling one particular account, based on the indexes, they will be grabbed. So you don't have to go through 1 million of filters to find out which profiles are using your account. And then you have dynamic data providers where you can query information outside of CGRAs dynamically. For example, look at the account status. If account has more storage than €5 in its bundle, then you apply some tariff, otherwise you apply something else, and so on. And like this, you can also use libform number and HTTP generic queries. Configuration option for the filters. And now regarding rates, I'm doing quite some marathon here in terms of getting all the content inside. So rates, it's a core component, and it's replacing the old RALs with rating part, because before we used to have only one subsystem named RALs, and this was handling both rating and accounting. And now we have completely different system, rates, which is just attaching prices on events, and accounting, which is able to attach prices as well as use bundles and compute various stuff on this side. Now the rates will have only one single file, CSV file for management, or you use APIs to manage them. It will make use of dynamic filters instead of just the old destination prefix or string. And it can also get partial changes over APIs. This is in real time. It has a common interface for loading, like I told you, receive the pricing format from your provider and decide which field you take from where when defining the price list. And then you can also avoid float arithmetics by using decimals. And there is some new functionality regarding minimum cost of the call, because before you could only have maximum cost of the call. Highly configurable rating with all these connect fees and rating increments and rating units, which was there before as well. You can charge multiple type of records like we used to do before, data, SMS, WhatsApp, energy now, and cars, and I don't know, CPU cycles and whatever you want to do. The huge advantage of 1.0 is that you can mix products. For example, the new energy market, if you want to merge it together, I recently heard about Revolut launching telecommunications. So tomorrow an ISP can also launch energy services and bundle them together in the same pricing. The old billing systems, they are kind of strict, and you will end up with 5 different billing systems depending on how many products you have in your portfolio. But by doing this generic stuff, you can mix them together. And then you have multiple categories like calls, premium calls for the previous market, and then derived charging, like charging the same event multiple times. So you can have price for your distributor if you want to do the billing for your distributor and your resellers and this stuff. So how we evolved is, you see, before we used to define rates for a customer inside 6 different files. So, and now we define it in just one, which is a huge improvement in terms of management. And all this due to filters. And configuration options, you can see a rate profile can have dynamic weights, which means if you have multiple rating profiles matching your event for charging, let's say a CDR, you get multiple rating profiles, and based on these dynamic weights, which is a new functionality in 1.0, you can decide which profile will win. So depending on, I don't know, how many degrees are outside, you can change your price for your customer, which is kind of becomes interesting. This was just a joke, but you can think about checking his account or his statistics. So if he sent you 1,000 minutes today, you can give him one price. If he sent you 1,001 minutes for today, you can give him a different price. And all this without changing nothing but the dynamic preference. Then you can have maximum, minimum costs and a lot of rates inside, which they also have dynamic stuff. You can see fixed fee, recurrent fee, interval start. So each increment, which is 1 nanosecond for time-based charging, you can charge it in different way. Then accounts is replacing Ralph's accounting part, so the same as rating, and same single file for management. You can do prepaid, postpaid, or pseudo-prepaid controller. And you can have balanced lifetime controls and stuff. You can have concurrent sessions per account. What I wanted to show also here is that accounts has changed. Before we used to deal with monetary and voice, SMS, and data. And now we are dealing with concrete, which is something which you can sell, and abstracts. And abstract can be anything. And you will have conversion table between abstracts. Abstract always needs to be paid with concrete. So it's the same analogy with monetary and voice. So you can give 3 minutes or minutes with price. But now you can give abstracts with price of concretes. And then from here, any kind of service you can think of, it can be emulated towards or abstracted towards this. And then you can also another difference is that the rates can be taken from rating system or can be also be defined here in accounting. How you can start playing with what we have today is Kamailio stays the same, use EVAPI module, and CG rates, we even publish documentation before the functionality, which is a first for us. And you can have now, it's already packaged, so you can just take it from our app repository and start playing with it. It works today for postpaid and authorization. It doesn't work yet for real-time prepaid because we didn't come to an agreement what's the level of abstraction we need there, but it should be in a month or two already operational for full prepaid. So 1.0 should be ready to rock. We also, you don't know how much we want to work because we love so much this new fresh approach on the charging. After 15 years of doing the same thing, we like doing something else finally. So I think, yeah, and look, 5 seconds I had. Thank you very much.
Quick question. And then you two run out.
I'm also fine to take questions outside. It's not a mandatory thing.
I've tried a couple of times message rates.
I heard that story before, so.
without access.
Yes, but
yeah,
please.
but my question is the next. Do you plan some decoupling some modules, other sub-services? Because right now you're doing like mostly monolithic service, which still gives some API for some particular, but for example, least cost routing and least cost routing, and then just, for example, how much charge you have to do or cost charger.
But they are decoupled. You just have to configure, instead of querying themselves internally, you have to configure querying themselves over network. And then they are all decoupled. All our modules are working decoupled or internally. So as soon as you put, it's slower over network because it's milliseconds versus nanosecond speed, but all modules are decoupled. It's just you have to configure them.
So I can use it afterwards on a postpaid. I mean, so to propagate their CDRs, and it's gonna be charged over the data I can propagate.
Yeah, you can.
Thank you.
Okay.
Sure.
So
thank you very much, Daniel.
Sorry, but Mohammed, Igor, please approach Dan.
After that.
Just checking mic works. Thumbs up, great. All right, hi everyone, I'm Lucas Christian. I'm a principal software engineer at Twilio. And yeah, thanks to Daniel for hosting me again. Like I said, I came over from San Francisco, so very long flight. But I'm happy to be here in Berlin. The weather is beautiful outside. That was at least very refreshing after I got off that plane. And yeah, so today I'm going to do a talk on the deep dive into Twilio's global voice network. So I know we've done the last few talks on very specific topics, whether that be denial of service, that was 2 years ago, or this last year we talked about stir shaken. This year I'm going to do just sort of an overview. I think we've done one of these back when we were presenting at the OpenSIPS conference, but we've never delivered one to this audience. So I'll jump right into it, and I don't want to keep anyone from their coffee break, so try to be on time. But yeah, okay, so I'm going to give just a quick introduction on what is Twilio. So Twilio is a CPaaS, or this is a bunch of letters, but Communications Platform as a Service. And I think that's a term that basically Gartner came up with to give us a category to fit into. We're not the only one in that category nowadays. But basically what all those letters mean is Twilio provides APIs for communications. And this allows you to connect your applications to voice. That's obviously what we're all here for. Also text messaging, email, and as well as we offer higher level kind of upstack services such as contact center applications and customer data analysis. And Twilio is not an out-of-the-box solution, but that's actually part of the power of Twilio. You can customize it completely to your needs. So unlike, say, a PBX in a box or a call center box type solution where you might be able to hire a systems integrator to add a few bits of functionality to meet your business's needs, Twilio, you can really get in there, get your hands dirty, write some code, and make it do exactly what you want. And you can start out with a pay-as-you-go pricing model. So you can still go to twilio.com and just sign up with a credit card and get started. We have had to make it a little bit more difficult due to just telecom fraud and spam calls and all that stuff. But if you've never used Twilio before, give it a try. It should let you do it. If it doesn't, please let me know. I'll yell at the team. But yeah, anyway, so I work with Twilio's Scramble voice product, and obviously we're all here for voice. What does this product do? This was Twilio's first product. It launched in 2008 with a company. A lot of people might think of us as text messaging, but voice was actually the first product. And what the voice product does is it lets you, basically, if you can write a web server, you can make your app talk to phones. And that was sort of the original value proposition. We have developers, many of whom are not familiar with SIP, but they know HTTP and they know how to write and stand up in Apache, or that was back in 2008. Nowadays, you can stand up Ruby on Rails, Spring Boot, any of these modern web frameworks. And so basically, all you do is we have a webhook that we call when your phone number receives a call. And then it requests your web server, just like any well-behaved web browser. And instead of returning something like HTML, you return a document called TWIML that basically describes what to do with the call. And that's really the power of the platform. It's super simple for people that know these web technologies. And it scales as well. So Twilio operates at cloud scale. We have 8 global regions, and we process over 30 billion calls annually nowadays. And we're deployed on AWS pretty much. We've been on AWS since day one. We have a microservices architecture that lets us really horizontally scale the stack. And I'll talk about this a lot more in the talk. We have something we call global low latency, which is what enables you to connect to us from anywhere in the world and get great call audio quality. So real quick, just to give you a visual example, I'm going to show a TWIML document. So this is for a simple application you could think of as maybe you call your local bank, and the call picks up and says, "Thank you for calling Owl Bank. Please enter your account number followed by the £." And you're going to type your number in on the phone keypad and get your current balance or something like that. And basically, you have this gather verb, which tells Twilio to wait for 1 or more digits to be pressed. And inside of it, there's a say verb, which tells Twilio to do text-to-speech with the text that's inside that tag. So just like that, you've built that application. The customer types in their account number. Once they enter it, we re-request your URL, and you can return a different document saying what to do next after that. So what did it take to make all of this happen? Well, I'll start with 2008 with our original architecture. And there's probably a logo on here that looks familiar to a lot of you in this audience, which is Asterisk, the open source PBX. And that is indeed how we got started. I'm sure it's how a lot of people in this room got started. And if you're familiar with Asterisk, you probably know you have a dial plan configuration where you describe what happens with the call. You may be a little less familiar with this interface called AGI, or the Asterisk Gateway Interface. And that's a TCP-based socket that basically lets you write an application and dynamically control the dial plan execution. So Twilio's sort of original idea was we're going to build an application we call HURL, or Handle URL. That was the original name. It lived on until just about a year ago when it was finally shut down. And it basically functions as a bridge between AGI and then HTTP that web developers widely know. Now, we've obviously grown a lot since then, and we've had to really refactor the stack to handle all these new features. So Twilio started out with maybe 1 or 2 sort of aggregators or wholesalers that provided our carrier connectivity. And that was the only way you could get calls out of Twilio. We started out with just PSTN. Nowadays, we have over 100 carriers, including all the major operators in the United States, as well as in some other countries around the world. And we have other connectivity modes. So you can bring your own SIP to Twilio. We have a lot of enterprise customers that already are invested in SIP PBXs and phones on everyone's desks. STOM phones, for example, Polycoms, all of those. You can connect them directly to Twilio with our SIP interface. And we also publish an SDK that you can plug into your web applications or your iOS and Android apps to add calling right into your app without having to figure out any of the details of building those yourselves. And then, like I said, as we've grown our global customer base, customers want lower latency. So all of these have sort of forced us to evolve the stack quite a bit. And today I'm going to be walking through some of those evolutions. and sort of talking about the why and then what we've been able to do with them. So this architecture I'm showing you here was introduced around circa 2013, and it's really still in use today, which I think is a testament to how well it's held up for us. So basically going right to left, we have a variety of different edge stacks, and these handle the connectivity from each type of call coming in and out of Twilio. So on the right, you have the carrier edge. This is going to be our PSTN traffic. Then you have public signaling gateway. This is customers bringing their own SIP to Twilio. Both of those use SIP, by the way, but they have different needs. Carriers, we obviously know who they are. They usually come from a specific range of IPs. Where public SIP, we need to do dynamic authentication and other things like that. And then we get our JavaScript mobile client libraries that have their own edges. And that's what we would call the edge layer. Now, I'll talk a little bit, since I am at Kamailio World, about where Kamailio fits in. And just a sneak peek, it's these two roles here, as well as this role. And I'll talk about on the next slide what we actually do with Kamailio in that use case. But you have the edge layer, then you have the proxy layer, which sort of handles taking all the traffic coming in from the edges and directing them to the correct application to process the call. And then when calls come back out of one of those applications, say they're going to bridge to another type of call, then they're going to go right back through that proxy layer and get routed out to the appropriate endpoint. That stack I showed of asterisk initially all fits in this Bramble voice box here. So we keep the application layer, we keep that application processing sort of down the stack so that we can build these connectivity features on top. So where does Kamailio fit in? Well, it sits at the edge in that carrier and public SIP use case. And it's an internet exposed service. We trust it to sort of handle the wild traffic you get on the internet. That's actually a very important function. Kamailio's SIP stack is very well refined. We don't find a lot of bugs in it. And it allows us to handle that UDP, TCP, TLS, and whatever protocols customers want to bring to us. It also does DNS lookups quite well. So there's a lot of adjacent protocols to the SIP protocol, such as, for example, doing NAPTR lookups and SRV lookups and some of those. And we rely on Kamailio to kind of handle all of those details and get them right. Now, as we work our way into this stack, we expose a very limited number of IP addresses at the edge. And the main reason for this is if you've ever worked with some various SIP devices that are out there on the market and tried to make them do DNS load balancing, you've probably not had a lot of luck. So DNS implementations are pretty hit or miss, especially across the carrier world, as well as sort of various SIP appliances. And so if we have an IP out there that's receiving signaling traffic, it's probably pinned. We probably have customers or carriers that are pinned to that particular IP and are going to keep sending traffic to there no matter what the DNS says. So we need those IPs to be available, to be scalable, and to really have as little downtime as possible. So Kamailio serves that role really well. And then we use the dispatcher module within Kamailio, sort of a minimal config, to route it to our next series of downstream services that do all of the Twilio application logic. So the dispatcher module, we have a service discovery system that was built in-house that allows Kamailio to be reconfigured whenever we add or remove downstream hosts. And then those downstream applications do all the processing. And the last function we do with Kamailio is we use it for traffic standardization. And that's basically just clean up incoming signaling, normalize headers, discard packets that are junk and obviously not SIP, whether that be like UDP keep alives or something more malicious, as well as do basic like firewall type policies like strip off headers, for example, that should not come into the stack. Another very important function on that public edge is we have customers connect to us behind NAT, especially if you have phones on people's desks, for example, connecting directly to Twilio. And so we rely on Kamailio's foreign NAT traversal functions to handle that use case. All right, so now I'll talk a little bit about when you get inside the stack, microservices. So microservices are a really key part to the Twilio stack because it allows us to horizontally scale individual components as traffic grows or shrinks. So if you look at a call coming in through our public signaling gateway on the right, perhaps the first thing we need to do to handle that call is find out how to authenticate it. Should we send a digest off challenge, for example? So we don't build all of that into the public signaling gateway. Instead, we have it reach out over HTTP to a downstream service that stores the SIP auth configuration. And then we have another service maintained by our identity team that provides accounts information. Like, is the customer's account suspended? Are they valid? Is the bill paid? So on and so forth. So we continue to work our way across the stack. Maybe we process a call in programmable voice. One of the things programmable voice needs to do is reach out to the customer to retrieve their webhook or their URL and retrieve that TOML document. Tasks like that are actually quite a bit more complicated at our scale. For example, when we talk about global low latency later, we actually have a feature that lets the customer control which region of Amazon's cloud we use to connect to their web server. So all that gets handled in that webhook proxy service, which means that teams can quickly iterate on that and deliver new features. We ship to production hundreds to thousands of times a week, and that the fact we have all these individual services means we can deploy them all independently and continuously deliver improvements to customers all the time. When you get into proxy core, maybe we need to route the call to a carrier. So we have a service that handles carrier routing, and this involves a lot of algorithms we've developed over the years to, for example, select the lowest cost or the best carrier for the route. When the call goes out to the carrier, maybe we need to do stir-shaken signing if it's in the US. That was the subject of our talk last year, and that gets handled by an additional microservice. So all of these have the benefit that they allow us to really scale out. If we're getting a lot of carrier calls at the moment, we might need to scale up this service and this service, but maybe we don't need to scale up those services. And that allows our stack to be extra flexible. All right, so now I'll talk about latency. So availability is obviously important, being able to scale up the service. But this is telecom, so customers also care about low latency. If the audio latency is extremely high, then you're going to have a hard time having a conversation. You're going to be talking over the other person over and over again. It's just not a good experience. So what Twilio did when we launched the Edge architecture is we built out this system we call global low latency. What that means essentially is we have particular regions all around the world, we have 8 of them in total, that have a carrier edge, public SIP edge, and a few other edge components. And this allows customers to enter the Twilio network close to their geographic location. So for this example, we have a customer maybe who is receiving a carrier call from a Japanese phone number, and they're going to go into our carrier edge in Japan. Now, some of the application services like preamble voice still only live in the US because those are our most complex services and involve a ton of hosts and roles to process. And so the signaling is going to actually go through Amazon's backbone using a dedicated pipe to the US. It's going to get processed, and then it's going to take this pipe back out to the target, which let's just say is a SIP PBX in Singapore. Now, another clever thing we do with the global low latency architecture is we can actually bypass the media when we don't need it in the signaling path. So in this case, if the call audio is just flowing directly to that PBX with no additional features turned on, such as AI transcriptions or things like that, we would just send that directly over the backbone between Japan and Singapore and right out to that PBX. And again, that keeps the media latency as low as possible and also minimizes the signaling latency. Now, if the call does have to get processed in the US, maybe you're doing an IVR application, that does end up going over the backbone to US East. But then as soon as you end up bridging the call to another party, which happens in a lot of call flows, we can send that audio in a more direct route. Now, just sending the audio over the backbone actually improves latency. So in this example, if we have a customer in Sydney, Australia, and they're just connecting directly over the internet to our US East region, they're going to be competing over that internet pipe with everything else happening on the internet. Think of this as like your teenagers watching Netflix, playing on watching something on YouTube, playing video games. Like all that is competing with your very important phone call for your business. And you're often going to see pretty bad latency, like 800 milliseconds or up, going all the way across the Pacific Ocean or the Atlantic. Now, if you enter our Sydney region here, and then we send that call internally over the backbone network. And in this case, this is just Amazon's backbone. You'll see half the latency essentially, because that's an optimized network path that's reserved just for that traffic. So just like that, we can get the latency down quite a bit, even if you're still going to the US. But 400 milliseconds is better, but it's not necessarily what our customers are looking for. And actually, I forgot I had this slide. When we have these tunnels here, there's actually a Kamailio on both sides of the tunnel. And that's because anytime we cross regions, the rate of failure goes up. Network paths do fail. They fail inside Amazon's network. They fail across regions a lot more than they fail within a region. And so we have a Kamailio on each side, again, using that dispatcher module that allows us to just have sort of redundant proxy paths across those cross-region backbones. And that ensures that if one goes out, we can just quickly reroute those SIP messages down another path. Okay, so now customers, 400 milliseconds is great, but we can get it better. And with this, we launched a product we call Regional in 2020. And the idea of Regional essentially was both to improve the latency problem, especially for those customers in Sydney. The main thing that comes to mind, like if you look at this call flow, the media may be taking a direct path, but that signaling still has to do that hop. And when you're crossing all the way across the ocean from Sydney to the US, this adds up. By the time you've done this hop, you've probably gotten up to almost a second of latency on that signaling path, even with the media taking that more efficient backbone. And if you have several different interactions on that path, maybe you're doing an IVR, it adds up a lot. And this manifests as post-dial latency for customers. So you place the phone call, you have to wait a second before you hear ringing, and it's just not the best experience. So with Regional, we basically launched clones of our US East infrastructure in 3 different geographic regions. And these were chosen both to sort of fit within regulatory boundaries as well as provide the biggest bang for the buck in terms of latency improvements. So we have a Twilio Ireland region. That's probably most relevant to those of you in the EU. We also have the Sydney region in Australia and then the US East region. And each of these regions basically has a clone of all the Twilio services, including the whole preamble voice stack, carrier routing databases, accounts databases, so on and so forth. And a lot of data we keep isolated and local to the region. So when you place a call in the Ireland region, your call logs and CDRs all stay local to that region and they don't leave. And that allows you to satisfy regulations such as GDPR. Now, accounts information and some of those other things get replicated between the regions. So that allows us to sort of keep things up in sync, but all that replication occurs asynchronously in the back end. And so your call setup is not dependent on any of that data being replicated. So if the US East region happens to go down due to, say, a blackout across the country, which seemingly nowadays is possible, then your calls in Ireland could still work, your calls in Sydney could still work. So that also gives our customers a disaster recovery or failover strategy. Now, when you follow this call on Regional, you can basically go all the way. If you're a carrier in Ireland, you can go all the way to a PBX in Ireland and keep it all within the EU within Ireland. So this is going to really deliver you that minimal latency. You're going to get it under 100 milliseconds if you stay in the circle. And even if you're having to cross regions, you're still going to get better latency. So in this example from a few slides back of Japan and Singapore, it looks very similar to previously, except this now says Sydney instead of US East. And just like that, since you're only traveling a little ways over the ocean as opposed to halfway across the globe, you're going to see dramatically better latency on that call setup. So the regional implementation allows us to improve things for everybody that's outside the US. And that's been a key to making Twilio a better product to use for people in other countries. So the last sort of evolution I'll talk about is splitting our signaling servers off from our media servers. So we started out, again, with just running everything on Asterisk, and then we put our signaling stack in place. But that signaling stack, we actually handled the media in those same signaling gateway roles. And for a time, we actually had our own media stack that was written in Java in-house. That was kind of fun. It actually worked pretty well, but the reality is media has become more complex as our needs have grown. So we have a lot of carriers now and wireless networks that support HD audio codecs. So we now need to be able to handle those. Encryption is a bigger thing than it was 10 years ago. If you're on the public internet sending voice over IP calls, you probably want to use SRTP just to have a little bit of extra security guarantees. And then if you're doing anything with WebRTC, you have all these NAT-traversal protocols specific to WebRTC, such as interactive connectivity establishment, or the ICE protocol. And these are all things the media server has to handle. And then we try not to transcode, as we have HD audio and other codecs that may come into play from time to time. But essentially all that goes up to increasing the amount of resources we need to handle media traffic. And if we couple those two types of traffic together, then that means your scaling of those signaling gateway roles is basically coupled to the lowest common denominator of signaling and media, which is almost always going to be media. It just takes more CPU cycles to process those RTP packets, even if your business logic on signaling may be a little bit more complex. So in the most recent form of our architecture, we have the media server split out as a separate service. So when a call comes in, it's going to go through Kamailio SBC carrier. It's going to reach our signaling gateway that's going to be responsible for figuring out who the carrier is and doing some of that basic call processing. That signaling gateway will also negotiate an STP, but to do that, it's going to reach out of band to a Twilio media server instance in that same region. So it's going to go find an available media server and then request to allocate a session on that media server. And this may sound kind of familiar if you've looked at Kamailio and used RTP proxy or RTP engine modules. It's a pretty similar idea. In this case, the media server is a Twilio-specific component, and we have our own sort of signaling protocol with it. But it's pretty simple: allocate session, release session, so on and so forth. And that gives an STP back that we send back to the caller. As the signaling path goes all the way through, we allocate a media server on the inbound leg at that edge, and then when it goes out another edge, we allocate a media server on the outbound edge. And then the media will obviously route through these, taking the most direct path. Now, if we need to do some kind of interactive application, such as maybe you want to insert smart transcriptions or some kind of AI application in there, or an IVR application, we basically reach out to these media servers and add an extra hop right in here, coordinated by this Bramble voice node. And then that can play in play back the text-to-speech or whatever else it needs to do, and then quickly remove that flow from the hop. Okay, so last thing I'll talk about is how customers connect to Twilio with SIP, since this is probably something that's interesting to most people in this audience. So you can go to Twilio's API or the console and create something called a programmable SIP domain. And when you create that SIP domain, you get your own personalized name, like lucas.sip.twilio.com, as well as sort of these regionalized prefixes where if you want to use a specific edge, you can say lucas.sip.dublin.twilio.com, which will always ensure that your traffic goes in the Ireland edge. We use wildcard DNS, so your personalized domain name uses the same IPs as everyone else's domain in that region. And then we rely on that signaling gateway when the traffic comes in to go figure out which customer is in the request URI by looking at the domain name. And then each domain you can configure in our API a set of IP ACLs if you want to do source IP authentication, or you can create a username password digest list, and we'll do a digest auth challenge to authenticate that. And you can also turn on TLS and SRTP. Now, one interesting detail I'll call out on TLS is that each of these individual domain names, the SIP RFCs don't allow you to use wildcards in a certificate. So they explicitly say you cannot do wildcards in your TLS cert, primary or the common name or the subject alternate name. So that creates a little bit of a challenge for our customers where we have these unique names. We're not really, Let's Encrypt has been out for a while, so we could potentially generate a unique certificate for every single customer. But we haven't really found a reliable way to load thousands of certificates into Kamailio and have it select them automatically, correctly based on the incoming call. That just doesn't work the same way it does maybe on a major web host with HTTP like today. So the solution we encourage most customers to do is they set their request URI to the lucas.sip.twilio.com, but then their outbound proxy, if they have that setting in their soft phone or PBX, they will set to a non-personalized version, like just sip.dublin.twilio.com. And then that exact name will be in the certificate. So as long as your SIP application validates the name using the outbound proxy, it'll work fine. It doesn't work if you use the SIPs protocol, for example, but it gets you most of the way. Okay, so last thing I'll just touch on is a few other ways customers connect to Twilio. We have our JavaScript client that lets you embed calling into your web application. And this uses WebRTC for the media stack. The signaling is a proprietary JSON protocol over WebSocket. I want to say sip.js wasn't quite as reliable, or I'm not sure it existed at the time we built this SDK. We have a mobile SDK that lets you do iOS and Android calling. This does use SIP over TLS, but if you've tried to do anything in iOS and Android, you probably know they don't let you keep a socket open to keep a registration alive. So we have to do a proprietary implementation of push notifications to basically use those native platform push notification APIs to get the call back to you. And that wakes up our application and it connects to SIP after that. The last one, I heard a name check of WhatsApp and over the top earlier. So Twilio's had an API for WhatsApp messaging for quite a while. For this one, I'll just say shh, but you should tune into our Signal 2025, which is happening this week in San Francisco. Just look out for some announcements there. You should see something interesting related to voice coming out on that one. And the last external interface I'll talk about is media streams, which is actually a really neat thing we've been able to launch after we split those media servers out. And that lets you fork real-time call audio off from your application and send it out over a WebSocket to another application. So maybe you want to plug your call audio into some kind of external transcriptions API or some kind of AI application. This lets you get that audio broken out so that you can go analyze it while the call is going on. And if you're a big enterprise that uses SIPREC, we support that too. Okay, so hopefully that gives you sort of an overview of what we do here at Twilio. Feel free to hit me up in the hallway if you have any other questions. And if we have time for Q&A, I'll open it up, but I don't want to keep you
one question,
from the coffee break.
Henning, it's first there, so then it's the coffee break, so.
Yes, thank you for the talk. Just one remark about the wildcard DNS topic. Microsoft just ignores it, so maybe you can also ignore it, I don't know. You're certainly large enough as well. Question, how many Kamailio servers do you have roughly, or services?
How many total Kamailio hosts? So we have 8 regions. Every region is going to run at least 6. In some regions we have up to 12. That's for a single edge, and in every region we have 3 edges. So let me do the math there, but it's going to be hundreds. Yeah. And in terms of like hosts overall, we're running tens, hundreds of thousands, maybe millions of EC2 hosts at this point.
Okay. Thank you. Thank you. So not to keep people from the coffee, but yeah.
me and giving the opportunity to give you a little insight on what we are doing and how we use Kamailio in that sense. Today I will talk about our mission critical network deployments, and even though public emergency calls are not the major use case in our solutions, customer now and then demand public emergency calls to be delivered to PSAP. So we heard from Wolfgang already today a bit about the public safety in the public network. And yeah, let me go briefly through the agenda. So just in a nutshell, 2 words about what Contron is doing. Then again, to recap what is mission critical, because it has some kind of definitions, what's behind mission critical. Then the building blocks of the architecture we are using. So you will see all the applications and nodes we are running. We can run in different deployment models, either in public cloud environment, but 99% we are on-premise in either Kubernetes cluster or any other virtualized environment. And then we dig into the use cases and features, what we finally did for the emergency calls, for the public emergency calls. And also an outlook, what we have on our radar for the new features for these emergency functionalities. And last but not least, the Q&A, if there is time left. Otherwise, I'm here, and you can ask afterwards as well. Yeah, what is Contron? In one sentence, Contron is delivering end-to-end solution for mission-critical networks. Our main customer base is railway organizations. Nevertheless, we have also here and there public transport organization using our solution. And a few words about myself. I'm part of Generation X. I'm doing this telco development for more than 20 years. Started with GSM for railways, what is still in place. So it's 2G-based technology, and a few years back, we have started with IMS and Mission Critical Push-to-Talk, which is the voice service for Mission Critical. So the overall terminology is MCX, and I like DevOps. Okay, let's start. What is Mission Critical? So it's basically must be available wherever and when needed. The probability of failures and the frequency of failures must be very low. So we have to fulfill the 5x9, for instance, and the system works reliable end-to-end. You will see in another slide what's behind this, and it must be secure in regards of integrity and confidentiality. A few mission-critical functions. Wolfgang mentioned them also in his talk in one or the other slide. So voice is the MCPTT part with optional push-to-talk. What does it mean? A user has actively pushing a button to get the floor. The floor is basically the uplink that he is authorized to talk, and only one user can talk at a time. That's the push-to-talk. That's optional for private calls, point-to-point calls. Then we have the group communication, where it's mandatorily to push to talk. We have extremely fast call setup time requirements. We are using preemptions and priorities within the network. On the one hand internally, but we also have to use interfaces towards the access networks like RX or N5 interfaces. The data communication is the MC data part of the MCX, and we have also the MC video, which is also for private and group calls. And finally, we have also the interconnectivity with other systems. This is also a very important part also within this talk, which finally enables the communication from MCPTT towards other domains like public network, voice over IP, or GSMR networks. A few highlights, what I see mission critical versus commercial network. In mission critical, you have the radio coverage there where needed. Let's say when you consider railway customers, you need the BTS, so the base stations along the track. While for public or commercial networks, you require the radio where more in the urban regions where more population is there. We have users in mission critical few, while in public we have many. For instance, I don't know out of my head, but I think our biggest customer hosts only 100,000 users, while in public you have millions of users. Encryption authentication is used on both sides, as well commercial as mission critical. As said before, priorities preemption is very important topic. And finally, commercial public operators rely on billing to earn money, while in mission critical networks, in principle, the system is used for operational purpose. Nevertheless, we also use billing interfaces, but this is more for statistical purposes. So we are using, for instance, an RF interface towards a charging gateway function when we talk about IMS terminology. And also very important, what makes a system mission critical? It's not only one network component. So finally, it's a chain where all the components must fulfill the mission critical requirements. This includes the devices. Of course, it depends then on the customer needs, but some of our customers demand ruggedized devices. Of course, they have to support this push-to-talk functionality. Same for the applications. The application must support all the features, functionalities I explained beforehand. And the network. So, and if one of the pieces in the chain is not considered as mission critical, the whole system is per se not a full mission critical system. Okay, now a brief look. This is just an example how we use it. But overall, it's the architecture we use in each and every deployment. So it's based on 3GPP IMS 23228. And it also shows where we use Kamailio. So also mentioned by Ramona, we use it for PCSCF, ICSCF, and SCSCF, all the various modules. We have also a dedicated module developed, which we use for interworking with relay domains. We will also publish this soon. Due to time constraints, we didn't so far. It includes a few conversion functions and specific functionality we basically require to interwork with our major customer base, the railway market. The next slide shows more or less the same, but it shows the interfaces we use. So the IC interface towards the application server. The application server is hosting the service, the mission critical push to talk service. We use the IC interface. So again, this is 3GPP standard. We do not use a full-blown IMS. We just use the pieces and parts what we require. We have the diameter interface switched between I and S, CSCF, and our HSS, the home subscriber server. Home subscriber server is a built-in application by us and hosts the SIP IMS subscribers for authentication and all the services. We use the CDP modules for the diameter. What else? Yeah, one demand of the customers is to do voice recording as well, and for that purpose we use RTP engine and SIP trace modules towards our RTP proxy, which is also acting as a black box recorder then finally, but this is a third-party vendor we've integrated with our PCSCF based on Kamailio modules. Yeah, let's jump into the use cases and the scenarios for the emergency calls, and to be precise, to the public emergency calls. In mission critical networks, the same for GSMR, there are per se emergency calls like railway emergency calls, which are then handled within the network itself, or some customers, even when you dial a public emergency number like 112 or national ones like 133 in Austria, 144 for the ambulance in Austria, they are then routed to the so-called dispatcher within the mission critical network. Nevertheless, we have the demand and obligation from some customers to route such calls like 112 through the public network finally to the PSAP center. What we did in that regard, again, this is a sample now where we interconnect directly with a public operator. Of course, we have also the other option, which you see at the later slide, that we connect to our GSMR customers if the PSAP is still, or the public operator is still on the GSMR network. So either the public operator already moved to the next generation MCPTT network, or if it's still on the railway network, then we have to interconnect and interwork with GSMR. What we did, we introduced an SBC, a session border controller, in regards to fulfill security. We host our PCSCF on this SBC node. The SBC is acting as a back-to-back user agent in our solution for several reasons, like topology hiding or other security features we have to implement. Then we have this interworking function, which is spread over 3 of our nodes. And we implemented this in Kamailio on the SCSCF and ICSCF. And we have also parts running on our application server. And in this example, you see we are directly connected to the PLMN, to a public operator. And what we do, even though our IMS, our solution is based on IMS architecture, we mimic a PBX. That's why we call it emulated PBX, which basically registers from the CSCF through the SBC towards the public operator. We get a dedicated, I don't know the correct term, head number for addressing our network, and that's why we call it emulated PBX. Yeah, and we use hash tables. You will see also a few examples later on to store information, configuration, and also do dedicated transformation functionalities which we require. This is just showing the other picture on which nodes in our solution we are running emulated PBX functionalities. So the most important is the ICSCF, because this one has the trunk towards our SBC. All the registrations towards the public network is initiated by the ICSCF, as well as incoming, outgoing calls. So SIP invites are passing through the ICSCF. So why we have also some functionalities on the SCSCF is simply as we have there already functions like address mapping, which means we have to address internal MCPTT towards dialable or public E164 numbers. But finally, important, all the messages are passing through the SBC, which you see on the next one, that all the messages, SIP messages, are passing through our ISBC towards the public operators network. Yeah, this is just an example, and what we've done, we have also, for instance, implemented some CAM commands to check the state or do various things. In the sample below, you just can check the registration state using CAM command, and the value 5, for instance, a value 5 indicates that the network is registered successfully. We also have some watchdogs running and perform alarming towards our network management system. Okay, then the journey started with some simple things. So what we have? We have on our phones. So we have an MCPTT Android app, or we also support iOS recently. And finally, you can perform emergency calls, which are treated as simple or plain private call as any other private call, so we do not have anything specific. The only specific we have is our IWF, because in MCPTT you have additional payload on top in XML bodies on top of SIP, and the IWF also does some transformation and additional header manipulation. That's why we have to pass through the IWF before leaving our network towards the public network, and the public network finally takes care about delivering the call to the PSAP. But again, this is nothing specific, and our solution relies, of course, on data connectivity. Can be 4G, 5G, private or public if we run over the top, but let's assume there is no 4G, 5G coverage, then our application does a fallback onto 2G and uses the native UE to perform the 1112 call towards the public network. So these were the initial steps. We have fulfilled that our customer at least can do something in regards of this. And so we were then basically thinking, okay, how to improve things. And we introduced the so-called emergency function. We also call it lightweight eCSCF, so emergency CSCF, because it's simply not fulfilling all the standard requirements. What it does, basically, it detects emergency calls by request URI. It performs a mapping from the PANI header. The PANI header is the peer access network info header, which tells the IMS, besides the access technology, also location information. So that means that the originating user will be routed to the correct PSUP. And the PSUP is this public safety answering point, is basically a physical location where the emergency call from the public is received. Wolfgang knows for sure better, but in a nutshell, I think that's it. Finally, we map this information, and the emergency function also is then responsible for routing the call and forwarding additional information, such location information from the UE. Like our MCPTT users, for instance, if they are fixed terminals, like a dispatcher, can then also send the geographical address along towards the destination. And we are also able to handle callbacks, but again, this is also just a lightweight solution because we rely here really on the public network, and that's why we at the moment bind to a specific operator always. We have to test if it works properly. Where was it implemented? We implemented it on the SCSCF as kind of extension of the IWF. Why? For several reasons. The IWF itself already has the capability to modify, manipulate all these headers. We can do address mapping quite easily, and it's already establishing interworking from out of the box towards our other domains. That's why we simply put it as an extension on top. That means whenever you run an emergency function, then you require the IWF enabled as well. Okay. This is the use case now I was mentioning previously. Let's assume we have a customer which has a GSMR network, still running the trains with 2G technology. However, already users are migrated to the MCPTT network, because the goal is that the MCPTT network should replace the GSMR network, but potentially this will take for sure 10 years from now still. But let's assume you have already users on the MCPTT domain, but the public operator network and their PSUP behind is still on the railway domain connected. Then the user on the next-gen MCPTT network initiates the call. It passes the PCSCF, which is hosted on our SPC, and goes through eCSCF I/SCSCF towards the MGCF. The MGCF is just the media gateway control function, a part of the GSMR network. So in principle, this is representing the railway domain, and this is the public domain. And this is schematically then depicted here with the red arrow. The red arrow is the signaling flow, SCSCF, IWF, and eCSCF. And you see the eCSCF detects the emergency call based on the request URI. It maps the PANI header to the PSUP URI. Finally, it will be then routed to the PSUP through the S/ICSCF. And in this case, we have to remove the geolocation header, because at the moment the GSMR cannot handle it. So it would throw just error or info logs. Yeah, and the blue one is just the RTP stream. And the IWF itself does also a few things. A part of this header and body manipulation, it adds additional information like a user header towards GSMR, because in railway networks you do not call with phone numbers. You have roles. Let's assume a train is running today from Munich to Frankfurt. It's the train number 123, and tomorrow another train runs from Munich to Frankfurt, and it's also 123, but there is the hardware, so the train itself is a different one. So that's also transported between the networks, this information. And this is the use case when the PSUB or the public network is already moved from GSMR to the MCPTT network side. Then the user initiates. Again, we go through the PCSCF, acting as an access SBC. ECSCF, along with IWF, will be passed. We go through the interconnect SBC, and we leave our network towards the public operators network. The ECSCF again detects the emergency call, maps the PANI header and routes it, and does also this header manipulation. In this way, in this case, we do not remove this geolocation header, which includes the location information of the calling user. Yeah, the callback from PSUB, let's assume you do an emergency call, but then the call gets dropped, then the PSUB must be able to call back. Again, this relies on particular operators, so it's not working out of the box. Nevertheless, in our deployments with our existing customers, we have found the operators supporting this, and we can call back, and we detect it also on the ECSF, in this case based on some priority information. And IWF then towards the originating user does again these manipulations. That's it from the scenarios. So maybe a few features that we can highlight how we do it. So again, in this example, what we talked about before, the ECSF detects based on the request URI. We configure this in hash tables, that the emergency function treats this call as emergency call. If emergency call is then detected, the ECSF does all the extensions and inserts the IWF into the flow. The PANI header information, the PANI header, we have kind of proprietary layout defined, and we have two models. On the one hand, a location ID as an integer, on the other hand, a location ID carrying an IP address. Why is that? Because sometimes, specifically for non-MCPTT users, so for VoIP users, we do not receive any of this location information we would require. So we basically identify the correct PSUB based on IP subnets, and because we have deployed our VoIP users then per regions. And this is what we have currently defined. And so the incoming call will have this pAccess network info with a location ID 42. And again, in the hash tables, we define then a URI for the outgoing side. In this case, it's the 4350255, whatever. And you see then on the outgoing side, the request URI includes this PSUB. And yeah, we have this transformation functions IP to PSUB or location ID to PSUB, depending on the terminal. And if, in case there is no location ID configured or misconfigured, we have also a default PSUB, which will be used in that case. So that's it, what we have today. Still, some improvements we have and ideas we have on our list. on the one hand, we do not fully support redundancy towards the external SIP trunk. So we do support kind of redundancy, but it depends on a few factors. So this is two things we have to improve on for the ICSCF towards GSMR and towards the external SIP trunk, towards the public network. We will extend the interworking towards the railway domain, including also the geolocation info, that even if the PSAP is behind the railway network, that the information is being transported. But this is only applicable to German market, because there is a specific Notrufverordnung telling how to deal with it on the railway side. And yeah, we do currently not support if the originating user is not IMS registered. So this is also what we want to support, emergency calls without the registration. That means the PCSF already detects the call as a public emergency call and will then directly send it towards ECSF rather than the SCSCF. And also we might support, but this is on the access side, I think more the IMS emergency registration. Then we have a dedicated bearer or emergency bearer can be used. That's it, what I wanted to tell you. I hope it was a bit interesting. So thanks for your attention, and yeah, feel free for any questions.
Thank you,
ask.
Roman. A question coming from Vienna.
Thanks for the presentation. One or two questions, perhaps. First one is, if you're removing the geolocation header and you're just providing the PIANI or network ID, how does the PSAP know about the location? Can the PSAP also map this identifier to a certain location, or?
Yes. So on the problematic when we go, because we remove it only when we go to the railway side, right? Because today on the railway side you have this information you have anyway only from the mobiles, because you can then send the cell and the cell of the originating user. If you have today a dispatcher, you will not send it to the public network and the PSAP. So and that's what I was saying. At the moment, there is this neue Notrufverordnung only in Germany, where you can also then transport via the UUI extensions postal addresses. And then we can send this information, the geolocation information, and the GSMR will transparently forward it to the public. But today, it's also not possible.
Okay. And
only for mobiles, right? For mobiles, it's possible, but also only from the granularity, only on the cell. Also, what we improve now is that we give each cell, we give GPS locations. This will also be coming
okay,
soon.
that leads to the second question. So if you get this accurate location from the device, would you also use it to map to the most appropriate PSAP instead of mapping your cell ID just using the geolocation?
Yes. Yes. But again, that's not that's not available today, but that's in development, let's say.
Okay, one more question from here, and then they have to catch you outside.
In one of your slides, there was this registration handling Kamailio config snippet, and you had something like CSEP wraparound logic. Can you?
Sorry, say again.
In your Kamailio example, there was this CSEC header wraparound logic.
Okay.
Can you discuss why that is needed, and if it's not done, is it a public safety hazard?
This I have to look up. It's quite old, but we can look later. Okay.
Yep. Thanks.
Okay, that's getting deep into the SIP. Now let's move on, because we need to search on the RFC. Okay, thank you, Roman. joining us. The floor is yours.
Okay, thanks very much. I'm really happy to share here the stage with all this community, and I'm really happy to be here. Okay. So again, a little presentation. I'm Santiago Troncoso, Research Director at Quobis, and well, I spent counting the degree that I also finished here in Germany. In Germany, it's 15 years. I think this year is going to have working on this voice over IP and real-time communication space. And after that, I have the opportunity to change through different spaces of the product development and specification. I think that a really interesting journey that brings to current date, where I'm working mainly on research for these new technologies and startups. But who is Quobis and what is these people doing that my professor said when I finished my degree that makes things with asterisks and stuff? So Quobis is a company, a small medium company from Galicia that is in the northwest part of Spain that crafts solutions for telcos that work from almost the beginning with telco technologies. And we are driven by these three main values, that is independence, care, and trust, and allow us to work on a more confident part, and also to make us and authorities, well, allow us to work more in what we love, and also to work with standardizations and to work and suggest free of any kind of tie about the knowledge and so on. So we are about 50 engineers working spread around Spain, and we work, we started at 2006, and from 2012 we were building our own products, and also we contributed to the WebRTC standards, and also we make big product there. And we were really big fans of Kamailio. And in the very early years, we also asked Daniel to come to our headquarters. And I tried to recover this photo from these amazing people that is here. One is in Nokia, other in Oracle, Red Hat, so on. But I tried and asked to my generative AI to try to improve it a little bit. Okay, we have this lady here that is not Fatima at all, but okay. But I really focus on the Daniel release, that it's okay. So I'm going to talk today about Camara. Camara is in fact the pronunciation, and it's telco APIs. And telco APIs is not anything new, but it's now with emojis and so. Oh, this is previous. Okay. To make a little presentation from the beginning, there is a missed word there, but it doesn't matter. The idea is that we have very niche protocols and very specific concepts for telecommunications, and any kind of API that appears on the very early ages was lack of standardization and so on. Okay, but current times also bring with a lot of new open source projects and new paradigm change, and we are seeing that things are changing. Things need to be much more faster. Okay, there were speakers, there were talks this day that point to that problem of the telecom networks that being so slow, so they need to arrive with something newer, something faster. And one of these main drivers was to need to monetize the 5G inversion and all the technology that is deployed, but it's not being used. And it's not being used because there is no applications, and all the promised applications are not appearing. This is an official Camara slide, and the main frictions that they want to fix is to provide something that scales, that brings consistency, and to bring simplicity to reach this massive amount of developers that works with web technologies and with REST APIs, because
one of the main points also that tries to fit into camera is that it's demand driven. Okay, so they want us to bring together a vendor and a telco and then to define a use case, and that use case is the one that is going to be sold. It's not a technology, it's not something that you need to really dive into it. It's just a use case that you want to solve, and we will see it on detail. How it looks, or what's new here. They put together the GCMA, the TM forum, and they also get in contact with Linux Foundation to create an open source project that could be agile and that could be fast and to have this new field, this new concept. But most of all, what they want to look for is the KISS principle, okay? To keep it simple, to keep it easy to understand, to keep it easy to join. Okay, this other official slide is to just get clear the scope of what we are talking about. We are talking about define APIs for the northbound interface for developers, and it also brings another side effect that is the appearance of hyperscalers or aggregators of APIs. And there are appearing very big players, and there are a lot of investment on this area, because the main concept here is to bring a specific API, and that API will expose a function of a telco or a function that requires to bring some specific feature to the service at the very end. So if you develop an application, for example, to drive a drone or to locate a drone that is flying, you don't need to have all the operators implementing them. Then you can deal with the aggregator, and the aggregator will deal with the operator itself. And it makes it simple, and it gets a lot of traction. Okay, so there are the main operators playing there. There are also a lot of vendors, and we are happy to be here behind Mavenir, Radisys, Red Hat, and we also say that if you are interested into this, just jump ahead, because it's really fast-moving space, and it's really getting a lot of traction. Okay, what our operators are doing now, well, this study is from March, but it's pretty similar. But the idea is that they are exposing directly the use cases. And these use cases are not being exposed like in the early ages, where you get a contact with the operator brings you access to an API, then a password, and whatever. You have these fancy developer portals with these kinds of elements that all the marketers things that the developers are. They are also trying to expose it in a better way, okay? So, as I said, it's not more thinking on the very old classic voice over IP engineer. It's more thinking on a modern engineer that consumes an API. Okay, but what I want to show is that there are functions, okay? It was said before, today, that there are a lot of functions here, okay? There are QoS profiles, there are swing swapping identification, there are verification numbers. It's not a specific concept, it's just a REST API to say, okay, this number is valid, and say, okay, using your authentication, using the information that I have, yes, it's valid. Okay, so there are atomic functions, and nowadays we can say that, okay, we also can exchange SDP for WebRTC calls, okay? And that was the main point that we tried to help here, because we found it really interesting that say, if the WebRTC signaling is not possible to standardize, we can try to provide something, okay? So, quick. WebRTC was already introduced today. There are a lot of elements, there are a lot of protocols involved, but WebRTC itself is not a protocol, okay? WebRTC itself is the exposure of some capabilities of the browser and so on, and a compendium of protocols to retrieve this information, to construct the SDP. Okay, but to make calls, to register into a network, and to connect to a conference, for example, is so simple as exchange the SDPs and keep them together and maybe establish some signaling to keep them synchronized, okay, or to reconnect, as previously was said. So if we look to the WIP and web, and Lorenzo made a presentation the last year, if I don't recall bad, but the idea is the same. You will have one emitter, one receiver, okay, and it's a de facto concept, or there is a state-of-the-art solution for broadcasting. There are a lot of people using it, and what they do is just to reduce the use case. It's just to make calls. In 2004, he was Anton Roman that stayed here, and presenting these slides also pointed to this problem. So every vendor were doing their own stuff. SIP over WebSocket was in the middle, but every vendor tried to introduce their own features, their own specification of the API or whatever. So it was not clear. So what we can do is, if we keep it together to register and call, we can all share the same signaling. And it will be great if someday we don't need to face again the problem with the media audio, because when you join a meeting, you say, okay, I don't have a problem. If we share the same signaling, we can keep using our own clients. You can be in Teams, I can be in Jitsi, the other one could be on their own proprietary solution, because there is no limitation for the enhanced context or the other objects that you require into your signaling. It's just to share and configure the media itself. Okay, so how does it look? The camera project is a project hosted on GitHub. It includes it includes a space at Atlassian and Confluence where you can follow up the meeting notes and other relevant information, but most of it, well, most not. Everything is driven by camera, okay? And the WebRTC subgroup includes their own APIs and their own descriptions, and all the APIs exposes behave the same, and they were defined in the same way. They include two main folders, code and documentation. In code, you will find the open API YAMLs where the API itself is exposed, and the documentation includes some supporting documentation. What is going on, what is the movements, is included into the issues and pull requests that are included there. So in WebRTC subgroup, we have three APIs, or three endpoints, if we talk on a more plain way. That is the registration, call handling, and WebRTC events. And we will see them a little bit more in detail. One of the main benefits to have everything exposed on open API YAMLs is that you can literally render, or also you can auto-generate your own clients and servers. With all these with these generative APIs, well, generative language models, you can now be really fast with that. What is exposed here, for example, is the registration API, and it creates a trigger for registration, okay? Regarding the IMS data, or the subscriber that you will include into this requesting, will be depending on the authorization and the previous step of onboarding, okay? We are covering here the seamless use case for calling, okay? That is a specific use case. And the main concept is that any application that you have can behave and work into the IMS network using a basic registration, okay? And after that, the main core of the feature, or the main use case, is to create a call and to receive data about that call. So it could be created with simply say, okay, this guy, I want to call to this other guy, but after that, you can start to enhance this object. Okay, and one part of this object is, and it's not covered on this screenshot, but the main idea is that you will have an offer, an SDP offer, with your candidates as soon as you are retrieving them, because your candidate retrieval could be synchronous, that you will retrieve everything and after that start the call, or you can start with trickleize, with start and updating. Also, if you change your physical position or your access point, if you are roaming, then you need to update your SDP. This is mostly what we found when we arrived here, but what we found is that they lack of the channel to retrieve the updates back or the events that come from the network. Okay, into a camera that they look for very defined HTTP REST concept. What they were looking is to don't have an open WebSocket, and onto this WebSocket you will send events or objects or whatever. You need to keep and include cloud events. That is a standardized way to share events, and you will receive events about your subscription. Your subscription could be tied to a registration, then you could receive an incoming call, or you could include these events for call handling when you are receiving updates about the SDP of the other side. You can have two main concepts here to keep things clear. Is you can create your WebSocket into your web application and just define how you are going to receive this request, or you can, for example, define that your sync of events could be a Firebase API or a Firebase endpoint where you will receive notifications via push notification or whatever. Okay, so this was our main point of contribution to define this API and to handle the conversation to that. And with that, we take part of the code ownership that, like Wolfgang said, when you are trying to standardize something, it's a matter of volunteers, and we say, okay, this group is not moving, so we start to move them, we start to include extra documentation and to get people more and more involved. And we have a lot of people involved, like for example, it's Nippon Telecom, it's Deutsche Telekom, it's Mavenir, it's Ring Central now joining. It's pretty interesting that it's gaining speed. And it's released now. It's starting to be stable, a couple of releases more, and it will be finally defined. Okay, its release on camera is about 6 months. And after that 6 months, you will have updates, new features, and also new things. Our next thing is branded calls. 2 minutes more, Daniel. Our next things could be branded calls, okay? That is tightly coupled to authentication to avoid the spoofing, but the main idea is to share an easy way to create branded calls. Okay, it's not needed to have a very very big complexity of the protocols included in the middle. The intention is to define something like, I want to make this call, here is the call, okay? And that's it. And it's something that any developer can see. Okay, so a couple of minutes just to talk about Kamailio. That is what we are doing here. And it's our favorite SIP signaling. There are multiple opportunities for a thing that is in the middle of a call, okay? So, of course, and it could be obvious, it could work as a WebRTC gateway working along with the SIP over WebSocket. It could implement this camera WebRTC signaling, but also camera could be a source of features for any communications that you have. So for example, you have an emergency call and you want to create a specific slide on 5G, you can invoke the quality of service API, and after that you will have the details and the definition to create everything that you really need. Okay, and it changed completely because it's for nothing compared with what you need to understand and to create, to use a dedicated slide is just to activate something based on demand. Okay, So first use case could be to building a WebRTC SIP gateway. It could, in a way, it follows the IMS standard, but the main idea is that using an HTTP server and a SIP client, you can interconnect both worlds, okay? And also another use case could be, well, and it's the more useful for most of you, that it's, okay, I receive any kind of event, for example, a call, for example, some kinds of data, input received from Prometheus or whatever, and then using HTTP client, I can connect to this service and process the callback back. What we did, and we are designing for our platform that combines different ways to communicate between them is WebRTC and also SIP signaling, is to consume some information, for example, for SIM swapping and authentication, that it's something that is really having a momentum in camera. But also we are trying to, we are working with these operators, with Telefonica, with and others to propose how to integrate with the networks. Okay, so that's it. A minute over the time, sorry. Thanks a lot for all the people involved, from our team, from camera team that also support us. Well, thanks a lot to you.
Thank you, Santiago. So we can get a question, but maybe Lorenzo is already setting up. I will give you another microphone to answer.
Blames, whatever.
Because maybe it needs to detect the Lorenzo. It's Linux, I guess. No, not Linux. Or Linux? Yes. So it might take a bit of time. So, question? Or it has Tim. One. You can answer. Wait for me to get to Tim.
Yeah. Hello. Okay. Any question? If you want to reach us, we are here. Yeah. Okay.
So I have actually two questions. The first one is, do you think that the operators are going to make it sufficiently the same over all of them that you can actually just interop properly, or are you going to have like minor versions between them all? That's the first question. And the second one is, why didn't you follow what WIP is doing with sending candidates over a patch request rather than a separate put?
Come again with the second question?
The second question was about the HTTP method. Why it's done with put instead of patch, like method?
That's a nice bug that you can rise and you can join. Yeah, that's the kind of agile movement that they are looking on camera. That it's to just identify anyone. Okay, there is no need to raise a bug here. You can just join the group, or you can just open a conversation about anything. That's a really good idea, because we already discussed that, but we were a little bit in a hurry to make the release. They are really tight for releasing times in order to get things done. Okay, and also in the Mobile World Congress, there were a lot of telcos exposing features using camera APIs. And to tie with the first question, if how we are going to deal with all the different vendors and if they are going to cover this or not, well, vendors, not telcos, that's the main role of the hyper aggregators. Okay, they are going to work as middleware that will handle the different time of implementation or the different versioning. Okay, the definitions will have a specific releasing, and every 6 months will be released a meta release that includes all the packages. Some of the groups will provide new features, others not. Okay. But the main idea is that.
Okay, so the answer is no. Will be different version with different, and we'll use a middleware in the middle. Okay, thank you, Santiago, once again. And again, a real pleasure to introduce Lorenzo, our friend from the WebRTC world. can do it himself. Lorenzo, thank you for coming. The floor is yours.
Thank you very much, and thank you for having me here once again. It's always a real honor. So yeah, today I'll be talking less about WebRTC and more about Quick, which is a new exciting way of getting real-time media out. And in fact, that's why I called it, is it an interesting opportunity or wasted time? And we'll see if I have an answer by the end of this presentation. So just a very few quick words about me. I got my PhD at the University of Naples. I'm one of the co-founders of a small company called Miteco, and I'm the main author of Janus, even though today I'll be talking more about a different project that I'm trying to spearhead that is called I Am Quick. And here there are a few links if you want to get in touch with me. Again, I won't bother you too much with this. I mean, as Miteco, we do the usual stuff that a small company does. So we do a lot of work with consulting and support related to open source software. We work a lot with standards, open source, which is why we love SIP, we love WebRTC, and we've been doing this for close to 20 years if we count the academic years as well. But again, today we are not going to talk about a lot about WebRTC. We are going to touch it, but mostly I wanted to focus a bit more on Quick itself. And even though I don't have much time, I wanted to give a very quick introduction on what Quick is in general, because not everybody may be familiar with it. And the idea with Quick was that at the time they wanted to basically improve about the existing HTTP protocol because it had several issues related, for instance, to head-of-line blocking and other problems that are strictly related to the transport protocol that HTTP uses, which is TCP. And they basically tried to come up with a new fancy protocol that could basically look a bit like TCP on steroids, if you will, but actually working on top of UDP rather than being its own protocol, which means that Quick, you will basically always find Quick as a user space protocol rather than a kernel-based protocol itself. And being based on UDP gives us some interesting properties. As we'll see, even though there are a few interesting properties about Quick itself, like for instance, the fact that it is always encrypted by design, which means that we don't have a decoupling as we do with TCP, where we first do the TCP handshake, and then after that we do a TLS handshake to secure that. Basically, everything with Quick is always encrypted, and since everything is, the encryption is part of the Quick protocol itself, it means that even just that should give us basically a faster connection time when compared to TLS over TCP, because we're basically doing two things at once when we connect. And it has a few interesting properties. I mean, TCP-like congestion control, loss recovery, all the things that you expect from a reliable protocol of sorts, but also much better connection migration, because again, we are building on top of something that doesn't have a connection at all, unlike TCP, which means that migrating a connection is much easier because there are a lot of abstractions taking place. Even though from an application perspective, and again, I put application on there because it's true that it started for HTTP3, but it's actually a generic protocol that you can use for whatever you want, is that it also has something that is called stream multiplexing, which is one of the biggest advantages that it has on top of over plain TCP, because TCP basically has a single stream over which we send everything, which means that if we are sending 3 different messages related to 3 different things, and maybe packet 2 is slow to go through, then with TCP we have to wait for packet 2 to go through before we can get everything else. With Quick instead, we can basically have the so-called stream multiplexing. So we can have multiple streams that actually are traveling across the same Quick connection. And each of these streams acts like a mini TCP, if you want, but don't quote me on that because I'm sure that the Quick people wouldn't love it. But basically, the idea is that each stream works a bit like TCP, meaning that each stream has ordering as part of it, has reliability as part of it, but each stream is independent of each other. So if 2 is slow, then the other streams are not affected. So they can go in parallel, which is great for going beyond the head-of-line blocking issue that TCP has in itself. And it also gives us interesting opportunities because then we can prioritize these streams, or we can get rid of some streams in case we don't need them anymore, which gives us a lot of flexibility in terms of what we want to send and when for different reasons. And each of these streams can also be independently flow controlled, which is also a nice property that it has, even though, of course, you have flow control as part of the whole connection. And the thing about Quick is that in general, when you have a transport protocol or any kind of specification that comes out of the ITF, you typically have one big document to read and you're done. Like for instance, with SIP, we all know 3261 is the document that we have to read to learn everything. With Quick, it's a bit more complex than that because you have basically 4 different documents that you have to read just for the basic Quick specification, which is a lot, but there is a reasoning behind that. And that becomes even more than that whenever you want to go a bit beyond that. So if you want HTTP3, that's another thing, but HTTP3 has a mandatory compression extension code that is called QPAC, which is another document instead. If you want to use datagram, which is basically a way to use Quick as close as possible to raw UDP, that's another document as well, and web transport and so on and so forth. But even though it seems complex, I mean, there are a lot of implementations out there. Basically, everybody and their dog has a Quick stack now. And it's all available in different programming languages, which means that everybody who is interested in getting into it from a programming perspective has access to that. I decided to self-punish myself, and so I tried to implement my own stack instead. And so I basically learned a lot from those documents, but also from these 2 blog posts over here, which I recommend to read in case you want to learn more, because it gives a very practical approach about how Quick works, because there are some things that you need to go through. And another interesting property of Quick is that with web transport, which is an extension of HTTP3, you can basically get the equivalent of basically what WebSockets are for plain HTTP. So it's basically a way to get a standardized API from the browser to basically do Quick. Because once you have done with the establishment of web transport using HTTP3, you can basically just exchange messages over on top of Quick using a very thin layer and from a browser, which means that it's very interesting to basically have access to Quick from a browser to do cool things, which, as we'll see, is actually quite important. And we have access to datagram as well, which is also very interesting in case we want really low latency for any reason. And this is just a very quick overview of how it looks when compared, for instance, because you can use web transport over TCP as well, but of course it doesn't make much sense. It makes more sense on top of Quick because with TCP we have WebSockets already. Which brings us to the main question. Can we use indeed Quick for real-time media as well? Because of course HTTP3 is great, but that's not real-time media. That's basically serving content in a more static way. And we can make a quick comparison with WebRTC that we basically all know about. So we know that WebRTC is based on UDP as voice or IP developments which WebRTC borrows are based upon, which gives us the ultra low latency that we need for conversational use cases. And even though WebRTC is peer-to-peer by design, in practice, we almost always use a client server anyway. So we have a WebRTC server that we use to communicate with from our browser or mobile endpoint. We do have optional support for retransmissions and congestion control if you want, and bandwidth estimation as part of that. And of course, it's natively supported in browsers, which was the big winning point of WebRTC in the first place. And when we look at Quick, we can draw some sort of a comparison with that, because even though it has TCP-like properties, for instance, for the different streams, it is also based on UDP, which means that in theory, at least, it should be able to give us lower latency than TCP for sure. Sorry. It optionally also supports the frame datagram that is basically as close as you can get to raw UDP. It is always client-server, so it's never peer-to-peer, always client-server. But as we said, this is how we use WebRTC anyway. And of course, since it mimics, or let's say borrows some properties from TCP, it supports retransmissions, congestion control. It has the multiple streams functionality that I mentioned that is really useful. And if we use it with web transport, we can also use it in a browser directly, which means that if we also use stuff like modern stuff like web codecs and WebAssembly, we can get a media stack in a browser that we can use with Quick if we wanted. Which means that when we start having a look, the ITF started to have a look at what can we do with real-time media, the first option that came to mind was let's just try and put RTP on top of Quick, which is a document that is going on in the ITF right now. And most of the document actually covers the overlap that happens. So the things that you can avoid doing on top of Quick because you don't need it. For instance, you don't need SRTP because Quick is always encrypted, unless you want end-to-end encryption for any reason. Most of the feedback that RTCP gives you, Quick already gives you out of the box, round-trip time, to give a very simple example. You have congestion control and so access to bandwidth estimation functionality as well. What you do need is basically a way to frame RTP packets, because especially when you use streams, you are acting with a stream-based delivery, which means that in that case you do need to have a way of saying this packet is this long, especially if you're using the same stream for multiple packets. And to do that, basically, RTP over QUIC introduces a new component that is called the flow identifier. So basically, you tag packets and you say this packet is related to this flow ID. And so, for instance, a very simple example could be all packets with flow ID 0 are my audio packets, all packets with flow ID 1 are my video packets. But the kind of mapping and how you do it is entirely up to you and how you negotiate stuff, but that's really the idea. What's most interesting is that I can use both datagrams or streams to send data. And when I use streams, since a stream, I can create as many streams as I want, and I can pack as many packets on top of a stream as I want. Basically, the real trade-off is how many packets do I put in a single stream, because I could spawn a single stream each RTP packet that I have, and that's an option. Or I could put more than one packet on the same stream, and in that case, I just need to specify the flow identifier once, because each packet that follows will be related to that flow. What you really don't want to do is use a single stream for the whole conversation, because in that case, it becomes like TCP. So you encounter the head-of-line blocking as well, but a simple approach could be, which is what most people are doing, for instance, for video, I start each stream with a keyframe, and everything that follows is a difference from that keyframe. Anytime I receive a new keyframe, I start a new stream so that everything is pretty much isolated and works better. Which then brings us to the next question. What can we use RTP over QUIC for then? And the idea is that, of course, the main thing that could come to mind is why not SIP itself? I mean, why not use SIP over QUIC itself? And that's something that somebody thought about as well, and there is an expired draft that talks about that, to basically try and learn from everything that has been applied to HTTP3 and apply it to SIP as well, in terms of better pipelining, better compression, especially because a lot of the headers in SIP are repeated over and over and over, and there is much better compression that you can achieve, which is something that they managed to do with HTTP3. And I actually don't know, to be honest, if that draft is going anywhere or what will be the next step, but somebody is definitely think about it. And I think it could be a good idea because there's a lot that QUIC can bring to the table also in terms of security, connection migration, as I mentioned, could be a very important add-on. Of course, we will need some way to negotiate those RTP over QUIC sessions on top of SDP, for instance, to negotiate what those flow identifiers mean. I think that even without all of that, maybe media trunking could be a good idea, just because of the fact that we can use flow identifiers to pack a lot of RTP sessions on top of the same QUIC connection makes media trunking possibly a good idea, because then we can take advantage of the congestion control, the flow control that QUIC has to manage all that, which was basically the main idea behind RIP, if you remember it. So that proposal that was about some time ago. They wanted to use HTTP semantics rather than RTP, but basically the concept is the same, trying to leverage the benefits that QUIC can bring to the table. But there's also the idea that since this is RTP, it's simple to bridge to WebRTC, which is also RTP based. And so this could provide a very easy way to basically start and having WebRTC and QUIC work together by basically talking the same language, basically. And I'll show a quick example of that in a second. Basically, the main thing that we need to worry about is how to associate and map these flow identifiers to an M line in the SDP, basically. All that said, though, RTP over QUIC is not really the main effort for real-time media on top of QUIC, because there's another effort that is gaining much more attention, which is completely different, though, which is called media over QUIC. And they're basically trying to address a different thing. So the generic distribution of media that has configurable latency, so that if I'm watching a football match, I can watch it in real time, or go back 20 minutes and go back to real time using the same connection, basically. So of great interest to CDNs, great interest to conference providers, great interest to real-time service providers, but it's also much closer to a traditional SFU from the WebRTC aspect. So this is definitely not something that I can see mapping easily or at all to SIP as a signaling protocol, because all of those streams are monodirectional. There is a publisher, there is a subscriber. It's really quite different, but it's basically the main direction that everybody is going through. So just so that you are aware of it. And that said, though, this brings me to the last part of the presentation, and I'll try to be quick because I may be short on time. Basically, I created this library to try and play with all of this. So I wanted to write my own quick stack, but I also wanted to play a bit with both RTP over quick and media over quick. And if you're curious about the name, it's a double pun actually, because of course it spells like I am quick, which is always nice. But it's also, you can also read it as Iron Maiden Quick, because basically this is the slide that I always showed every time that I said I really want to learn about Quick. They had a song that is called Be Quick or Be Dead, so I had to do that. And some may say that I lost a great opportunity for a much cooler name, but I really didn't want Nestlé's lawyers behind me, so let's say the other name was safer, let's say for sure. And just to give you a very quick overview, because I don't want to bother you too much with it, it's an open source library, and these are a few links if you want to learn more about it. There's also a detailed blog where I introduce it in more detail. It's generic, meaning that you can use it for a generic library to build something on top of either raw quick or web transport or both. But it also has integrated support for RTP over quick and media over quick to play a bit more proactively with those, using higher level APIs to interact with those. So that if you use the RTP over quick API, it masks a lot of the details about quick itself. So you don't need to know much about quick, you just need to know that there are RTP packets going back and forth. And of course, it's definitely not ready for production at all. It's something that I'm playing with at the moment. It needs a lot of love, especially the quick stack part, because it's a complex protocol, but it's given me a lot of fun and opportunity to experiment with these protocols in a sandbox environment, let's say. And RTP over quick is indeed what I wanted to prototype first, because it was the easiest one to start from. Basically, I wrote the multiplexing and the multiplexing functionality as part of the library that would be used on top of the quick streams and datagrams, and then I created a couple of demo applications like an RTP over quick server and an RTP over quick client, where one could send RTP packets over quick to the others, and stuff would happen basically. And I also wrote a basic integration in a Janus Quick plugin that, time permitting, I will show you in like 10 seconds to show you how it works. And I also tested this, of course, with other implementations as part of the IETF hackathon. I added some log support for better debugging and so on. But basically, if you just use the command line applications, they look like this, so a bit boring, if you will. This is a client that gets RTP packets from something else, like a GStreamer pipeline, and whatever it receives, it sends here. And of course, tagging the packets with the flow ID that we want to use. And this is how it looks like when I integrated this in Janus, though, where I have Janus acting as an RTP over quick server, so that if I use my RTP over quick client, I can send RTP packets via quick to Janus, and then Janus will send them via WebRTC to a browser. And this is an example. Or I could do the other way around. So publish RTP packets via WebRTC and then send them via RTP over quick to an existing RTP over quick server. Or do what I was saying before. So basically basic trunking where I have WebRTC end-to-end, but the two Janus instances are actually connected via RTP over quick, because this is an RTP over quick client, this is an RTP over quick server, and then basically the end users are seeing WebRTC, but the actual backend is actually RTP over quick, which gives you an idea of how the trunking may work. And just to give you a very quick idea, I can show this in real time. Like I have this demo that I can start over here. I can start a client. I can start a client, and I can start GStreamer, and then something magically happens. That is basically the Iron Maiden song that I was mentioning before. So nothing fancy, but this is basically receiving RTP via RTP over quick. And now, last slide, because I'm done. Basically, what's next is, of course, figuring out if this all makes sense. And as I was saying before, it's really a matter of figuring out what will happen with respect to SIP over quick, and what will happen to RTP over quick as well as part of that. Consider that, again, media over quick is the main topic of it all. I'm spending a lot of time, of course, on IMQuick itself to try and improve it as much as possible, but for that I will need some feedback also from other users. And of course I want to release the Janus integration as well. And again, this was also an opportunity to introduce this library to everybody. So in case you're interested in this and want to play a bit with it, so feel free to do that, feel free to give me some feedback. And I hope I'm more or less on time, even though I may have rushed things a bit. So thank you.
Thank you, Lorenz. Yeah, no worries. So we'll have a question, but first, Nacho, you can come in front and switch the microphone. Lorenzo, you'll answer on this one. So we speed up a bit setup. We can take it later. Okay, so there are one question here.
As you dig into it, doesn't seem to you that Quick a little bit over-engineered for the media because of for the RTP, sorry, because of RTP with its extensions already existing for the WebRTC and standards covers almost everything, and Quick itself brings the same functionality like band switch estimation, then re-receiving packets, so error correction things, and adds this overhead with the layer. So yeah, it should be better connectivity, but then slower or let's say a little bit more complicated scenarios of using RTP within the Quick. How do you think?
Yeah, no, I think that the main advantage of using RTP directly is basically because it makes it much easier to interact with everything that is existing. Because, for instance, one of the things that our Media over Quick has with respect to RTP over Quick is that if I have to send a video frame, with RTP I typically chop it up in multiple packets because I assume I have to fit into a limit that is the MTU. With Quick I really don't need that because I can spawn a stream that can be as long as I want, and I could send the whole video frame on top of that, and then Quick will chop it up in multiple frames according as how it is needed. So you really only use RTP if you want an easier integration with existing deployments. So for instance, a media trunking solution or interaction with WebRTC or whatever. But for something new, it doesn't bring anything new to the table except for the fact that it is well known, it is easy to address a specific payload type or to say this is that, and then send it out, because otherwise there is a lot of stuff that overlaps, as I mentioned in the draft. So they say that there is a lot of things that you don't really need, so you can forget about most of the stuff about RTCP. You just send RTP packets and you're done. So it's definitely not the best option. It's just the first option that came to mind in terms of how can we actually do this. And the answer is that you can indeed use it because especially when you use streams in a certain way, you can do stream prioritization, you can just drop some streams entirely, which means that you can keep up with the delivery, which is something that you cannot do with RTP or TCP, just because you can have multiple streams, and so if you need to keep up and there is congestion and whatever, you can adapt much more efficiently than TCP could do instead.
Okay, so looks like a lot to explain here. So for you, maybe you catch up with during the dinner time social.
Thank you, Daniel, for letting me participate here with all these Kamailio rockstars. I could never imagine this some years ago. So I'm Nacho Garcia, I'm lead engineer at Zaleos. This is a small company in Spain, based in Madrid. What I'm going to speak today is about how we use what we call Kamailio as a framework. This is going to be a software engineer oriented speech, so you may expect to see a bit of code, okay, just a bit of taste on this. So how we started, we created a new project that was a SIP proxy. In this case, we had a really complex routing logic that could be modified dynamically through a REST API that we will be providing to as well. That means like from call to call, the routing could change. Okay. And on top of that, we have another requirements, obviously excellent performance as usual. But also this routing should be able to be tested using somehow a simulation, just using the REST API, not even having a real call. So as on any new project, we started evaluating different technologies available in the market. First, we thought about doing our own custom SIP stack, but that's been a lot of work, a lot of maintenance. That was not really an option. We checked other SIP stacks, for example, Reciprocate, but that was implying for us some learning curve, as we didn't play before with them. And we already have some experience with Kamailio. So as Kamailio, we know that was super performer, a lot of features. We give it a go on this. But in this case, we have a clear idea that this routing logic was so complex. So for us, it was mandatory to set up unit testing. Why we wanted unit testing? We could do system tests, but we wanted the coding cycles to be really short. You know, this code, build, test to be super quick. So we came up with a solution that was, well, just create our own custom module of Kamailio. In the end, this is C code. So we will be able to do unit tests over it, as this is just standard code. And we end a second feature of this, which is we end the portability we wanted for this simulation, as we will be able to reproduce scenarios, not having a Kamailio invoke in our module to run a real code. Okay? And so that's how we conceive, like letting Kamailio just pass as soon as possible the control to our module, then our module do the magic, and then just tell Kamailio what to do. So this is what we call using Kamailio as a framework, right? As it was your SIP stack. So we started doing a minimal viable product to validate the solution because we've never seen something similar. So as soon as we started, we started with the issues and the challenges. The first one is that our module was dependent on some Kamailio core functions, and even so we use functions from other modules. For example, this shared memory module, you know, these primitives SHM malloc and SHM free. We use that for setting the configuration across all the Kamailio threads. The configuration we change using our REST API. And obviously that was a problem because we wouldn't be able to solve this. We will end up getting back to this complex system level test. So what we did, we applied some software engineering here, and we decided to isolate and try to separate our code from Kamailio. We decided to create a standalone C library that we will be using the same library even from the Kamailio module we already have when running normally, and from our unit test binaries. So we will test the same code on our unit test and obviously on our Kamailio, as we are using exactly the same static library. This way, the code part related to our Kamailio model will become really, really thin. Like just take whatever is passed from a Kamailio script and then invoke our function and then just return results. And we introduce an additional layer. We call them bindings. This layer were a set of headers and C sources, and that's the only place we allow to put or to use a Kamailio actual code. So, for example, we created a Kamailio binding for the shared memory module, and we did, well, for the unit test, that gave us the ability for the unit test we use some mocks there, the mock implementation. You have as an example that we were just using standard malloc or standard free for shared memory. But when running for real in Kamailio, we use the real Kamailio functions. And in order to get better this thing on the unit testing, we researched some tools, and we found out, and we were really happy with the Seedling framework. Seedling framework is from Throw the Switch company, and it has two main utilities: Unity, that we use for test runner and for making assertions. It's really handy. You can select which test you want to run, and also integrates with Giacomo. So we started getting really early coverage reports on our code, and CMOC, that was very useful for mocking functions. That we use that for just mocking our own code in order to have successful unit tests, but also that was super useful to mock the bindings we created earlier. Why? Because that allows us to provide different responses for each individual test case. So with all of these and these code coverage metrics, we were really confident on this solution, and we were really happy. But mod problem arises. Even also, I already speak a lot of memory, but we suffer a lot on this. As I said, we were using two different types of memories, and any who has code in C will know that it's not easy to handle memory in C. It's very easy to forget one free and you get a memory leak, or even worse, try to free something not allocated and you go with a crash. And especially in our case, what even harder, because sometimes we face, like we allocated memory using a shared memory from Kamailio, and we try to free using the standard one, which even the directions are shorter. So obviously that was making crashes sometimes. So how we address that? Since we have a unit test, we use utilities like ASAN, address sanitizer, and Valgrind. And with that, we found many of the leaks and many memory issues. But it's through this combination of using different type of memories for free and from alloc and for free, that wasn't able to catch that. Even though we got at that point to deliver a minimum viable product, even we were not happy on this error-prone solution and hard to debug. So we can say we end up here. Luckily not. Why? Because we were iterating on our approach. That's the main reason of using a minimum viable product. So after the evaluation of this minimum viable product, we found out new business requirements. So things we're looking that we are going to need to modify more changes. And also we kept the desire of remove these persistent issues with C memory. So what we decided to port all our code and our solution to C++. As you know, has a way more powerful abstraction. We could use objects in this case, and we could tie this object lifecycle to the memory allocation and memory free. And obviously we pick C++ because, well, this integration with C is directly seamless. We won't have any issue on this. And also, well, another pro we got from this is that we could benefit using more tools or different tools. Like for example, for dependency management, we started using Conan, where before we were just vendoring the libraries into our code. So the actual solution on this memory issue in C++, or as easy as applying this resort acquire is initialize, means initialize. Okay, there's RIEEII pattern. And how we get to do that? Well, we created a base class. As you can see here, we call it SHM object, and all the entities we will use, they are going to be placed in shared memory. They will need to extend this class. where we are overloading the operators for allocating the memory and deallocating the memory using the Kamailio functions. You can compare both solutions. As you may think, it's very easy to mess up here. And if you just stand here, you don't care anymore about the object. You just need to care about, in the end, just removing the object itself. So make things, the leak prevention, way easier compared to our previous solution. So at that point, we were happy. We had our unit test, but that was not enough for us because we were just testing our code. We were not testing everything as a whole. We will need to ensure this regression with Kamailio, and when we update Kamailio versions, that everything went smooth and went confident. So the good thing is we already have some experience with SIP. So we started creating different SIP scenarios. For example, at that point on this product, we have more than 250 different SIP scenarios. Maybe we went a bit crazy. I'm sure, but maybe even there are more crazy people than us here. And also that was really helpful for us to testing different transports. So as we wanted also to have a really good system test, we end up creating our own tool. Our own tool that took advantage of these REST API provisions that was a requirement from the beginning. So with our tool, we were able to provision a specific scenario, test the functionality, and then deprovision. So each test has its own environment, clean and nice to work. Second, we put in place containerization. We managed to run everything into Dockers. So we could have like several UAs or even several instances of our product and run all of them in one row. Also, as you may know, CP is really verbose when you do a scenario. So we provide our tool with a template engine. So we managed to have very concise and small scenarios. Obviously, with all these features, that was one of the goals of this, that was having a CI integration on this, just run all the tests we have in CI. So with few clicks, we know everything is good, and on each change, we know we were not breaking anything. And we managed also to parallelize all these 250 tests. You may think it will take a lot to run. As far as we could parallelize in different tranches, we managed to run in 10 minutes all the build and all the tests we have. And as you may notice, since we have a good foundation on this functional testing, going with load testing, just using the features that CP provides, and implementing this concurrency testing where we mix different scenarios running at the same time, trying to see if there is any interaction or problem or race condition between them. That was not really hard with all this background work we already had in place. Well, this is a report from this product, so you can see a bit the complexity and the coverage we get. So we are almost 25K lines of code. Right now we are on the 80% of coverage, which makes us really, really happy. So how we get to this, how we succeed? I think the main thing, even we have good skills engineers in the team, the main thing is just apply software engineer approaches. All the steps that all of us we know, we should know, starting from analysis, specification, design, architecture, construction, coding, and testing, and just apply this iteratively. Please use this minimum viable product approach with an agile mindset, so you can find out not only issues, technical issues, but also issues on the business requirement. Try to pick the right tools. Obviously, that will help you a lot on regards to quality and your how efficient you work. And please set up tests from the day one if you can. So you are going to be way more focused on the code you do, and likely your code is going to be better structured. In conclusion, after doing a deep analysis, and we got a successful solution. I would say that don't be afraid on making big switches. For example, that the switch we did from C to C++. Even at the beginning sounds like that was kind of a lot of changes, a lot of crazy. That was crazy. In the end, I think it's important to learn from the mistakes. And in the end, the benefits really outweigh the cost for us. Keep the quality focus, try to not miss that. And as I said, pick the right tools. In this case, we picked Kamailio, Seedling, CMake Conan. And well, there is no magic. This is just apply the process iteratively and try to improve always. So thank you for your attention. You have any questions?
Thank you, Nacho. So yeah, there was some discussion in the development group to make Kamailio part of it as a library, but we haven't got there. I see some companies made progress in parallel. Then Sandro, while you set up, you're gonna, Nacho, you answer here. I see a question from Thomas.
Hi. Cool project. Just a question. So did you ever consider a Kimi language? So something like Lua or Python? Because it's quite fast, is it, Daniel? So did you ever measure it?
I didn't mention that, was some years ago. When Kemi was almost born, almost starting, we considered, but didn't fit well on all these things, setting up the REST API all together. That, well, that wasn't as a good fit. I'm not sure if we take recent versions of Kamailio and we see if Kemi could do something on trying to, because we are launching our own process externally. And on Kamailio, as far as we understood, at least on that time, the Python code only gets code when you receive a call. And we needed to run some servers on the mod init function, right, when all the modules were in it. But yeah, it's something we evaluated, but it's true, at that point was kind of first year, second year of Kemi, so not sure if it was Python 2.
Okay.
Python was a bit later, yeah, indeed. Okay, thank you, Nacho. Thank you for your contributions. I see Sandro, it's...
So let's remove this from here. Let's try again. Okay. Where did it go? Oh, it's hiding there. Okay, good. So maybe I can start. Yeah. All right, so Kamailio configuration security.
So Kamailio is, of course, really flexible. That's what makes it really great. But, of course, this flexibility, this can create security problems, right? So we will be focusing here in this presentation on Kamailio configuration vulnerabilities that we saw on client engagements. So we do penetration testing, and we see all of these configurations sometimes. And then after that, we will focus on not just fixing, small things, but more long-term proactive security approach. Like Daniel said, I'm, of course, Sandro, known for having made your lives more interesting, I think, in terms of, having released Sipvicious. And at Enable Security, what we do is we focus on doing penetration testing and security consultancy, security testing of voice over IP and WebRTC systems. This is our focus area. We publish a newsletter every month that covers voice over IP and WebRTC security, of course, called RTC Sec Newsletter. Everyone here should subscribe, so we can have a bit more subscribers. So, Kamailio configuration security. Now, the Kamailio installations out there that are doing anything, really valuable, they tend to be not behind some application firewall, network firewall, sure, but, they need to be exposed. They're not hidden in some internal network, right, for them to be useful. In fact, in most cases, they are the SIP firewall or the SIP security gateway. They have a very important role. They might be called an SBC, a session border controller. So they have a security function quite often, these Kamailio servers. So having a security function means that these Kamailio servers have a very critical role in many deployments. Kamailio is, of course, very flexible, and the Kamailio configuration is like a scripting language. It's not your typical configuration language. And of course, this flexibility, like I said, has critical security implications. What's, I think, important to keep in mind is that it shifts the security responsibility heavily towards the administrator. So it's not only the code, but it's also the administrator, how they configure it, that is really important in terms of security. And of course, when we talk about the real attack surface, Kamailio is definitely one of the most robust software out there. But it's also a bit of a misconception in some cases, because so much of the interesting stuff happens in the configuration itself. So we'll first look at some real-world Kamailio vulnerabilities that we have seen in our work with very quick demos, or just one demo and some examples. And then in the second part, I will focus this presentation to look beyond just patches, just security fixes of Kamailio configurations. Instead, we would like to take a more strategic approach to this challenge of, security solutions. And also present a proof of concept tool that we've been quietly developing. So when it comes to real world findings, this is just a slide showing a quick snapshot of common issues that we encounter. I'm not going to dive into these so much, but we have some case studies soon. But the point is that the details often lie in the configuration. And what's interesting when you start talking about security exposure is that, the more features you have, of course, the greater the attack surface, the more likely you have a security vulnerability, or a few. And Kamailio supports many, many features through its modules.
The most obvious modules that can easily introduce vulnerabilities are the SQL ops, the exec module, of course, the AVP ops, and any of the RPC modules if you're exposing that sort of functionality. So let's look at some specific case studies. So the first one is a classic SQL injection via AVP-DB query. In the case of our client, this got a very high rating, a critical rating. And the configuration is, of course, very simplified, right? But it essentially looked a bit like this. I don't know if you guys from the back can see, but if the diversion header exists, then it reads the diversion URI, and it uses it when constructing the SQL query over there after the like, which is actually problematic. And this would have led to full database access. We have a quick demo here. So first, let's see how the server behaves with a normal SIP request. We're using our tools, of course. And we just send a SIP message, and it responds with a 403. Why is that? Because next we look at the configuration. But yeah, this is how this particular Kamailio was configured, roughly speaking. Of course, we changed everything as much as we could so that the original configuration was much more complex, and there's no customer names. But if the diversion header is there, then it doesn't return a 403. It does something. It goes to the route diversion to tag prefix, which does what we showed before, roughly speaking. Yeah, the diversion URI is being fed to an AVP, and then you have the like query, and it passes, well, what is essentially malicious user input, potentially, to the SQL database by constructing the query. And now we're going to look at what we're sending to exploit this. So this is an options request in this particular case. And we can see the sleep, OK, fine. But the most important thing is the single quote there in the SIP URI. And we're just appending and comparing the version of the SQL server. And then if it matches, it does a sleep. And in this case, it did sleep for 2 seconds, even though I'm slower speaking. And it responded with a 201 because there was some sort of error. Now, SQL injection is usually an attack that is applied against web applications, but really any application that uses a SQL query that constructs SQL queries from user input could be problematic. And Kamailio, with some of the modules, allows this. Now, in terms of recommendations, of course, strict user input validation. So, before passing the URI, check if there are only certain characters, and if not, don't allow it. And also the use of the transforms, in this case, escape.common, which is what's recommended in the documentation, did address this security problem. Of course, I don't know of database modules that support parameterized queries in Kamailio, but that would be great. That would be a better solution. Next case study, the denial of service via DNS query. So a bit of background. So Kamailio is obviously asynchronous. That's what makes it one of the things that it makes it so useful. But of course, there are blocking functions, and blocking functions that take attacker-controlled input can exhaust workers. The DNS query function from the IPOps module is such a blocking function. And if you pass, for example, the from domain if it's going to be attacker controlled most of the times. If you pass that to DNS query, the attacker could force long timeouts, especially since the attacker can control the DNS server in most cases. So let's look at the configuration. So yeah, I mean, you have just a DNS query. They're being called. And in many cases, let's look at how the attack might happen. So, and we've seen this, of course, in practice, and we've done it. So as an attacker, or as a pen tester, you would register your NS record on a domain that you control. In this example, ns1.example.org becomes an NS record, and it points to a fake name server that does nothing, okay? Does not respond to DNS queries. You might have IP tables so that you, for sure, don't respond to anything, not even ICMP reset. However, then what the attacker does is you flood the target SIP server with invalid host names, FQDNs, in the form of, random 8 characters. You change them all the time, okay, with each request. .ns1.example.org, and in Kamailio you might see something like this, right? And the thing is, these non-existent FQDNs will take a long time to fail, and then a legitimate request comes, and it will time out as well. So no response is received for a long time. And this is what denial of service is about, right? So in terms of recommendations here, of course, the ideal would be to avoid using such functions with user input, user-controlled input. But in the cases where we saw this meant that the client would have had to rewrite their Kamailio configuration logic, which is not very nice. So, we're pragmatic people, and the way to address this in reality in many cases is to just push it as down as possible in the logic, the DNS query, as possible. So you might have it behind strong authentication. You might have it also perhaps under strict rate limiting, which would greatly address this. And of course, if you can do input validation, like really strong input validation, so only good domains, but what is good domains, right, if you're exposing your SIP server. So yeah, these are the sort of solutions for this. Anyway, next case study is the open relay and amplification. And we're talking about something like this. You might have a weak regular expression. You might have no checks at all. We've seen this. And then the SIP server gets exposed on the internet by mistake. We've seen this. It leads to toll fraud. So this is just an example. But yeah, this would match enable security, but not only, but also enable security.hex.fun, which is our domain as well in this case. But it will be a bit different. So yeah, this is very simplified, of course, and it would relay to unintended subdomains or attacker-crafted URIs. And this could lead to SIP amplification, denial of service, where your SIP server becomes complacent in flooding a victim IP address, which might not respond to SIP. So there would be SIP retransmissions 10 times. So your server might not be the only one who's attacking that particular IP. So there might be hundreds of them. And then, they cause denial of service, and your server is also helping. And this might also lead to toll fraud. If your SIP server is, say, on an allow list or whitelisted or IP authenticated with a third party, your SIP trunk, it might start sending SIP messages if an attacker abuses this vulnerability. and then makes calls to PSTN, and so on and so forth. So this can be quite dangerous. And in fact, Ivan over there had blogged about this, had noticed this on his honeypot, and blogged about it. We also, of course, contributed, and we worked together on this. Because it's been abused in the wild. I don't know if it's still going, but yeah, it's definitely a problem. Out there, there are various SIP servers, most of them not Kamailios, but we've seen this in our work as well. Anyway, how to abuse this? A SIP message would look something like this, right? Nothing special. We're using options here, but if you're doing toll fraud, you're going to use invite. But yeah. How to address this? The vanilla configuration, of course, has a very good example, if not myself, but it's not always possible to just check if it's yourself. So you might need to have strong regular expressions, input validation, but you need to, before using T-relay, you need to actually validate where you're going to send the next hop. All right, so these are things that we saw in pen testing, black box tests. So in pen testing, you might have a black box penetration test, and you might have a white box. Black box is where you don't have access to anything. And black box tests often miss configuration issues, right? So attackers might gain internal knowledge. Maybe that internal knowledge gets leaked on GitHub, for example. Attackers have much more time than penetration testers. Most pen testers, they last a week or two. We take a bit longer usually, but yeah, in 3 weeks, you're not going to find everything if you're doing, or everything worth finding if you're doing just a black box pen test. So I think we need to take a different approach here. Proactive defense is key. We need to shift left. That's what everyone is talking about in cybersecurity. So taking the approach of manual configuration review and together with security testing could be really complementary. And the basic principles, right, in terms of best practices, in terms of security, is strict input validation. These are the classics, right, especially for pseudo variables that are used in the logic. Use allow lists instead of deny lists whenever possible, white lists over black lists. If you're doing regular expressions, keep them as simple as possible, and then carry them, of course. You end with a $sign and so on and so forth. And then if powerful functions, make sure that you check them out, how you're using them, especially things coming from the exec module, things coming from the SQL ops, AVP ops, and so on and so forth. All right. So in terms of tooling, what we've been doing lately is we've been trying to identify which sort of variables are actually have user input, or part of them is user input. We've then also been looking at the core configuration documentation and the code to understand which settings have security implications, and also analyzing the module functions for injection risks, especially. And injection is not the only vulnerability, but it's a good place to start from. And the idea is to document these things, but also to build a tool that does static analysis to check Kamailio configurations and highlight potential vulnerabilities. And we hope to also contribute in terms of documentation and updating the documentation with warnings. We already did that with the exec module. It was quite an obvious thing to do, but also examples as well, giving better examples. So here's a quick, very, very simple. So what you can see is, this is better than grep, right? So that's what's important here, is that you have tainting of, you have the user agent, so the variable being fed to the variable A, and this tool can actually look for this sort of stuff. So if variable C is actually coming from the user agent, so the variable, and then you want to look for usage of AVPDP query, which can introduce this SQL injection vulnerability, then yeah, it can detect it. A bit more about this tool. So we're calling it Kamailio now. So it's based on tree-sitter, which allows you to define languages. And of course, we have our tooling to search through the tree, and then for now, it acts like a very flexible tool. Okay, so it's very much works in progress, but I'd like to hear some feedback about this approach and if it's interesting for other people, so that we see what to do next with it. So a bit more about security best practices. So in terms of module usage, avoid risky modules, like exec, of course. In fact, we blogged about that so that we give practical examples of how dangerous it is. We've seen many cases, not too many, but we've seen cases where people were using the exec module to do things like creation of files and so on. This avoid that. It's better to go for things that are specifically for creation of files or for editing of certain things, rather than using touch with the exec and so on and so forth. Right. In terms of documentation, templates, and examples. So the current examples in the MISC examples, Kamailio, are not really best security practices. I think we need a bit of a community effort there to update the documentation, perhaps to include some warnings and better examples that have that don't introduce security issues. Especially since we're AI and humans, we're both learning from these examples, right? So if we want, the tools that are being used to perhaps write new configuration files to not automatically introduce security issues, perhaps we should be writing good examples. All right, so we're at the conclusion. Before I give a recap, I'd like to thank my colleague Alfred. This presentation is as much mine as it is his. A lot of the things he contributed to. And of course, Daniel for organizing this, and the Kamailio World organizers for doing this conference. It's really a great opportunity to meet you all again. And our customers who keep it interesting for us. And anyone contributing to RTC security. There's not many, but there are a few in this room. So thank you very much. Key takeaways. Almost there. Yeah, so keep in mind that Kamailio security relies heavily on its configuration. It is very possible to configure it insecurely, as we see in our work. And I think education, secure examples, and updated documentations is one way. Tools would be really great to have. Tools are always useful, right? And penetration testing, of course, is focused on configuration, is very, very good when it comes to testing large configurations. What to do? Stay informed. There's the newsletter. That's what one way that we contribute to this. Review your configurations, test, and contribute to the knowledge, collective knowledge. So yeah, questions.
Thank you. Thank you, Sandro. And thank you for your work outside of this event, of course, helping the telecom and open source world in real-time communication to get better and secure. Now, Randy, maybe you want to come in front to get the main microphone, and Sandro will answer. You have something to put, or you like slides or not? Just discussion. Do you have slides?
No slides.
Oh, okay. Then it's easy.
It's audio only.
What do I do?
Then you can use that microphone. I was thinking maybe you switch the microphone.
Okay.
Okay, questions, sorry.
No questions?
1, 2,
I think
3 questions. Everyone is afraid? Santiago?
Okay.
Okay, thanks a lot for your presentation, always great. I was going to ask you about one specific topic that you almost mentioned about the generative language models and this vibe coding, that there are a lot of production code that is starting to appear, or a lot of things. Do you think that we need to get details over this generated code about security and things like that? Because security, I think that it's learning for our documentation. If that there is an increasing of insecurities related with this kind of programming.
I didn't understand the question, though.
The question is maybe, is AI and generated code some kind of problem for security?
Potentially, yes. However, it's also potentially a solution. So, it's a very long discussion to be had. I've seen, not in the case of Kamailio configurations, I have not seen any code being generated from LLMs yet. I mean, we've done it ourselves, but not from clients. However, I've seen this in the normal other code, PHP and so on, and people are complaining about it, but also people are, for example, configuring their cursor or whatever, giving it instructions to always do a security review after suggesting some code. So, it's not necessarily terrible, but if you're only teaching it on insecure configurations, I think it could introduce it. I'm sure it would introduce security problems.
Sounds like it's good to continue around a beer
for
after,
sure,
or a wine.
For sure, it's a very long
because
conversation.
It's AI security. It's discussion
this is
here.
Thank
you, Sandro, again.
Thank you very much.
Relate. Thank you for...
We're going to talk really fast. Is this working? I can't tell.
It's on. It's on.
Now it's on, yeah.
Okay, 1, 2, yeah. I'm not going to... The guys will introduce themselves, but they're probably very well known already. My name is Randy Resnick. You know me a little bit less, except I've been to almost every Kamailio World, but it was the VUC, and it's been over for a long time. A lot of things that you do on the internet have ads, and this is one of them. The new hit by Lorenzo and myself called Reluctance. You can look it up. It's on the... Huge. So I'm actually capable of holding two completely contradictory thoughts in my head. One of them is I've been a musician paid for playing music for something like 58 years. Okay. How long have you been playing, Lorenzo?
20, 30? 30 years.
Yeah, he's a baby. But the thing, Dan, do you play?
I used to play the violin.
Yeah, oh, great.
But not anymore.
Anyway, so my comments are based on the experience that goes from recording vinyl, black vinyl, also called licorice pizza sometimes, to today, digital. I have over 300 registered compositions, and so I think I'm kind of qualified to speak for the music, for composers, and Lorenzo is too, and he's going to talk about this in a minute because we talked about this morning, and he brought up some great points that I hadn't thought of. Trying to abbreviate this and get rid of the whole Spotify thing, which is clogged right now with not great music from humans, but it's getting more and more not great music from artificial intelligence. I said that I can hold two thoughts in my head, and those two thoughts are AI absolutely sucks, and I'm sick of hearing about it. It's worse than blockchain, much worse. and all the billionaires in the world are putting money into it and shoving it into every single thing. I have had 2 experiences today with David Duffett's, remember David Duffett's demo, if you heard his demo with the AI thing, which was great, and it sounded exactly like my wife's 25-minute phone call with American Express. Exactly the same thing, getting a human after 20 minutes. I myself had the same experience about an hour ago with my phone carrier, because I was not roaming. Anyway, this is pretty sickening that they're shoving all this in our face, but on the other hand, it's great. I stood at Kamailio World in 2023 and asked a question I'm going to ask you now. The question I asked then was, how many of you have tried ChatGPT? And I think 5 people answered. Now, how many people have never tried any of those ChatGPT variations? Can you raise your hand if you've never tried one? There's one person back there. 2? Anyway. Anyway, I've been experimenting with all of these things, including music composition software. And I'm really scared because it's getting so good now. The paid version, there's a thing called Suno, the paid version, and this is what we were talking about a few minutes ago. We've both experienced how good that is. When I say good, I mean, it's just surprising. It's like a circus. It's like watching somebody, with trapeze or something. So what was one of the problems that we were talking about was the ubiquity of that music, Lorenzo? Oh, okay.
No, I mean, in general, yeah, the question about whether or not AI is great or not, I think probably both answers are equally valid, because, I mean, there are many use cases where we are all using AI today. For transcriptions is one typical example, but there's so much more where AI can actually provide value. And even going beyond our realm, I do see value in AI for critical stuff. I mean, in the medical world, I'm sure that it can provide a great ton of value, where I really put my sword in the sand, if it makes any sense, is any kind of generative AI. It really makes my blood boil for multiple reasons, one of them being what you said. So basically the whole concept of stealing everything and just regurgitating stuff to look like it's creating something is really something that I don't like at all. I don't like its approach to music. I don't like its approach to images. And I don't know about you, I'm tired of seeing all these Studio Ghibli images, clones that everybody is publishing everywhere. So I really see it, in that case, I really see it as a way to basically cheat basically graphic designers out of their job just because you want a logo done quickly or something like this. I really see it as a way to regurgitate copyright content. And I see this as a great problem for the future, because right now all these things, including Suno and others, look great, and even the Studio Ghibli images, as far as I hate them, they look great as well. But that's only true because there was real art in the background that it took from and it stole from. The problem is that once everything is AI-generated content, then the new AIs will start using that as ways to learn what comes next. And that's where I really see the flattening of creativity happening, because basically that's what will be the standard for everything in terms of media, content, whatever, ads, marketing, whatever. And I see this as a big problem. As a tiny creator, I see this as a big problem.
Right. Dan, we're going to get to you in just a second, but I just wanted to say the other side of artistic creations, which was the graphics thing, which I jumped on. I created a bunch of album covers because I don't have $50 to give to an illustrator for a thing that's going to maybe with luck earn $3. Okay, so I'm not going to do that. Now I'm using photos, and I've changed as many as I can because the reaction of people in graphics has been to say it's negative is, they are expressing themselves. And just to finish, they have a solution, and I don't know how they're going to implement it, and that solution is called the 3 C's: consent, credit, and compensation. Now, and you can do this today, by the way, if you're an artist, by joining one of these databases and saying, yeah, use my Lander, for example, a distributor. You can tell them, yes, use my work, and they will pay you for it. However, no credit. But at least there's consent, because one of the main complaints about the artistic thing is consent. Now, if we switch this over to programming, coding, and so on, it's a little bit different, because you in the open source world, you're already having your libraries out there that are being used by a lot of people. And I remember one complaint was somebody was saying that the library was used, but they removed the comments and made it look like it was their own. So Dan, let's hear your take on this stuff.
I mean, very, very quickly, going back to creative stuff as well. There's something happening in the UK around laws around consent and how potentially they're going to make it opt out, so that you have to tell all of these AI companies, I don't want you to use it, rather than the other way around, which I think is shocking, but it is what it is. But yes, going back to code, AI, open source. I mean, I'm very, very lucky in the sense that I don't have any big open source projects that AI is scraping. I have lots of little projects, and I have lots of, I've helped other projects. Whereas, Lorenzo, you were telling me the other day that an AI bot was scraping the Janus docs and the GitHub code, and creating these professional-looking websites that are meant to help people, but all of it was pretty garbage, because real-time media isn't easy, right? This is why there are only so many people in the world actually doing it. I came from a web background, and it took me a long time to really figure out SIP. David Duffett, 20 years ago, it's a long-running joke between me and David. 20 years ago, David helped me. But no, it is scary. But at the same time, we as the people, going off and building things with AI, whatever AI is, whatever your definition is, we're the ones that have to be responsible, right? So we can't just go off and build websites that show off crappy code and tell you, oh, this is the way to do it, and it's completely wrong. There's got to be there's a trust relationship there, right? You can't just go and, I mean, some of these websites, like Cloudflare, have added an AI bot detector, and then it will chuck the AI bot down a rabbit hole to protect people's servers, because they're getting completely and utterly attacked by AI bots that are just going over and over and over the same content over and over and over again with no real purpose.
Isn't somebody doing poisoning too?
Poison, yes. Yeah, people. So it's not just rabbit holes. It's here's some crappy content and it thinks it's real, which inherently goes back to what you were saying earlier about the fact that, well, when AI is looking at AI-generated content, where is the world going to be, right? Do you want to add anything, Lorenzo? You've actually had real experience of this.
No, in general, no. What you said was basically a good summary of it, because basically there was this, I don't even remember the name of the project. I got a mail that said, probably a mail generated to a lot of GitHub repos that said, I created this agent that basically answers questions about your project. It will be a great help to people and everything like this. And basically it was just something that had scraped all the content and created an automated agent that answered on it. I created a quick summary out of the docs as an introduction, and then you could interact with it by making questions and stuff like this. So, of course.
There is not just the creativity like artists and the coding. If you look at the social media, there are so many AI bots on the social.
It's on.
Okay. Yeah, there are so many AI bots. AI bots answering each other. You probably have seen those clips like Siri and Alexa are arguing with each other. What? I mean, so I think it's the use of technology is going wrong way. It's a good technology. For example, with AI, I have done a lot of good things. As a programmer, as a coder, it really speed up me writing the code, because there are many parts which are similar or repeated, and I don't have to write them, and it automatically generates. Okay, you probably want to repeat this for next carrier, if we are matching carrier and so on. So it's really good if you use it wisely. But if you just want to earn a quick buck on the expense of other person's hard work, then it's really bad. It's a person that is bad, not the technology.
That's true. It all depends on what you do with it. One other comment I have that I was talking to Lorenzo earlier about is this, and this is why I can see both sides. As I said, I've been in music for almost 60 years, and I'm pretty good at it, actually, but where did that all come from? It came from me listening to music for 60 years, and then there's stuff in there that comes out. Now, I think most of what I've done is pretty original, unless I'm trying to be some kind of particular idiom. And it's true, too, of coding, because I'm a horrible programmer, the worst. I mean, if I coded, used to use PHP, my stuff was totally insecure, but, it didn't matter with what I was doing. But the point is, how did I code if I don't know anything and had no education? I just looked for libraries, and I looked for examples. When I was doing asterisk dial plans, what did you do?
You went to voipinfo.org,
right,
and you copied stuff from there.
You copied stuff from that, yeah. And it's the same with music, and it's the same, frankly, now most artists won't admit this, but it's true for art too. I mean, graphic art. You study stuff, you look at it, and so coding's similar. But the big difference, and I'm going to land the plane right now, the biggest difference between AI, between so-called artificial intelligence and human intelligence is speed. Because in the case of writing a song based on here's a line of lyrics and here's the genre I want, it took 15 seconds for the website, plus with the latency of the web and everything, it took 15 seconds to generate 2 versions of a song that was totally believable, with lyrics that rhymed and that were coherent and made sense, told a story, idiotic story, because that's what I put in there. And the chord changes were right and the vibe was right. So it's just mostly a question of speed. It would take me maybe, I think I once wrote a song that took an hour, okay, but still, that's how many times more,
But who owns that song, right?
What's that?
Who owns that song that was generated?
Who owns it?
Yeah.
The company owns it because I didn't pay, but if you pay $8 a month,
it becomes yours.
Yeah, you own
even though the AI generated it.
Yeah, and
right.
it is copyrightable, apparently. That's all being discussed now.
So on the whole open source thing and code, I want to encourage everyone, if you've got an open source project or something that involves documentation, there are things that we can do to actually put documentation in the right format for LLMs and AI and scrapers and to make it so that they don't bring down our websites with crappy scraping. So there's that. And then going back to your ChatGPT question earlier, please raise your hand if you have, who in the room has vibe coded? And vibe coding definition is literally just talking to an AI and having it make you something, and you are not thinking, you are getting the AI to do it. You are thinking enough to be able to prompt the AI, but you're not going in and changing code. AI is doing 99% of it for you. How many people in the room have done it?
So I just asked it for a script in Python to automatically post on Twitter, and it generated it in a second, and it worked, except that Twitter no longer accepts it.
Right, exactly. That's an interesting, I wonder what that number will be in a year's time. Maybe 3 months ago, I wouldn't have imagined just talking to an AI and iterating on code just via talking to an AI. But I built a whole project. Pardon?
You don't need to do anything. You keep iterating.
Yes, you keep iterating on it.
You instruct him to iterate
Until they get it right, but at the same time, yeah, you got to keep pushing it until you get what you want. But at the same time, I'm not going in and changing this code. I'm telling it, oh, you got this wrong, and it changes it. I built a whole project the other day just by vibe coding. It's not a project I would put in front of a client of mine. It was a fun project to do, but I did it, and it did 99% of the work for me. Sure, I wrote some prompts and I did some voice prompts, but the fact that you could be, in a queue in a shopping market and talking to an AI and it writes you a project for you, and then when you get home, it's already deployed. That's pretty cool.
Who else would like to chime in real quick here? I'll bring the microphone over. Anybody? David. While he's going out there, I just wanted to mention that I watched Law and Order, the most recent episode, which was, do you know what I'm talking about? The episode was about a kid who murdered his father after having a discussion with a therapist, licensed therapist on Instagram or something. Go ahead, David.
It's a philosophical question, and that is, we hear a lot in places like this about tools that allow web developers to use telephony without understanding too much about telephony. So what's the difference between that and putting a tool in the average person's hands that allows them to make music?
Does anybody have an answer to that?
I mean, I feel this very much targeted at me, David. But I'm not a web developer anymore. No, I don't know. I mean, if you can, yeah, great, good, because I was going to waffle.
Very short answer. Responsibility. Who is actually means if you have some company who is providing you the service, you can always pinpoint. With AI, like go ask Microsoft, go ask OpenAI. Means why the answer was like this. Responsibility.
Somebody's phone. Well, a big thank you to Daniel again and to the participants, the brave participants. Nobody else? Anybody? Comments? We're kind of short, but hey. Let's get.
Sorry, but I just want to add a question because a couple of weeks before come here, I was also discussing with another musician about this Gilby stuff and so on. He defends that it's the vibe of the music what is copied. Okay, as in the art is the style of what is copied, and also in the code is the previous example what is copied. So when we say that AI could kill the creativity, I think that not. So I think on the opposite way, I think that they will spread a very massive plane wave of normal stuff that should be relevant. So in that place is creativity, I think that they give a specific insight. So because we have a capacity of as humans that we didn't implement yet on artificial intelligence, that it's to bring creativity to something completely new. And my belief is that they are not really there. So I think that it's a complete paradigm change, what we are focusing here, like the new release of Daniel that I saw. It's something new. It's something that we need to adapt. I think that it's something that also provides another competitor to our spectrum. But yes, I think that it's needed to bring easier fields for anybody to join. As for example, if you don't know anything about voice over IP and then you join a company that builds half a product as web and other part as voice over IP, I think that it's interesting to bring easy tools to keep going. So, but it's something to discuss.
Yeah,
after that.
That's why I was saying we know that the humans are more creative after some wine beer. What if the computer start drinking, and then what will happen with AI there, right? So yeah, maybe the last question or point, not too delayed. We are a little bit delayed, but if not, in like you want to, we are.
Just as an example, for example, my son.
No, it's not on.
Okay. So just an example, my son is in 7th class. He know no coding at all. You know, he's just a school kid. And my brother, he's a web developer. He's working there for like 10 years and so on. Very experienced in this and that. So I told my son that your uncle is web developer and it's very difficult. So you should start learning so that by the time you finish school, you should have some experience. What he did, he go to Manus AI. You have heard the Chinese one, and he asked it to create a website to sell the headphones, and he literally created it within an hour and so. And he said, "What's so difficult about web development? I made it in just 1 hour, and I only need you to pay them so that I can download the code and host it on some server. So it's there." So
but then it's more than just the kids say, because you have to integrate it with payment API, with stock management, and so on. So yeah, when you look at a web page and see some pictures, some fields there, actually it's a lot of work behind. So probably that AI was generating.
No, it was completely with PayPal and everything. You just need to set up PayPal, and it was linked behind the scenes with Alibaba or some market, and it will order it. It's kind of drop shipping, and
but you're gonna trust it that
no.
Because it looks like, and you'll still have to check this, because if you go into some
exactly, it looks like a complete website, but it should not go on public, because there must be some bugs, or it could be missing.
Yeah, could be worse. Okay, then Randy, thank you. We'll have drinks and dinner and cocktail, food, finger food. Well, it was the lunch, the same area, so we have a bit of time to maybe get some fresh air. What would be good, if you can take your glass and put it outside, would be easier to clean up as we are a bit late. If you don't mind, if it's